Anyways, Jedi,
So
are you away
is
from
this
your mic?
is this a chat? What is this channel about?
This channel is about the flat Earth that we all live on, and today we're talking about geometry and science as it pertains to the Earth.
So are all the planets flat?
I don't know. When I get my telescope out and look at the planets, they seem to be circular at very least. So I would say, um, they are circular in nature. They could also be flat because round and flat are not mutually exclusive. Like you could have a coin or a CD, or a pizza. They're kind of round and flat. So those two things are not mutually exclusive. Do you
Okay.
mean spherical?
Well, you know what I mean. I'm not going into the terms because I don't know the terms, but yeah, like round, like everyone else believes, and flat, that
Like a
small people.
ball?
Yeah,
Yeah, like a ball. Yeah, no, I have no idea whether or not the planets, that being the wandering stars above our heads, I cannot determine one way or another if they are spheres. The Earth, though, is objectively flat and stationary.
and why they say that it is otherwise?
I don't know. I could make some speculations, but I ultimately don't know their motives. I don't
What
like to
what
try
would be
and
those
read
speculations?
people's minds.
What would be those speculations?
Well, like I said, I don't like to speculate, especially in this channel. We're only trying to talk about what is objectively true, what we can measure, what we can test, especially empirically, dealing with the physical realm around us. So in this case, we measure the Earth, and when we measure it, it measures to be horizontal, flat along the surface, no curvature consistent with the globe told to us while we were, still in diapers in some cases and through our schooling as children. That entire concept has been debunked by the measurements of the surface.
All right, and does gravity allows you for a flat Earth?
Well, we've also checked the claim about gravity, right? Because then we would supposedly be jumping into physics, right? And that would fall under the category of science in here. So, physics, there is no physical mechanism that we can detect or determine that would be anything like what is described as gravity. There is no gravity as far as physics is concerned.
And what keep us in this flat Earth?
Nothing, as far as I know.
So why I am attached to the ground and not floating?
Why would you be floating?
Why would I not be floating?
Well, that's a burden of proof reversal. That's, I don't want you to ask me a question. If you say we would be floating, I would want to know why we
Wait,
would float.
but then I ask you a question and you ask me a question as an answer, and then I just did what you did to me. I'm
No,
just
you
here
asked
to
me, why
learn.
are we being held to the surface of the earth?
Well,
And I
I'm
said,
not
as far
here
as
to
I
give
can tell,
answers. I'm here to
excuse
give
me,
answers.
sir.
I'm here to
You asked
learn.
me, why are we being, dude, you asked me why we were being held to the surface of the earth. I said, as far as I know, we're not being held here by any physical force. And you said, well, then why are we not floating? That
Yeah.
tells me that you think we should be floating for some reason. Why should we be floating?
Why we should not be floating? I mean, what keeps us attached to the ground? Why does a table doesn't, why I'm not connected to a table the same way?
Let me ask you a question. I can tell you that there are certain times on the earth when I do float. You want to know when that is?
Yeah.
When I go into a different medium, let's say water. I float when I'm in water.
You float when you're on water?
Yeah, don't you float when you're in water? You ever been swimming?
Yeah, but what do you mean by that?
I mean that I can float in water and I am not being pulled to the surface of earth. That would be the ground beneath me. I float at the surface.
Well, the density of your body is not that strong to pull you to the ground, so the water just push you out.
I don't know that the water pushes me at all. I just know that
If
I do float in water.
Well, if you didn't have air in your lungs, you would just sink in the bottom of the sea.
Right. And as you described earlier, depending on my density compared to the density of the medium that I'm in, I may go up or I may go down. And yet everything that you and I have both described right now, gravity is no part of it.
How is not? You haven't explained why I just don't fly and I'm just attached to the ground.
Whoa. Why would you fly?
Well, why would I not fly? What does it keeps me to the ground? Well, this is what I'm saying. What
Nothing
keeps me?
is Nothing's keeping you to the ground. As far
Well,
as
I
a
can't
physical
fly.
force or anything like that, there is nothing keeping us to the ground. There is
But
no sentient being or force that we can detect called gravity that is holding us to the surface of Earth.
but you have to explain when I jump why I get back to the ground.
Oh, well, then you've instantly created potential energy. See, when you're standing on the surface of Earth, you're at rest. So there is essentially no transfer of energy. Now, when you jump, right now there's energy input into the system. Your muscles contract, you burn a few calories. Now you move from your state of rest and go up into the air. Now you have potential energy. And
Right.
since you're in the medium of air, you're going to return to the Earth. But if
Why?
you
Why
jump
is that?
into a pool, huh?
See,
Why? Because the air
how do
cannot
you
support you.
explain? How do you explain why I
Brother, I'm
have
telling you, can you let me explain? The air cannot support you, but the water can.
the water? I told you the water can't support you if you don't have air in your lungs.
Right. Well, how about a piece of wood?
The piece of wood probably have air inside. It should be solid.
Exactly. So it is a relative density relationship, isn't it? If the object is less dense than the medium that it's in, it will have an upward vector. If the
Well,
object is more dense than the medium it's in, like you and I or a piece of wood in air, it will go downward. So you have two different vectors, and the only thing that we can describe is that there is a relationship between the density of the object and the density of the medium, and that basically determines whether or not something will go up or down. And no
well,
gravity is involved whatsoever.
if you remove the air, I will still go down. I mean, we have vacuums in the
Oh,
air.
Yes,
okay,
I
let's use a
know.
rubber ball. How about a rubber ball? A solid rubber ball.
What?
A solid rubber ball. It's not going to go down, is it? It's got no air in it.
What is a solid rubber ball? I don't know.
Like a bouncy ball, like the bouncy balls you get when you're a kid out of the little machines. Right.
Yeah, so what? Yeah.
Yeah, so it doesn't have any air in it. So you can't use that as your excuse now.
I don't understand what you're saying.
Seisu's explained it to you perfectly, right? And you're just using the remove the air. You're saying remove the air and it will go down.
Well,
But no, it's
I'm
not.
saying remove the air because it's not the air, guys. It's not the air the point.
We are not saying that the air is anything. We're saying that the air is a medium, right? And so the medium determines what happens with the object within it. So if you go, let's say, in air, the wood block goes down. If we take most of the air out of, let's say, a vacuum chamber, the wood block goes down. If we change the medium again and fill the chamber with water, the block goes up. So it's always dependent on the relative density between the medium and the object. There is no gravity. There is no force of gravity. No one has ever proven a force of gravity. It is just a concept. And currently, it is only a mathematical concept, meaning it's not even a physical proposition.
Well, I understand what you mean, but then there is something that pulls object, like even me as a body
Okay.
has some sort of attraction to the other entities, but it's so small that I can't really attract them. And then that we call gravity. I understand that we haven't like defined it, but then there is something
Friend,
that's called gravity. This is what I mean.
I
Like,
don't want you to
is
ramble and
this
make many
accepted term?
claims. I want you to, friend, don't make claims. In this case, we're talking about science and physics, right? So what I would like for you to do, instead of making the claim over and over again, is to prove to me the mechanism by which you go downwards. How are you going to prove that?
Well, I told you, like everybody, like when it is has a high mass and has some sort of attraction, like this attraction, I think we call it gravity. I'm not a physicist, but this is what I've learned.
Yes,
So
exactly.
even a small, yeah, even a small body, if I were very 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 tiny small, then I would attract something else. And this
That's
is
not
what
true.
we have.
I'll tell
What?
you why we know that. That's not true because gas, right? The molecules of gas, the small particles that we call gas, the stuff that we breathe, moves
Well,
freely and randomly in all directions. It is not attracted to anything.
well, this is quite different because when you have tiny masses, I guess a gas will have a tiny mass. Then I don't know what happens there. Like, I mean, I'm not a physicist. Maybe this is something that, like, probably is not. The force is so small that it can't really get, pulled or attracted to anything.
Right. Now you're saying probably. So actually, you're telling me that you don't even know if this has been proven. Believe me, we've checked. There is no evidence or proof of any kind of force that is determining someone's vector up or down in the realm that we live in. And the reason that we know that is because gas is omnidirectional as far as its vectors are concerned. It moves freely and randomly in all directions. It is not attracted to the ground. It is not forced to the ground. Gas
Well,
debunks the idea of gravity completely.
I ask something. Why is Earth attached, or like why it is like I don't know what flat Earth people believe, but like is the Earth or the Sun the center of the system of the how's it called the system? Yeah.
Oh, I have no idea. To say the center means that it'd be the focal point, or that's kind of a weird question. When you say center, what do you mean?
I mean, does the Earth moves around the Sun or the Sun around the Earth?
Well, what we observe is that the sun moves across the sky along with all the other celestial bodies from east to west. So it seems that the celestial bodies move, although I'm not sure that I could consider the Earth to be a center point.
It's not the center point. So, but is the one like is Sun moving around the Earth or the Earth moving around the Sun, or you haven't defined that?
Well, the observations show us that the sun transits the sky in a east to west direction. And of course, in the extreme north and the extreme south, it seems that you can see the sun do circles. But that still wouldn't necessarily tell us that the Earth is the center of anything.
Who did these observations?
Many people over the last, well, I mean, since, the beginning of mankind, the sun has come up in the east and set in the west for everybody. And in the extreme north and apparently now the extreme south, the sun does circles in the sky.
Are they scientists or are just experimental?
Well, what would it matter? That's what we observe. The scientist is going to observe the same thing that I observe. They just have a PhD attached to their name.
Well, isn't that important? I mean, I'm not.
Not really.
How is not? I mean, I can easily make wrong assumptions or like wrong calculations if I'm not expert to the field.
No.
I'm not saying
no. You can't make assumptions and you can't make calculations. You can only make observations. The scientists and I both have eyes. We both see the same thing. And if we're going to be empirical about what we observe, then we will attempt to prove the cause for what we see. But him and I both have the same problem. We don't have access to the sun, moon, or stars. So we don't really have a great way to prove one way or another how or why they're doing what they're doing.
The bodies. And what do you think about the rest of the world, the rest of the people that believe that, this is why they move, this is why the Earth is round, and all the occasions that, like, they can prove that a comet after 30 years will come back at some point in the future?
What do I think about them? I think they're well, number one, if they're observing the same thing that I'm observing, but they have a different conclusion, I want to know why they're getting to the conclusion that they have. So far, all I can figure out is that they are under a delusion that they live on a ball, and then they make all of their assumptions and calculations like you just described to me based on that assumption that they live on a ball. And so they've created a mathematical realm where Earth is a ball and the sun, moon, and stars are all planets, and we orbit, and yada, yada, yada. You know the solar system story, along with the rest of the universe. Hold on, bro, I'm not done. So all of their assumptions are based on their delusion, when in reality, the Earth is measurably flat. So their assumptions are false from the beginning.
But then the language of the universe is mathematics, and there should be only one truth. And if they
Yeah,
can prove,
I agree.
they
So if we
create
measure the Earth, hold on,
let
bro.
me finish.
I agree with you completely. So if we measure the Earth and it is flat and there is no curvature, then math, being the language of the universe that you discussed, is telling us that we live on a flat Earth, right?
I think they have already done that. We have already.
Okay, so
we have sent.
Great. So that's fine. So can you go ahead and get me the Earth curve measurements on the surface to prove that we have roughly 8 inches per mile squared of drop over distance everywhere across the surface of Earth? Can you get me those measurements?
I told you. Well, see, I need a team of scientists. I can't do it myself.
Why? No. I'm saying somebody at some point has measured the surface of the Earth, right? So you don't have to do it yourself. You can find out how somebody measured it, and if they did something that is easily replicatable, we can all go do it and check. But so far, we have not seen any measurements of the surface of Earth showing that it curves.
Well, what about all the photos? I don't agree with what you said just now, but I'm just saying.
Oh, you don't agree that somebody has measured the Earth curve? I agree. Nobody has measured the Earth curve. Now, the photos and the videos that you're appealing to, if they're showing an Earth that is curving, then we should be able to measure the surface and see that it's curving, right?
Do you want to Google that? What you just said? Just ask Google or ask an AI agent. And
why would I do that? Why would I not measure the surface of the Earth? Why would I ask Google to tell me what's true when I have the Earth underneath my feet and I can go measure it?
When you buy stuff from a supermarket, do you ask why there is a milk or who? Like, do you just buy the milk, right? You just
That's non sequitur. That's a complete red herring, and it's not even analogous to what we're discussing. You stand on the surface of the Earth, do you not?
Do you step on giant salters? So this is how science works, doesn't it?
No, it's not how science works. That's how someone told you that science works and you believe them. But in reality, you have access to the Earth and you also have access to the technology. Excuse me, you have access to the technology to measure the surface of the Earth. You do. Why haven't you done it?
I'm telling you right now that if you Google that, if the curvature of the Earth is measured, there is 100% chance.
Okay.
100%.
100% chance. Okay. I'm gonna give this challenge to you. You say there is 100% chance, meaning there is an absolute certainty that if you Google who has measured the surface of the Earth to be curving, that you will find that somebody has done that. I'm going to challenge you to do that. Not calculate, not assume, but measure. So I want you to get me the measurements of the surface of the Earth, who did it, how they did it, and how can we replicate it to check and see if it's accurate. I want you to do that.
No, I'm the challenger. You have to do that.
No, brother, I've already done it. That's the problem. All of us here have already Googled what you're asking us to Google, and it's not there. But if you are so confident, and this is your positive claim that there's 100% certainty that I'm going to find this information, I want you to do it.
No, I'm the challenger. I know. I've already.
No, this is not about challenging. This is about you making a positive claim. You have made a positive claim that if you Google who has measured the surface of the Earth with 100% certainty, we will be getting an answer. I want to see the answer. I want to see the method. You do it.
No, you do it because I believe that. You are the one who doesn't believe.
I don't care if you believe it. I want you to prove your claim.
But I want you to prove your claim.
I already did.
You haven't. You're just a person who talks. I don't even know.
All right, no problem. Do you want measurements of the surface of the Earth? Do you want me to get you some survey data? The people that measure the surface of the Earth every day, do you want their measurements?
Well, scientific proof, not just, me and you, or I don't know if
this is not as okay. So the event for the day, we're talking about science and technology. Measuring things is not science. That would be mathematics. Okay, so this is not a scientific topic that you are currently discussing with me. This is about measurements. Okay, so we're not going to be trying to figure out the cause of an effect like we would do if we were using science, right? This is not science. This is geometry.
Well, this isn't geometry part of the science, and also I think that
That would be a composition fallacy. Even if we did use geometry within science, that is, the parts of the parts do not make up the whole. So that's a composition fallacy. Science and geometry are two totally different things. In this case, we are dealing with geometry only.
I believe that a scientist, and this is true, can use geometry in his observations.
Yeah, I already covered that, bro. You're repeating yourself, and I don't care about what you believe. I want to see what you can prove.
Well, you can't prove anything of this, so you are talking like
Sure, I can. What do you want me to prove? How about this? I'll give you some proof. You ready?
Yeah.
And we'll see if you agree. Would you agree that water is level on its surface when it is at rest?
Water is what?
Level.
What's that? I don't know.
Okay, so level, if you haven't come across that word in English yet, it means straight or flat, having no part higher or lower than another. Like if you were going to build something, you would use a level, right?
Okay, so water is what, at level, at rest?
Yeah, so the surface of water, like, the glass of water in your cup, is it flat, level, horizontal across its surface?
In my cup?
Yes.
Yeah.
Yeah, okay. What about in your bathtub? Is the water in your bathtub, is it flat and level across the surface?
It depends on the structure of the bathtub, right?
I'm talking about the surface, man. Are you telling me that somehow the surface of the water in your bathtub is not straight, flat, level, horizontal?
It depends on the incline, but
No, it doesn't.
Well, how if it is a little bit, it's not the same height or
the surface of the water.
Brother.
Well, if
Hey, brother, real quick, brother. If you take a tray that you make food in and you fill it with water and you turn it diagonally, what happens to the water?
Goes down.
It runs out. So there's no such thing as sloped water, brother. Water's flat on the surface, homie.
Well, I'm sure if you zoom and you go to quantum level, you won't really have this observation. But yeah, me as a human, because I'm a human and I have an eye, I'm not like a robot. I'm sure I can see it as a flat.
Yeah, you can, because that's how you see it. It's how it's observed and measured. Water is horizontal, level, flat upon the surface. We don't need to talk about the quantum level. That's irrelevant.
How is it relevant?
Right, because we're talking about the surface of water over distances of tens, hundreds, thousands of miles.
Well,
it's not on the quantum level.
What are you like? How are you checking this surface? Are you checking with your eye, or are you checking with a microscope? How is it called?
We're checking with optics. The human eye. You asked a question. We're checking with optics, the human eye, telescopes, and then we measure and survey with surveying tools like lasers and theodolites. We survey the land with surveying tools. Why are you speaking through me?
I don't know where.
In the side chat, my friend, being as you decided to speak through me, you might as well read what I've posted with regards to water being level upon the surface. You noticed our citation from such places as physics.info. Now, please read those. I have many more. Sorry, says who, mate? You carry on.
No, you take over. I got to take care of something. Thank you.
No problem. So I've also posted some other citations in the side chat. I'll read them to you. Water will always form a flat surface unless it is acted upon by another force, such as wind. That comes from the National Air and Space Museum. Science in pre-K. Do you want me to read the other ones out to you? You understand, because we're not talking about on the quantum level. We're talking about the surface of water over distances.
I'm sure that if you zoom enough, the surface is not really flat.
If you zoom in enough, we're talking about the surface of the Earth, my friend. We're talking about where it should measure to have curvature because it's a planet, a sphere. We don't measure the curvature where it should be. When we measure the surface of the Earth, we measure the surface of the Earth, primarily water, to be horizontal upon the surface, which is contradictory to the Earth being a sphere. A sphere would have a curvilinear surface. We don't measure that. We measure it to be flat. Now, primarily over water, not on the quantum scale, not if we zoom in with a microscope, over distances that should show curvature.
Okay, don't know what
You
to
notice, you notice this isn't scientific evidence. This is direct measure of a shape. This is geometry. Observation and measurement are required for geometry.
Okay, but have you tested a big enough object to
Yes.
measure?
Yes.
Like a big enough as
Yeah, so I'll give you an example. With the radius that we're told of the Earth of 3,950, we should have a rate of change of slope on the surface, that's curvature, a calculation of approximately 7.98 inches per mile squared. Let's keep the number simple, 8 inches per mile squared. That means over the first mile, there should be 8 inches of descent from point A's horizontal. Over 10 miles, there should be 66 feet of descent from point A's horizontal. 20 miles, 260 odd feet of curvature descent from point A's horizontal. Now we're measuring over those distances, 10, 20, 30, 40, 50 kilometers, where there should be curvature on the Earth according to the claim in the mathematics. But there isn't. When we measure with surveying tools, like I said, primarily with lasers or theodolite, or other light or observation equipment, we measure the surface of the Earth to be horizontal.
All right. And let me ask you, why do you think the rest of the people believe that it is round?
Because just like you got taught this. You didn't question it. We just got told it at school. We turned on the TV. So we all got taught this. The funny thing about being children is you accept the reality of which we are presented. And that's exactly what we did. We were presented with a globe and we didn't question it.
And okay, I agree. But then why?
I don't know, dude. My claim is as far as the surface of the Earth, I can't divinate the motives of individuals or groups that I've never had met.
But wouldn't that be like unreasonable? Like, why would they?
So unreasonable for me to not divine people's motives and intent if I haven't met them. I think that's perfectly reasonable.
I mean, there should be a reason, though. And
yeah, there probably is a reason. I just don't know what it is. I might be able to speculate, but I don't know with 100% certainty. I don't even know who they are. It's not you, right? It's not my school teacher, right?
Fair enough, but we do know some people. We do know some people in the past that posited the idea that the Earth was a globe before they could possibly have known it, and they were religious. They thought that God is perfect. God would create perfection. Therefore, the Earth must be perfect. Therefore, it must either be a ball, because a sphere is the perfect shape, or a testicle, because a testicle is, the embodiment of divine creation, or an egg, which is also like divine creation or life. So it had to be in the shape of a ball, either an egg, a sphere, or a testicle. Yeah, that's what they thought. So we know why they thought it. And there's other people that are in record saying why they thought it, right? So we know at least why they did. Kind of like a tradition, People start thinking about something, they start telling other people, hey, this is the reasons. And you're like, oh, those reasons sound pretty good. I'm going to agree with you. And then eventually enough people are like that till they say, hey, we're going to make an education system and force our kids to learn what we all agree on. And so then all our kids are just going to believe it. There you go. That's how it happened, brother.
Guys, I have a question for you who believe that the Earth is flat. How would you describe the sun movement?
Pardon? Can you say that again, please?
How would we
How would
describe
it's
the sun
described-
movement?
Well, it can be described depending on your perspective, right? So
From east to west.
mathematically, it's described as an arced path, but there's no way to prove that it would be an actual arc.
From east to west. That's how I would describe the sun's path. Comes from the east in the morning and goes towards the west in the evening.
And what about the south and the north?
What about them?
Why you say it moves only in two directions?
Because that's how these things are kind of defined, right? East is defined as where the sun rises. West is defined as where it sets. You asked us how we describe the sun's motion, and it's as simple as that. Now you're asking about north and south. North and south are absolute directions, let's say, north, right? Now, east and west would be circles, I think, around those poles. So not absolute directions, just directions of travel.
Or are you asking about in? Oh,
No, you can go ahead. You're good. Don't worry.
are you asking about the relative difference in the direction of the sun, whether you're in the north or the south?
Yeah, that's right.
Yeah, well, those are relative directions based on your location, but objectively, the sun goes from east to west.
I don't understand how that works on a flat Earth like model. I guess.
Well, there really is no model, but it doesn't really matter what a model would say. Everybody observes the sun to go from east to west.
Well, I guess what I'm saying is it doesn't seem to be something that's possible if the Earth is a disk, right?
No one
Because
said
what
that
we
the Earth was a disk.
Well, like you know what I mean, like overall, generally flat and not a round sphere, you know. So like,
Right, so you have a flat surface, and the sun goes from east to west on that surface.
do you mean like it spins around the flat surface? I don't understand what that means.
Nope, I didn't say that either.
Can you clarify? I'm misunderstanding.
The sun goes from east to west over our heads on the Earth,
Like back and
as
forth.
observed. Nope, didn't say that.
So, okay, I'm trying to make you like give it like if you could do an illustration for me. Maybe I'm not.
I'm
understanding.
giving you the observation that we all have. I'm not going to, create for you my concept of what the Earth may look like and what the sun might be doing. What we do observe is that the sun goes from east to west for everybody.
Yeah. So I agree with that. Okay, what I'm saying
Okay.
is, if I have like a round Earth perspective, obviously, and what I mean by goes from east to west is obviously the Earth spins around, and then we see the sun like quote unquote travel to east to west, right? But what I'm saying is I don't really understand how that would work on a flat model. That seems to be not possible to me.
Let's put it this way. It's not necessary to understand how that works. It's what we observe. How it works would be a different question completely, meaning we would have to have some kind of mechanism or an understanding of the system itself and how it operates, how it's powered, what these things are in the sky, like these lights, if they're physical, if they're holographic, all that stuff. We have no idea about any of these things. What we do observe is that the sun goes from east to west over a flat, stationary surface. That's what we can measure. That's what we can observe. The Earth is measurably flat, so the sun is going from east to west on a flat surface.
Sure. Okay. So maybe I'm not being clear, right? So what I'm saying is, presumably speaking, if you have two models, let's say you're trying to choose which one is most coherent, a flat model or a round model, and let's
Fair
say,
enough.
yeah, and let's say what you're trying to do is we're making some observation, right? Like the sun goes from east to west. I agree. Presumably speaking, we would agree, right, that to find out which one is more likely, under this specific thing about the sun's movement, at least, you would see, okay, is it that that one of them is, like, for example, impossible, or you would have to make way more assumptions, right, in order to actually find it be consistent with the model that the sun actually moves from east to west in one.
I agree.
Other, right? Yeah. So that
I agree. So the easiest way to determine that is to measure the surface of the Earth to see if it's curving or if it's flat. That way we can eliminate one of these concepts. So we've measured the surface of the Earth. It is not curving. Therefore, the concept, or in the way that you described it as a model, that model would be incorrect.
Sure. I guess we can move on to another reason if you want, but what I'm talking about is not like whether or not the model would be consistent with some other fact, like the measurement of Earth. Right now, I'm just talking about like the sun's movement. Like, we're talking about which one of those facts are consistent with it. But if you want to move on to like, oh, go ahead.
Well, in the concept, and I'm not even going to call it a concept, in the reality, the Earth is measurably flat, and the sun goes from east to west over the surface. That's what we can prove. So in that concept, if you want to call it that, that would be the one that is correct.
Okay, I guess if you want, we can move on to that. And I've just asked, like, how do we see like the Earth is horizontal? How do we measure that?
We measure across the surface of water because it is our greatest and easiest way to do. The one claim is that the gravity is pulling the water towards the center of the presupposed sphere, and so that water is essentially equidistant from a center point, and so it is as round and consistent as the surface as you're going to find on the Earth. Well, we measure across the surface as big a bodies as water as we can find with the most expensive lasers that we have, and it is measurably flat. It is parallel. The surface and the laser itself, the separation of the beam and the surface, there is no deviation, so they are parallel. The Earth is flat, measurably so.
Can you show me that?
Sure.
Paper or something?
Although I never have it at the ready, so if somebody has the 40-kilometer laser test,
Yeah, I can grab
faster than
that
me.
quickly.
Thank you.
Gotcha.
There's also a 100-page PDF document with all the data, measurements, specs, distances, all that stuff along with it if you want to read it.
You understand the principle, right, of the laser test and how the water underneath the laser would have to be curving at a specific rate if the Earth were a globe.
Well, it would just have to be curving on average at any rate, right?
Well, yeah, it would be at a rate which would be consistent with a globe that has a certain radius value of 3,959 miles.
Well, I mean, we're not talking about the radius. We're just talking about whether it's round or not right now. So I don't think that matters. We're just talking about whether it has a curve.
That's what we're testing, right? So we're told the exact size of it, so we can calculate exactly how much curvature there's going to be over a given distance.
Yeah. Okay. Hold on. What I'm saying is, presumably speaking, if there's any curve, let's say the curve is such that the Earth will be quote unquote double its size than purported, right? That would still be like a round Earth, right? So that's just what you're trying to talk about right now. I don't know the exact diameter of the Earth.
Right. So here's the test that Seisu wanted posted in the side chat.
What is this, a YouTube video?
Yeah, it's hosted on YouTube, right? It's YouTube's just a platform that people can post videos on, right?
Yeah, that is what YouTube is. Do you have like is this like in a peer-reviewed journal or something, or is it just a PDF?
Yeah, there's a 180-page PDF to accompany it with all of the technical details.
Well, so I guess what I would be looking for is like some sort of independent verification for multiple different sources that are experts in the field. I don't know if I would trust something.
Yeah. So these are experts in the field, right? These are literally field engineers. It's a whole team of field engineers. Okay, they did 5 different tests. We've also had PhDs in optics go out doing similar tests with different spectrum lasers. Okay, Dr. John D. So these have been done over and over and over again. Now you're dismissing it, right? Because what you're trying to do is appeal to authority and appeal to credentials. Okay, so you've got some faulty logic happening right now. So you haven't even looked at the test, and you're instantly dismissing it because you don't think the people that did it are qualified enough. Even though it's a team of field engineers using a $30,000 laser, you're just hand wave dismissing it, and that's intellectually dishonest and fallacious.
Okay, so in reality, I don't actually hold any of the beliefs that you just described. But what I would say is that my issue, I guess, is that I don't know any engineering at all. So generally, what I would look for to find out whether something like this would be true would be some sort of, number one, explainable, right, to me. It wouldn't just be like a whole bunch of numbers. And it would be usually be like independently verified, like in a decentralized manner. Rather than just
this is independently verified, and anyone can go and repeat this themselves. And not only is it a 180-page PDF document with all of the numbers, there's a 1 hour long high definition video showing the entire process done start to finish.
Can you show me the independent verification?
Yeah, you can watch the video. You haven't even looked at the test yet. There's an hour-long documentary showing the entire test done, unless you would be claiming that these people are lying and all of this is somehow CGI or incorrect.
No, that's not what I'm saying, right? What I'm saying is, if the independent verification happens in the source itself, then it wouldn't be independent, right? It would be by the people that made it.
He told you, brother. He told you. This is just one example of a. Listen, pay attention. This is one example of a group. All right, check it out, brother. This is one example of a group. They did 17 tests. This one PDF has 17 tests in it, done at different locations, okay? Other people have done other tests at other locations. Some people have done it at different lakes. Some people have done it over the land. Like he mentioned to you, there was a PhD specializing in optics. He heard about flat Earth. He decided to use his optics skills to test it. He went out and he cataloged what he did. He did a similar thing with lasers to do a laser transit measurement. So this has been repeated multiple times by multiple different people, even people who weren't flat earthers. So yes, it's been independently verified.
So what I'm not asking is the independent verification of the measurement itself. I'm sure other people have measured the Earth. What I'm asking is the independent verification of the PDF that was posted. That's what I'm asking.
What would that even mean?
Well, what it would mean, so generally, normally what we do is we take like a paper, we like make it whatever, and then you post it in a peer-reviewed journal, and then a whole bunch of people who are also experts in the field will respond to that. And they will be incentivized to
that's not independent verification, dude. That's
well, it would be independent because
they're different things.
Well, those are the same thing. Those peer review is an example.
No, they're not.
What do you
think?
No,
peer review doesn't verify that you did anything. It just reviews the process of what you did. Unless you duplicate the experiment, you're not verifying anything.
Yeah. So hold up. Peer review is an example of verification because what you can do is you can take data and see if it lines up with what would be expected in reality, right? So that would be an example of independent verification. There are other methods, I agree.
Yeah, so why does the laser hit the target?
Well, you are
every single time the laser, right? So the laser is placed 1.5 meters above the surface of the water. Okay, and then there's a target on the other side of the body of water that's also 1.5 meters above the surface. And every single test, the laser is hitting the target. Why? Why do you think the laser is hitting the target?
Sure. Okay. So I'll answer any question you have once you answer whether or not it's the case that this PDF, like you can show some sort of independent verification of this PDF here. I would like to see that.
Yeah. So it hasn't been peer reviewed by whoever you're thinking should peer review it, right? But that doesn't mean that the test wasn't done. That doesn't mean the test hasn't been done and it hasn't been reviewed by thousands of independent researchers.
Yeah, well, hold on, DJ.
I reviewed it.
Hold on, DJ. There's a problem here because duplication is a higher standard of verification than review. Okay, so he's actually asking for a lesser standard than's already been done. This has been duplicated. Yeah, it is, dude. 100%.
No, I'm not asking for that. Right. So what I'm not, just to be clear,
you asked for a verification, dude. That's not duplication of the actual process.
So I don't think you're
somebody just reviewing it and giving their opinion on it.
So I don't think you're correctly prescribing my beliefs right now. So what my beliefs would be that, look, I'm sure other people have done this test before, and I'm sure maybe some people have come up with flat and some people have not, right? Maybe one of those groups of people are lying. I don't know. Oh, Jesus Christ. This is like the sound that disables flat earthers.
How about a PhD specializing in optics that not only
Sure,
reviewed
yeah, I would
the
like that, yeah.
process but duplicated the experiment, and not only duplicated it but upped it by using dual band lasers rather than just one
Show me a
frequency?
PhD that have reviewed this PDF. I want to see that. Yeah.
Yeah, not he duplicated it. It doesn't even
Yeah,
have
can
to
you show me
review
that?
it.
Can't you
I'm asking
review
for.
it?
So I just want to be super clear what I believe. I don't believe. I'm sure other people have duplicated the experiment. What I'm asking for specifically is whether or not people have reviewed this specific experiment. But presumably, you could do another experiment. That's fine. And
The
maybe
moment we're
some
asking you to review it.
well, I'm not an engineer. I don't know anything about this. So I'm kind of
Yeah, dude. I'll give you. I'll fast forward. Dude, I'll help you. I'll help you. Okay.
Thank you.
Okay. Here's how it works. Anybody who has an open mind looks at it, reads it. Globers who scrutinize it, they come up with ideas to scrutinize. For example, they might say, "Oh well, the collimator burnt out on test 4, and therefore that test doesn't count," or they didn't level the laser, et cetera, et cetera. But the fact of the matter is, the laser hit the target. Now they may say, "Well, okay, the laser hit the target." They have to concede that. There's also a photograph of the laser at the longest range shot, which is 25 miles. So there's actually an image of the laser, right? The light of the laser coming into the camera, which means you can use a Gaussian profile because lasers distribute their light pattern Gaussian. And you can actually tell that the centroid of the beam is actually coming into the camera. So you know that the laser hit the target. Now, the standard excuse, just for your benefit, the only excuse, because keep in mind, this is going to be 90 meters off from a globe prediction, which is 2 orders of magnitude debunking the globe geometry by laser transit methodology, which is an effective measurement methodology. So the standard response is, well, light just bends around the Earth magically to always hit the targets whenever flat earthers do a test that disproves the globe. There you go. There's the review. That's what they all do. That's what they all say.
Wait, so you
Now
just
you know.
reviewed the paper? That's crazy. Are you an independent
No, I'm telling
expert in the field?
I'm telling you, listen, friend, I've been doing this for 10 years. I've heard thousands of people talk about this document, including flat earthers and globers alike, some with credentials, okay, some from like astronomers, some physicists, et cetera, and they all have the same thing to say. So I'm just telling you what their review was, and that was their review. Okay, now you know.
Yeah, sure. I would like to. Okay, wait. Can you show me the review rather than like saying the review yourself or something? So I'll just recite specifically what I'm asking. Right? What I'm asking for is here's a PDF. Now, I think anybody can write a PDF. Okay, it could be true or not true. I don't know because I'm stupid. I'm not a physicist or anything. So
okay, stop for a second. Stop for a second. Okay, so if you're not credentialed in those fields, how could you possibly scrutinize somebody's review of this event?
Well, the way you would do it generally is you get a whole bunch of experts way smarter than you and me who can explain it to us, and we say,
I see. So the point is you're going to have to scrutinize what they say based on your own acumen. Okay, correct?
What? Wait, sorry. What?
You're either going to carte blanche accept what they say based on faith, or you're going to scrutinize what they say based on your own intelligence, right?
Oh no, I don't hold that belief. No.
What? That's the only two options, dude. Look, if somebody tells you a proposition, A, you believe them based on you trusting them that they're correct, or B, you scrutinize their proposition and then you either accept it or reject it. Those are the only options on the table, bro. There's nothing else you could do.
So the difference is I don't base it on faith, right?
Well, calm down first.
Yeah, calm down.
Yeah, if absolutely. Yeah. Listen, if a physicist says such and so is true, and you just say, okay, because you're a physicist, I'll accept it. That's faith, brother.
That's not what I believe, no. I didn't say that.
Oh, okay, that's fine. So then the only other option is you have to scrutinize what they say, correct?
Well, I could also do it based on some other metric than faith, for example.
Right, which would be scrutinizing what they say, correct?
Well, there could also be a preset measure that I have that measures the likelihood of whether or not it's true, the thing they're saying, right? And an example of that could be
a Ouija board.
Well, you could also set some standard that would increase the likelihood of correctness, right? So you'd say if multiple independent experts in the field looked at a topic and decided that this is actually seems to be consistent with reality, and they can explain that to me, of course. Like,
Right, which would be faith. Right, that would be faith. Faith in a greater
Well-
number, but it'd still be faith.
Well, so what maybe we have different definitions of faith. What I think take faith to be is some sort of like axiomatic, unjustified belief. But I don't know if you want to.
No. Faith is confidently trusting that something is true.
Oh, sure.
Okay,
Yeah, absolutely.
without direct knowledge of the truth of it. Okay.
Well, I don't know if you have direct knowledge of the truth of anything, but like, if what you mean by faith is just that after this process has happened, I would hold like a greater than 50% belief that it's true. Then yeah, then that is what I mean. If that's what you mean by faith, generally I don't use the word that way though.
Okay, so if let's say 7 physicists say that this laser test isn't correct because they didn't level the laser, okay, would you believe that?
Wait, what are you saying? If what?
Okay, let's say 7 physicists scrutinize this test and they say they didn't put into the document how they leveled the laser, therefore this test is incorrect. Would that be true?
I would say if 7 say that consistently, independently, and in a decentralized manner, like without bias, then I would probably believe that. Yeah.
Right, but the problem is that's logically fallacious. That's logically fallacious. Just because they left it out of their document doesn't mean that they did or did not level the laser properly. So they would actually be logically incorrect. So you're basically just believing them even though they're wrong.
When you say logically incorrect, do you mean that it like violates some law of logic or something?
Okay, they're making a conclusion. In the document, it doesn't say how or if they leveled the laser, therefore their conclusion is wrong. That's illogical.
Okay, when you say illogical, do you mean that some law of logic is being violated?
No, dude, you know there's logical propositions, right? Yes, they do form out of the laws of logic, but that doesn't matter, dude. You know logical arguments? You know, like there's like 400 logical fallacies, 200 formal fallacies, et cetera, you know all those? So if I said to you, you're a guy, therefore you must own a Toyota Camry, that would be illogical, correct?
You're a guy, therefore. Well, the reason it would be illogical is because it violates the law of logic, right?
Which is what law does it violate?
Well, that one. Well, you're a guy, so therefore it must be. Well, I would say it would be non-valid, so it would probably be the law of non-contradiction, right?
What? What? No, dude.
Wait,
Not
sorry.
at all.
What do you disagree with about that?
It's called non sequitur. The conclusion doesn't follow from the premise.
Yeah, and a non sequitur is a law of non. Is a violation of the law of non-contradiction.
No, it
The
isn't.
second
dude.
law.
No.
It's not.
Nope.
Maybe you're.
There's no contradiction. There's no contradiction that if you're a man, you own a Toyota Camry. That's just an if then.
But sorry, hold up. If the thing which if the argument is invalid, right? Then it means that it doesn't follow from its conclusions, right? So when you have a conclusion and it doesn't follow, it means you're claiming it's justified and also not justified at the same time, and that would be a violation of the law of non-contradiction, right?
Well, I mean, look, if you put it that way, you could stress it out maybe, but it doesn't matter because there is no inherent contradiction.
Sorry, if it's a logical fallacy, then it violates the law of logic. Right? That's just
no, dude, because you can make a conclusion that's poorly reasoned, but the conclusion is still correct.
It depends on whether you. Sorry. You can make a conclusion that's correct, but poorly reasoned. I agree with that. But then
right, or you can make a conclusion that's poorly reasoned and incorrect based on your presuppositional biases of your worldview. For example, as a peer reviewing somebody else's work, you could shove your worldview into your interpretation of what's going on and make conclusions based on assumptions rather than the facts.
I don't know what you're saying there, but like, look, the point is just. Oh,
no, stop, dude. If you don't know what I'm saying, this is very relevant. No, we're not, dude. It's very relevant because you said you want physicists or whoever, credentialed people to peer review this. But how do you know that their review is correct?
Okay, so Like, the problem is I can't respond to multiple things at once. I don't know which one of those things do you want me to respond.
It was only one thing on the table, dude. You think
Well,
that having
problem is-
7 dudes with credentials reviewing this thing is going to matter, but I'm asking you, how would you know their conclusion about the review is correct? How would you know it?
The problem is that you have already moved on from the thing you already said, and I haven't responded to that. Which one of those do you want to go by? The one we have now, or the one we did previous that you moved on?
No, I'm just trying to get to the point where if 7 dudes agree because they have credentials, it means they're correct and you're going to believe them.
Okay, we'll address the one you moved on to. Okay, so I would say that if 7 people have credentials, there's a higher likelihood than not that they're probably going to have a good belief on it. That's number one. And number two, if 7 people are saying it, that's going to increase likelihood even more, of course. And if they're independent, decentralized, it means that they're probably not affected by some sort of bias. So those are going to be the justification for that. That's going to increase the likelihood more than not, like compared to not having 7 dudes. It's going to be my
Okay, so that's great and all. So how do you know that what they're saying is correct?
Well, I just gave you the reason why it would be more likely than not. Like all those.
Okay, but how do you know it's correct?
Sorry, when you say knowledge, do you mean like 100%? I don't know anything 100%. I'm
Well,
saying
dude,
I'm just
you
claiming
you can't even tell me how you know what they're saying is correct, let alone how you know anything. So why should I trust your opinion about anything?
Okay, maybe we use knowledge in a different way. What I'm claiming is just that it's more than likely to be true, and that's what I mean by this is how I know it. If you use know as a like, do I know 100%? I don't think that's true. I don't think I know that many things 100%.
Okay, so there's 3 billion Christians in the world. Are they correct?
Are there free?
All different walks. So yeah, there's 2.5 to 3 billion Christians, 2.5 to 3 billion Muslims and Hindus. Like it's all in whatever. Anyway, there's multiple billions from all countries, from all walks of life, from all demographics, completely disconnected from each other. Yet they all agree on one thing. Are they correct?
Yeah, so I would say things aren't correct just because a lot of people say so.
Oh, really? Wow. Now we're getting somewhere. So just because 7 dudes agree that this test doesn't disprove the globe doesn't mean they're correct. Good point.
That's right.
I'm glad you made it there, brother.
Yeah, so there has to be other things true than just them being 7 people, right? There has to be.
Oh, there you go. So then their arguments of why it's correct or incorrect are actually what matter, not the fact that they agree.
Well, no. What would matter is, one, there's 7 people. Well, you would say the majority of the people who reviewed it or something, right? That's number one. Number two, they're experts in the field, right, on the proposition of whether this thing is true or not. And number three, you would say that they're independent and decentralized and unbiased, right? So those things.
Them being experts in the field are irrelevant unless they use their expertise in a proper argument to make their point. If they just make a point and they generally appeal to the ethos of their credentials, being an expert in the field, then their point gains no merit from that whatsoever. If their conclusion isn't logically connected to their expertise, then their point is irrelevant.
Yeah, I agree with that.
Right. So since you're not qualified to critique these guys, like you already admitted, how could you possibly know what they say is true or not?
Well, for the same reason I already stated, right? It's going to be more likely that they've used expertise.
Yep. So thank you. So what you just agreed, whether you realize it or not, is you have no way of understanding. Even if we gave you a peer review of this event, you would have no way to understand what you're reading. You would just take it on faith that if 7 dudes with credentials said, no, this is bogus, you'd just be like, yep, I agree. Good point. Thanks for playing.
So I have a feeling we mean something different by the word faith. I don't know what you mean by faith.
Dude, you admitted that you don't have the acumen to critique their review and that you're going to take it on a more than likely basis that they're correct. And then you're going to put your faith into that conclusion.
Yeah, I'm going to believe it because of the surrounding factors of the.
Correct. That's called faith, brother. Faith.
Sure. If that's how you define faith, as in you believe in the more than likely conclusion, then I agree with that. Yeah. I mean,
No. See, dude. See, the more than likely. See, I don't agree with your metric of more than likely being based on 7 schmucks who have a particular worldview agreeing. So, for example, there's a bunch of retarded evolutionists who think that boobs on a woman evolved from butts on a monkey so that they could trick men into having sex with them face to face rather than from the butt. So, yeah, they're morons. Yeah. Oh, see, that's true. Oh, see. Oh, wow, dude. I got one. I got a person who actually believes that. Wow.
That's crazy.
I can try to build biology paper if you want.
Yeah, dude. So the butts, what happened was the butts, they slowly moved to the hips, and then they slowly moved to the belly, and then they slowly crawled their way up to make boobies that men find attractive.
So so you have a slight misconception. It actually crawled like the other way around. It crawled the back.
Down the back. It crawled around the back. So they had back boobs for a couple of millennia.
Yeah. You can actually see that on the tissue samples we get from like fossilized
fossilized. Dude. Hey, Jedi, fossilized monkey dino back boobs.
No, well, specifically, you're not getting it from like the you're not getting from like actual tissue. Usually, it's turned to stone or something.
Whatever, dude.
Okay, so
you're the kind of guy that when they put out an image of 5 pixels and they say it's a planet where diamonds are raining down, you believe it. That's the kind of guy you are. I imagine.
Can I ask you a question?
Absolutely, Holmes.
So, if a ship is on the horizon and then it disappears, what do you think that's because? If the Earth is flat, then you should be able to see it. You should be able to see everything on the horizon.
Okay, fair. Okay, so there's 2 claims there. One is, if the Earth was flat, I should be able to see everything at all times. That's
not necessarily.
Not true. The second,
not necessarily.
Okay, fair enough.
Listen. Let me finish. A ship passes over the horizon. Say you have no fog. Shut the fuck up, Reed. Say you have no fog. Say you have nothing on the horizon. Right? It's a clear day. A boat passes right from your distance of view, the same exact distance, no matter what. I'm pretty sure it's like 9.
No, it's not true.
Yeah, it is.
It's not true.
Yeah, what do you mean?
No, it isn't.
Okay, tell me how it's not true.
It's not. It's not true. It's just hold on. It's not true that the boats always disappear at a fixed range. So, for example, there's boats sighted 30 miles out. Now, 30 miles out, the boat would have to be 400 feet tall to be seen, but there's no boat that exists that's that tall. So it's not true that there's a fixed distance where things disappear. In fact, you see things much further than they should disappear all the time.
Can you tell me what boat that was?
Dude, I could give you. Listen, I'm not going to do it right now because I'm busy working. But I can. We've got all kinds of observations, dude. And this one I'm speaking of is from Indio, and he's actually a member of our server, and he could actually show it to you and show you the marinetracker.com where it shows which boat it is. He could show you where he is in the Boston Harbor. And I'm not, and this is just one example, dude.
Okay, I'll give you.
Not only that, so check this out.
Can I ask you another question?
Well, no. Let me finish.
Oh, I get
so
your
I'm just
point.
doing a teeter
if you're not willing to show
no.
If you're not willing to show me the evidence, then I'm not going to listen to this because I'm not going to listen to you if you don't show me the evidence. Okay, can I ask?
Okay, listen, Nick.
Well, if you're not willing to show me the evidence, I'm not.
Nick, I don't need to show it to you. I can validate it with an argument. It's very simple.
There's no validating with an argument because let me explain it. I'm not going to take your word.
Let me explain it, and then you can discount it after I explain it.
No, I don't.
For the past 10 years,
if you can't show me the real evidence, then I'm not going to listen to you. You can say,
whatever, dude.
Can I ask you another question?
Posted up bottom-up obstruction. Flat surface in the side chat if you want to look at it.
Can I ask you another question?
No, because I might have to present evidence, and then we can't have a discussion and actually talk it out.
How about this? From now on, you could just explain to me why this is true or why this is not true.
Well, I want to stay on the other point real quick.
we're gonna go past that right now because you're not willing. You said that you have evidence, but you're not gonna show me the evidence. So
I posted up
It's not just that I have. Listen, Nick. It's not just that I have one piece of evidence. It's that over the past 10 years, including before the past 10 years, hundreds upon hundreds upon hundreds of observations of objects being seen further than the geometric horizon have not only been proffered by globe argumenters and flat Earth argumenters, but they're all over the mainstream. Like it's so ubiquitous.
So
that there's actually this whole. Hold on,
if
let me
you're still
finish.
not going to show me the evidence, I'm not.
Hold on.
I'm not going to.
Hold on, dude.
You can't show me the evidence or can't.
Okay, that you don't have to believe me, but let me finish this point. So the point is that on the globe side,
I'm going to go for a next question.
On the globe side, they have a rebuttal for this, but it's not that they deny this occurs. So go ahead.
Okay, whatever. So let's go for a more complicated one, if you can explain this. So why do you think the stars change position based if you're on the north side or the south side? Or, why did the stars change positions in the sky depending if you're on the north hemisphere or the southern hemisphere?
Well, the stars don't really change position. They're just like different stars.
Yeah,
I don't know of any star that changes position. Oh, that's simple because you're in a different location. Yeah, you're in a different location, so you see different stars.
But I understand that, but the closest star is like it's like 3 light years away, which is so far away. And
okay, fair enough. Fair enough.
Yeah,
fair enough. How do you possibly know how far away the star is?
Do you want me to explain to you the science behind it, or do you want me to send you a link?
There isn't any science behind it, but go ahead and try.
Okay, let me pull up the science because I don't know because I'm not a scientist. Let me pull up the science for you.
There's nothing, dude. There's only angular sizes. There's the assumption of the cosmic distance ladder. There's the assumption of the luminosity, and then there's the assumption of the parallax measurements, which they have to assume the Earth is in a different location in space to get the base leg of the triangle to get the parallax. So all of it is a bunch of assumptions.
Okay. It's okay. Here, I'll explain to you. So
yeah, go ahead and explain it to me, even though I already told you everything. Go ahead.
So they find distances, and this is how they found distances 400 years ago, right? So if you have I'm just reading this is what it says on what's it called on NASA's website. I understand this somewhat. They say using parallaxes, tiny shifts from nearby.
Oh, parallax!
Measuring brightness compared to known types of stars, so they can tell.
Luminosity. Luminosity.
Listen, let me explain it. Let me go into more detail.
You're just saying what I said, dude.
I know, but let me go into more detail than you did. Okay. So you have a red dwarf or a white dwarf or a any types of star, a main sequence star.
Little person. No. Listen. It's a red little person. Okay.
What?
Yes, dwarf is a derogatory term.
You call them little people.
Okay. A red midget star. You have a your main sequence. All these different types of stars, which we know we've studied in the past. Let me say, in the past century, in the 20th century, we have studied more about stars than any other time in history. We've learned the ins and outs of stars. That's what we've done. This is what NASA has focused on for literally 50, 60, 80 years, whatever. When I think they were made in the 50s. So let's just say 70 years.
So in 70 years, they're still doing an assumption-based ladder rather than actual measurement.
A redshift. You know what the redshift is, right? When light.
Yeah, redshift is circular. Yeah, redshift is circular reasoning.
How so?
Because you're assuming the thing is moving away based on the spectral bands. Based on how they match the
away. You're not assuming it's moving.
Oh, yes, you are, dude.
You're not assuming it. No, you're not.
Yes, you are.
And our perception is at a fixed distance, right? Because we assume obviously they are moving away in a sense, but because the expansion of the universe. But
You can't have a redshift. You can't have a redshift being caused by anything in there except movement.
Shut the fuck up and listen for a second, dude. You interrupt so much. Just listen. Okay.
Yeah, but we're buddies.
Oh, that's true. There you go. That's a fair.
That's right.
You got me there. All right. So you have a redshift, right? So, when light travels along a distance, it loses some of its energy and it stretches out. And this is just a very simplified version.
What? That's not what redshift is, dude.
Well, light stretches out and the wavelengths become much low. The frequencies of the wavelengths become much lower, changing the color to a dimmer red color. So if you look at stars,
hold on, friend. The color of what, though? The color of what?
The emission of the light, the luminosity.
Oh, you're wrong.
No.
Yeah, let me explain it to you. So what they actually do is they take a spectral analysis of the light and they look at the element bands. So on Earth, when you do, like, let's say copper, if you look at copper through a spectral analysis, it's going to have certain bands of stripes, right?
Yep.
And that's going to represent the gamut, and they have an identity by that gamut, and then they say that's copper. And so what it is when they see from these stars these bands, they match the bands of, let's say, copper, but the bands have shifted towards the red side of the spectrum. That's why they call it red shift.
Yeah, so when the wavelength of the frequency of the light gets stretched out over a distance and it becomes redder and redder because red is the lowest color that humans can see.
Yeah, fair enough. So let me ask this question, dude. What if, now here, this is important, because remember how I told you how they do it? They try to match it to things on Earth, right? What if it's the case that stars just emit red shifted light and it has nothing to do with them moving? Yeah, and if that's true, let me finish this conclusion. If that's true that they're not actually moving and they're actually just emitting red shifted light, there'd be no way to know because nobody has ever been to a star to validate it.
Yeah, well, they can tell with 100 different sciences that what type of star it is based on, like you said, whatever, seeing what type of chemicals are in the star, seeing what type of elements are in the star. They can. I'm not a scientist. I'm going to tell you this. I know
you're not a scientist, brother. Check this out. If you're doing science in a lab, and you have the sample in the lab, and you have very accurate machines, let's say they're 0.3% accurate. The standard that they need to check the star and to validate it is orders of magnitude greater than what they can do in a lab. So what they're trying to tell you is that they can get a certain parts per million reading in a lab, but they can get a greater accuracy reading from a star. That makes no sense, my brother.
Well, star's a billion trillion times bigger, dude.
Hell, whatever, dude. Yeah, so in other words, they haven't validated any of their claims about what the stars are or how far away they are.
So you think NASA is just lying to everybody that the Earth is round?
No, I think they're so stupid they actually think they know what a star is based on their stupid little readout that's way more accurate than what they can produce in a lab.
We're not talking about a star right now. We're talking about why the Earth is round. This is your argument. So you think NASA is lying that the Earth is round, right? You think they're just lying about it?
That depends what you mean by they, because there's many people in different organizations. I was in an organization where I had secret information that nobody else had, and everybody else just had to go about their business without knowing what I knew.
Okay, so that literally had nothing to do with my question.
Yeah, what I'm trying to tell you is that just because NASA is involved in quote-unquote space missions doesn't mean that everyone's lying. There'd only be certain people that know truth and are constantly saying against the truth. But if you're just believing what you're doing, so for example,
that's what I just said, bro. They're lying to them.
Yeah. So
they're lying to the public to say
no.
Is that true or false?
No. Just check this out, brother. There are many employees at NASA who absolutely believe the Earth is a globe. They even do missions, and they can't even tell the difference between a training mission and a real mission. So I don't know who's lying, but most people just believe the Earth is a globe, bro. They just believe it. And that includes NASA employees. Most NASA employees have no firsthand knowledge of whether the Earth is a globe or not. They just believe it.
Okay, hold on.
Their jobs have nothing to do with any firsthand knowledge of the Earth being a globe whatsoever. And they certainly haven't seen it with their own two eyes.
Okay, so how do you explain, like, how the moon and the sun behave? How do you explain day and night?
Oh, perfect. So during the day, the sun is out, and then it go away, and then the moon come up a little while. Sometime it come up during the day, and then it go away. So the moon and the sun, they're kind of like here, and then they're kind of like there. So they just go around and do, they're never in the same place.
Okay, that doesn't explain it. No shit, Sherlock. Explain why that happens.
Well, I mean, listen, fair enough that you desire an explanation. All I know is what I see. I don't need to know anything more than that. I don't need an explanation. So if you want an explanation, I'll give you one. So Ratchet and Clank, the video game characters, are actually real. And Ratchet uses his gravity gun to make the sun go around while Clank feeds him tacos.
Okay, I mean, honestly, that's fair enough. I'm a flat earther now. Now I agree on everything. Actually, no, the Earth is a banana. Prove me wrong, the Earth is a banana.
No worries, brother. But see, the point why I'm being so tongue-in-cheek is that what the stars are doesn't change what the shape of the Earth is. What the sun and the moon are doing doesn't change what the shape of the Earth is. So, for example, I'm in a kitchen. I'm in a kitchen, brother. Just check it out. I'm in a kitchen, and there's a granite countertop, and it is beautiful and flat. And then there's a light fixture above the countertop, which has 1, 2, 3, 4, 5, 6 globe lights. Rest assured, my friend, the shape of these lights in this light fixture has nothing to do with the fact that this piece of granite slab is flat.
Okay, that is a completely irrelevant analogy that has nothing to do with what we're talking about.
No, it has everything to do. It's that the ground is what the ground is. It has nothing to do with the lights in the sky, bro.
Do you want me to explain to you why that's an irrelevant analogy?
Yeah, go ahead and tell me why two things that are different things have nothing to do with each other. Yeah, go ahead.
Okay, so I'm talking about motion, not the shape of a star. I said nothing about the shape.
Oh yeah, fair enough, brother. Fair enough. So let me do something. I'm gonna up my experiment. Flat granite countertop, 6 globes in a dangly light by a chain. Now watch this. I'm gonna take my finger and I touch the chain. Now the lights are moving. Oh look, my countertop changed its shape. My countertop, oh my goodness, it's no longer straight. Wow, the countertop just curved in front of my eyes because I made the lights move. Did that happen? The answer is no, it didn't. What?
I really don't understand anything you just said, but
I know, brother, that's the problem. So now I'm going to take a tool. The tool I'm taking out is called a square. It's actually the shape of a triangle. And I'm going to lay it onto my granite countertop. And let me tell you, brother, it lays right on that, flat as can be. Now, since I have my tool showing me that the granite countertop is indeed straight and flat, I'm going to take the lights on top of the granite countertop and I'm going to turn them off. It's now dark. The granite countertop is now in the dark. Is it now a globe? Oh, whoa, the light's back on. Is it now a globe? Oh, whoa, the light's off again. Is it now a globe? No, it's never a globe. It's always flat.
Okay, can I ask another question? Bring up another
sort of thing, brother. Hit me up.
So, let's give you an example. A city in Egypt, I think it's Sainin. You probably have heard this one before. Sainin, whatever it's called. During noon, on whatever day of the year it is, there's no shadow. You don't have a shadow because the sun is directly above you at noon. And some other cities, it's very similar.
Yep.
So if you go to the city next to it, if you go to Alexandria, city next to it, you can measure your shadow and it's at an angle of 7.2 degrees. Right? It's not a city right next to it, but it's a city in Egypt as well.
Yeah.
So if the Earth was flat, how would you explain that? If it's round, that would check out. But if the Earth is flat, how would that not check out?
Well, you see, what you're talking about is shadows, right? And so you're making assumptions about the nature of the light and the shadows and geometric relationships.
Oh, we're not making assumptions. We're not making assumptions. We know this.
No, you are.
Science.
No. Listen.
There's no. That's not an assumption.
No, the non-assumption. Listen, Nick, dude. Okay,
shadow is just the absence of light. It's just it's not.
Okay, listen, dude. How are shadows created?
They're not necessarily created. It's just not necessarily a complete.
Hey, listen, let me ask you this question. If it's pitch black, are there shadows?
In our eyes,
no.
Yes. Yeah, well, I'm not saying, because there's obviously...
If it's pitch black, there's no shadows, homie.
Well, if you want to... That's just way too...
So then the only way to get a shadow is to turn on a light, and the path of the light to illuminate the area, and a shadow is where the light is not hitting the area because it's being blocked by something. Right.
Yeah, that's a shadow. There you go. That's what we create when we're saying
and so shadows are blocking the path of light. Now, in order to make geometric claims about the light that's blocking the shadow, that's casting the shadow by the blocked object, you have to make certain assumptions. So, for example, Eratosthenes, which is who you're speaking about, made the assumption that the sun is an infinite distance away, that it's larger than the Earth, that all the lights are that all the rays are parallel, et cetera, et cetera. He made a bunch of assumptions. So it's not, he measured shadow angles. He didn't measure the sun, and he didn't measure the Earth.
Okay, so why would those two things
Oh, it's very simple, dude. It's if the sun is over here and the rays of the sun are not coming in a way that's uniform, then you're going to have different shadow lengths. I mean, look, I have my granite slab again. Watch this. I take my square, which is blue. It's from Empire Squares, and I'm placing it on the granite countertop. I see a shadow. Okay, this shadow is, since I have it, I'm going to turn it this way so I can measure it.
Wait, also.
Okay, the shadow is, hold on, brother. The shadow is 6 inches. Now I'm going to take the square and I'm going to put it directly under the light fixture. No shadow. Now, let me ask this question, friend. Is my granite countertop a globe?
You're doing it at such a small scale that it really doesn't matter.
Doesn't matter, dude. The principle's the same.
No, it really isn't. Not at such a small scale. Scales have a lot of to do with things. It has a majority of the things to do with everything. A scale can change your experiment drastically.
Sure, I would agree that scale can change things. That's fair.
All right, can I ask you another thing?
Sure.
So why does the bottom of a ship disappear first, then the middle, then the top when it hits?
Okay, I agree. I'm glad you asked that, because now we're going back to where we started. So I said that the ship doesn't disappear at the geometric horizon claims. It disappears much further sometimes. But did you know this? Check this out.
No, I just answer my question.
Hold on, brother. Hold on.
I don't care what Jeff is saying. Just answer my question. That's all I want is you to answer my question. Why is that the case?
Okay, dude. I'll tell you why. If you can't see the bottom of something, it's because resolvable light from the object is not being resolved in the optic. There you go. That's the answer.
Okay, but why is that the case? That's just.
I just told you. I'm gonna listen. If you don't let me expound, I'm gonna reduce it to the most absolute technical reduction, and you're just gonna have to live with that answer.
Yeah, but that's
you don't get to take a dial. You don't get to take a dial and then dial the color of the television till you like my answer.
It's like I'm speaking to a brick wall, bro. Just answer the question in detail.
Yeah. You can't see things because you can't resolve light from that portion of the object. There you go.
Why can't you resolve the light from the bottom, then the middle, then the top?
Oh, because I'll tell you why. Because you have a limited angular resolution, and the packet angles that are available to render are below the threshold of resolvability.
Go a little bit more into detail with that.
Yeah, so if you took a checkerboard and you look at it, standing up and you're looking down at a table and there's a checkerboard, you could see all the squares. But if you took that checkerboard, put it directly into your eye, and then turned it horizontal, it would disappear. So the angle of approach matters to whether you can see something or not. So once light falls below a critical angle, for example, a human eye is 0.02 degrees. So if light is not entering greater than 0.02 degrees, there's no resolvable information. Any information that's coming in that triangle will be conflated with each other and become one value. So if that's the bottom of a boat in the ocean, disappears. If that's the bottom of a building and the sand, disappears.
Okay. Can I ask another thing? What do you think
only if you let me finish. No, only if you let me finish my previous thing I wanted to finish.
Well, then, sorry, you're not going to say another thing because I don't really care about that. I'm not going to ask another question.
Hey, Nick, how's that fair? How's that fair? I've been trying this whole time to tell you a very cool observation that I've done with you. I've done my own observation on my own lake, and you won't let me talk about it. Why are you such a bigot, bro?
I'm not a bigot. I just don't care about your observation because I don't necessarily.
Yeah, see, you're a bigot to my observation.
I don't trust your observation. It's just like you saying something.
Hey, bro, the best part. Listen, friend, the best part about my observation is you can reproduce it yourself if you're within driving distance of 1,000-foot lake.
Okay. Well, I'm not. So, can I ask you another question or no?
Listen, I want to tell you my observation, dude. How about this? You put your fingers in your ears, and I'll tell the audience since they want to know.
How about this? I just leave.
Well, dude, if you're going to say, I'm not going to let you tell me your unique, curious observation that has relevance to the flat Earth, globe Earth discussion, or I'm going to leave. How is that fair?
I don't trust your observation. That's the thing.
You don't have to trust it, dude. I'm just going to tell you what it is. It's reproducible.
Well, what would be the point of you telling? I'm not going to reproduce it because I don't care that much about if the Earth is a globe or flat.
It's not only reproducible. You can also go find other people that have already done it, dude. So besides me.
Okay. So can I just ask you a question or no? Or is it just a no?
Dude, I'm just trying to give you my observation, bro. Why are you so scared of my observation? Are you afraid that it's going to shatter your paradigm and you're going to have to realize that your globe cuck religion isn't as true as you thought it was?
No, I really don't care if the Earth is a globe or flat. I just was.
No, you do care because you're too scared of my observation, my bro.
No, I just wanted to ask a question.
It's like your girlfriend is holding your phone and she's like, I'm going to flip through your messages. And you're like, oh my goodness, why would you want to do that?
For the sake of privacy.
Yeah, but see, the difference is you know that there's evidence of you cheating on the globe. Because when you're out there in the world that the Earth presents itself as flat. So you've been cheating on the globe your whole life, bro.
Okay, can I just ask a question, bro? You're making some fire analogies. I can't lie. That was pretty.
All right, listen. You ask your question first, and then I'll tell you my observation. Go ahead.
I'll listen. I'm probably just gonna leave afterwards. All right. So, how can you explain to me like your idea of gravity, right? Because if our understanding of gravity would be that the Earth, if it was flat, if it magically became flat, for someone that believes that it's a globe, if it magically became flat, then it would crumble back onto itself. And how do you explain gravity in that sense?
Perfect. I got you, bro. I hear you. So I'm going to do an experiment to help it. So I'm going to grab something here. Yeah, I am. I like demonstration over explanation. Okay, so we're going to use my granite countertop because it's flat and it's affixed to the ground.
You can't use something at such a small scale.
No, just check it out. No, it's not about that. It's not about that. I'm just saying it's just a reference plane. So I have a can of Monster Energy Ultra Fantasy Ruby Red, the thin one, 12 ounces.
Shit flavors are.
That's what they had. So I'm going to take it and I'm going to place it onto the countertop. I'm now going to let go, and I'm going to look at it. Now, check this out. The can is empty, and it's not being crushed into the ground. Why not?
Because it has such a small mass that it's I mean, I could go more into it, but it's just this.
Yeah, it's much. There's a more simple. There's simpler. You can reduce it even simpler than that. If you reduce it ultimately, it's that the structure is able to resist any collapse forces. So, for example, if I put a 50-pound brick on top of it, it might crush, right?
Yeah, it's just a small. There's not that much weight going against it in the structures.
Yeah, fair enough. Right. So yes, fair enough. But for the purpose of the can, it serves its purpose well, and it's able to resist the forces to maintain its shape. Now, if the Earth was flat, yeah, fair enough. So if the Earth was flat and gravity is real, then in order for the Earth not to crush itself, all it needs to do is be strong enough to resist the forces. That's it. It's that simple.
So how do you know that it's strong enough to resist the forces?
I'll tell you how. Because the Earth is clearly flat and it's not being crushed. There you go.
You know, okay. It's like the worst argument I've heard, but okay. Because that assumes that assumes that I would agree with you on the Earth as being flat, which is not an argument you can.
Nick, it's what we all experience. Nick, let me do another experiment. Another experiment live.
I told you I was going to go after this one. I told you I was going to go.
Yeah, fair enough. You can leave. The audience still wants to hear what I have to say. They don't care whether you hear it.
Okay.
So Monster Energy, yeah, peace.
Say I love you too.
Man, listen, I love you an enemy that became a friend, and then we try to backstab each other sometimes, but when we're face to face, we shake hands.
All right, that's fair. All right, bye-bye. Toodaloo.
All right, so I'm going to drop my can. I've dropped it. It landed on the granite countertop, which is flat. It dropped straight, as far as I can tell, towards the countertop, hit the countertop. So something fell downwards and landed on a flat surface, just like we experience our entire lives. Every time we drop something, it heads towards the earth, straight down, minus any wind. But that's all we've ever all experienced. So if gravity is anything, if gravity is pulling things down, then it's pulling it down to a flat earth. So if gravity is anything, it's proof the earth is flat. Now, there will be some triggered people who may hear what I just said and be like, oh my goodness, he said gravity. He said you can have a flat earth and have gravity. Yeah, that's true. Gravity doesn't make the earth the shape that it is. Gravity doesn't make curved things flat. Gravity doesn't make flat things curved.
Is your God gravity?
My God? Or wait a minute, what did you say?
I'm just joking. You know how Globers, they worship gravity. That's their God.
Fair enough, and transversely, some flat earthers are so scared to talk about gravity because they think if they concede gravity, then that means the earth could only be a ball because they can't think outside the box.
I love talking about gravity.
Flat earth. Yeah, you can have a flat earth.
Are you saying there is gravity?
No, I'm just saying gravity is irrelevant. If you're a flat earther, gravity has nothing to do with the shape of the earth at all. Now, if you're a globe earther, gravity could be a religious mythos as part of your creation story. Like, for example, that guy said, you got to have gravity to have a ball because if it was a flat, then it would be crushed into a ball. So he's talking about the formations of things in the past. In other words, a creation mythos, a religion. I know that my flat countertop, when I drop something and it hits it, the fact that something dropped to the countertop didn't change the shape of the countertop. Certainly not a metal can ain't going to change the shape of this granite countertop. Now, if I dropped 5 tons onto this countertop, maybe it would turn it into a pile of rubble. No worries, but to close up the previous convo before you arrived, my observation was that I was trying to tell him that you can see things disappear from the bottom up well before the alleged globe horizon is even in the picture. So in other words, at short ranges. And that, coupled with the fact that you see things disappear at long ranges, short and long, both beyond the globe geometry, demonstrates that it's an optical effect. It has nothing to do with the Earth being a globe whatsoever.
You guys really think the Earth is flat?
No, dude, the Earth is flat.
Yeah, the Earth is flat, dude.
How?
It's pretty fun to talk to.
How's the Earth flat? That doesn't make any sense.
Yeah, the same way my granite countertop is flat, brother. It's arranged horizontally, and all the peaks and troughs on the surface are between two horizontal parallel planes. That's how.
How's your countertop constantly lit by light?
What? Constantly lit by light? What are you talking about? Hold on a second. Hold on a second, brother. No, everybody stop for a second. We're going to do an experiment. We're going to hold on. Listen, we're going to do an experiment. Listen, brother. No, we're going to do an experiment together. So what I'm going to do is I'm going to count to 3, and then I'm going to turn off the light. Okay, the light's off. Is my countertop still flat? The answer is yes.
Oh my gosh. I never thought of it that
Hold on, the light. Hold on, I turn the light back on. I turn the light back on. Now it's a globe. Light off, flat. Light on, globe. Light off, flat. Light on, globe. Is that how it works? No. In fact, my countertop is a structure, and it maintains its structure regardless of how it's lit.
Turns itself on and off because that proves that the Earth is flat because the sun just turns itself on and off.
Let's talk about
No, dude, it's irrelevant. See, the point is, friend, that the structure.
How does day and night work?
Yeah, very simple. During the day, there's light, and during the night, there's not. That's the definition of the day and the night, right?
But how? You're not even explaining it. You're just saying that it's day or night. You're not explaining how it works.
What do you mean works?
If you're a flat earther, explain to me how day and night works.
Yeah, very simple. So the light source, whatever it is,
how does it work?
What is that? How does that even make sense, dude?
Would the sun go underneath?
Listen, bro. Listen, bro. Let me help you out. So the audience doesn't have to suffer. All right, listen.
Yeah, I
think what you're trying to say. I think what you're trying to say that is if the Earth was flat, that the single sunlight source would light up the entire Earth at all times. I think that's what you're trying to say. Is that what you're trying to say?
No. I'm trying to make sense of how you explain away.
What do you mean, though? Well, listen, if it's not true, listen, friend, if it's not true that a sun would light up the entire Earth, then I don't need to explain why the sun isn't lighting up the entire Earth, because you already agree.
No, I'm just trying to understand how you make sense of day and night cycles if you're a flat earther. Do you think the sun travels underneath this supposed plane of...
No, the sun moves around and the available light moves around. There you go.
Light attenuation.
So is the sun like a spotlight lamp? Does it have things around it?
The sun, I'll put it to you as simple as I can for the facts that I know. The sun is not a sufficient light source to light up the entire Earth at all times. There you go.
So it's a fact. It's not a theory.
Listen, the whole Earth is not lit up at all times. Therefore, the sun is not capable of lighting up the entire Earth, or it is, but it just isn't doing it. So either way, we end up with the same result, that you have day and night over a clearly demonstrably flat surface, measured as such, covered in the known territory by 70% flat level water. So the Earth is flat, and the sun does what it does, and the sun is not the Earth. There you go.
So when... Just to be clear, when the sun
I also have another question.
Are you thinking that the sun is moving too far away for us to see? Is that what's happening?
That's part of it, sure.
Okay, I have another question. How do you explain the spherical structure of other stars and objects in the sky?
Okay, gotcha.
What sense would it make for other objects in the sky to be spherical but not us? I guess is what my question.
Yeah, no worries. Absolutely. I'm going to use my granite countertop again. So I have a granite countertop. I'm eating on it right now. There's lights above it.
Granite countertop, man.
Dude, it's a six light array. Each of the lights are globes. It is above the granite countertop. All 6 of the lights are globes. So countertop 7, 6 globes. 6 globes, 1 countertop. So that's 7 items. 6 of them are globes, and 1 of them is not a globe because it's not the lights. Very simple.
I have a question. Why is it that the source of light, aka the sun, is not in view, but there's still light, like during dusk? Why does light source disappear from view before the light does?
Well, that happens during the day. Like where I live in between 2 mountain ranges.
But I'm
and the sun, just listen, the sun will go from one mountain range to another, and before they're even over the other mountain range, if it's a humid day, I won't be able to see the circle of the sun, but it'll still be daylight.
Right, sure, but what about when you're not in a mountain range? What if you're in the desert? Because the same thing happens.
Same principle. Same principle.
The horizon.
So, okay, then what blocks the light in the desert? Because the mountain blocks the light in the mountain range, but what about...
No. In my example, I told you before it gets to the mountain range. So if the mountain range is not blocking it, the air that's blocking it.
The air is blocking it.
Yeah. In case you didn't know this, friend. In case you didn't know this, real quick, air is not transparent. In case you didn't know that.
Right. If the Earth was flat, wouldn't our chances of being struck by a deadly asteroid would be much higher, wouldn't they? In theory, if we were a plane.
No, you believe in fairy tale space. We don't think that there's a space or comets.
Fairy tale space.
Meteoroids. They're gonna.
I got a question.
Yeah, how about you explain why you think the Earth isn't flat, buddy?
Do we live on an infinite plane? If it's flat, is it just infinitely flat forever? There's an end?
I don't know, bro.
It makes less sense to believe in a flat Earth than it does to believe in a round one.
Really? So 70% of a known surface is flat, level water, and that somehow makes sense that it's a ball.
Do you also believe all scientific research is fake? Is that also what you believe?
So a lot of it is pseudoscience, not actual science.
Yeah,
I believe we've never traveled to space. We've never been to the moon. We've never traveled to space. You don't believe in that stuff?
What evidence? What conclusive evidence is there that anybody's ever landed on the moon?
I mean, there's a lot more evidence to say that we've been there than to say that we haven't.
I've seen it on TV, but it has to be true.
But what about
all I asked for was conclusive evidence, and instead you just gave me some like balancing
photographs.
Why would gravity just stop working? Why does gravity work for us to stay on the ground, but then it doesn't work for the ground to stay on more ground, and then that ground to stay on more ground?
Yeah, fair enough, brother. Yeah, fair enough. Why do magnets? Why does your refrigerator magnet not attract something that's across the room?
What?
Yeah, why does a refrigerator magnet that's on the other side of the room not just fly to the refrigerator?
Wait, hold on.
I'm just trying to understand,
He's
bro.
asking a question. Wait, it does. You do know it does attract it. It's just not strong enough because the other attractions.
Oh, there you go, brother. No, dude. A magnet. Listen, a magnet on the ground isn't just going to fly over to the fridge, but once you get close enough, it's going to fly out of your hand.
No, but listen. Do you know there are different attractions constantly going on, and if there are those attractions of magnetic forces, right? But if
it's because listen, dude. The reason is, yeah, we got you, bro. The reason is that magnetism is a cubed loss, and gravity is a squared loss. So nice try.
Where do you get your evidence from?
How do you know
my other
that?
question. Where's your
it's
evidence?
It's a cubed loss.
Where's your undeniable?
Oh my goodness, dude! The strength. Hold on, for that kid that asked. Yeah, the strength of the field wanes off with distance at a much greater rate than any alleged gravity. Okay, so the reason why you have certain effects when you're close to something versus far away is because the strength of what's going on is decreased so much that it no longer has a significant effect.
Everything has a magnetic effect, bro. What? Everything has a magnetic effect.
Dude. All right, listen, bro, popcorn. I ain't got time to teach you physics, bro. So let's ask Prodigy what he wanted to ask.
You're a physics master.
Okay, yeah, ask it.
How dare we question the physics master over here?
Wait, hold on,
Popcorn. When I cleared the floor for Prodigy to ask his question, that wasn't your cue to talk straight through him. Right, Prodigy. I apologize.
Arkin's voice.
It's all good, man.
All right, so who wanted to ask the question? Was it Prodigy?
Yeah, I was just going to ask you, like, where's your evidence coming from, man? If you're so informed and so knowledgeable.
Okay, yeah, absolutely.
Where exactly are you collecting your information from? Where's your evidence?
Yeah, got you, brother. No worries. So
why is everyone else's evidence invalid?
Well, dude,
James
I accept your question. I accept your question as a valid question, so I'll answer it. Okay. Here's the answer.
What did he know?
I want to hear him.
Okay, check it out.
I want to hear what he has to say.
So, when it comes to the form of the Earth being a globe or flat, Okay. The key definition is the geometric qualities of the structure itself. Now, whenever you're going to measure something to be flat, you need to have a baseline. So, for example, this granite slab, you have a baseline, and then you have another another line from the baseline. So 2 horizontal lines. And there's a variance between them a little bit, but roughly the entire surface is between those 2 horizontal lines. Now, whenever you're doing anything like that, you can float it. You can use a weight crusher, which will slide it back and forth and just grind the bottom off. There's all kinds of techniques you can use. But whenever you're going to test it, you're going to put a straight benchmark, and it's going to be a solid structure. Now, when it comes to the Earth, there's no solid structure that can be stretched across the entire Earth. But there is a structure which can tell you level. That structure is water. Now, water is the gold standard of level throughout all human antiquity. In fact, even the globe paradigm assumes that water level is wrapped around a ball. So in other words, the Earth is level. It's either a level that's curved around itself to create a ball, or it's a level that's horizontal. Now, intuitively, everywhere we go, we operate with horizontal. We don't operate with curvizontal. So how do we know that the whole Earth is actually truly horizontally level and not curved back around itself? Well, that's very simple. If the Earth is covered in water, and water must be level, then that means that the entire 71% of the Earth covered in water has to be curved. So all you have to do is do a sufficient sample size, accurate enough to the test to tell you by within a threshold of tolerance whether or not that water is actually curved. So if you take a laser and you use a laser transit methodology and you shoot it over 25 miles of water, you actually can hit a target plus or minus a few feet that debunks the globe geometry by 2 orders of magnitude, demonstrating that the level that we all experience is indeed horizontal and not a giant curve. And then if you extrapolate that out based on the known physics of water across 70% of the territory, you end up with 70% of the territory a flat level baseline called sea level, and the highest mountain and the lowest trench in the ocean being, hold on, real quick. I'll finish with this. From the highest mountain peak to the lowest trough is a span of 13 miles, over 197 million square miles. That means not only is the Earth flat, but it's very flat. Go ahead.
Okay, well, say it is flat. What difference does this make? What difference does it make that
Fair enough.
Scientists have been lying to us? I mean, what's the big deal? I don't understand. Like, what would be so I mean, it would be groundbreaking to learn that the Earth is flat, but like, what significance would it pose to discover that the Earth has been flat this whole time? I don't understand. Like,
well, it will change. It will change some of. So the great metaphysical questions: who am I? Where did I come from? Where am I going? All those things, right?
There's no definitive way to know. We can talk about lasers, we can talk about measurements, this, and that. We can talk about all that all day long. There's no way to actually truly know. So, like, what's the point?
You experience it every day.
What's the point?
What are they getting for blind?
The point is, dude, that it may not matter to you, and that's fine if it doesn't matter to you in particular, but it does matter to some people. Okay, and the truth is the truth, no matter who it matters to.
I'm not disagreeing that it matters to people. I'm just saying, like, what's the significance of arguing about the existence of a flat Earth? What's the point, man?
We just don't like liars in our society.
Do you mean what's my point in doing it?
Well, like,
or do you mean like the greater existential point?
The existential point? What are we going to do to the liars if we find out they were lying about the flat Earth? What's your guys' end goal here?
Most of them ain't lying, dude.
What do they gain from lying?
Most of them believe it.
Why would a collective group of anybody lie about the flat Earth?
Dude, to change the human's conditions, assumptions about the great metaphysical existential questions. There you go.
There you go.
From your metaphysic and your answer, yes, correct. From your metaphysic and your answer to those questions alters your behaviors. Now, it may not on a small scale, but it does on a grand scale. And not only that, but sometimes you don't have to, because it doesn't matter what you think. It only matters who the people or the entities that are engaged with it.
What I think doesn't matter to you. What I think doesn't matter to you. That's really what you're saying when you said that.
No. I'm saying people's motives that are able to control you. What you think of their motives doesn't matter in the sense that their motives are their motives. If you don't agree with their motives, if you don't think their motives are worthwhile, that doesn't matter because they think their motives are worthwhile and that they're the ones doing it. So their opinion of their motives is the only opinion that matters of whether they're going to do it or not. But thank you for moving down the 5 stages of grief from the fact that the earth is flat to now you're coping.
Buddy, you really thought you got one over on me? You're not going to convert me to a flat earther, man.
No, dude. We know because your coping mechanisms are too strong.
I can't comprehend this elaborate theory of the earth being flat. Is that what you're telling me?
No. You did comprehend the elaborate theory of the earth being flat, and then you went into the motives. You can't comprehend the motives. You do comprehend that the earth is flat.
Okay, so dive deeper into the motives. You still haven't really given me very much example of what a motive for the earth being.
The existential questions. Holy crap, dude!
The gain from that.
Imagine your rebuttal. Your rebuttal is, I told you to alter humanity's answers to the great existential questions, only the most important questions in the existence of mankind. And you think that doesn't matter. Just dismiss it out of hand.
Dude, you're just saying, what? They can control what people think? Is that the motive? They can control?
Dude, what if I told you the reason was $1 trillion? Would that tickle your fancy?
No, if we all found out that the earth is flat, then what? We're just all going to rejoice and be like, wow.
Well, hold on. Let me answer that dude's question. You're right, sir. Some things are more important than money. Some things are more important than trinkets, okay? The fact that you can't comprehend that some people would be motivated for things that are beyond the scope of monetary or selfish gain, for some kind of self-deluded service to mankind or attack against mankind. Look, if you don't understand that some people at a quote-unquote elite level would operate that way, I mean, that's not my problem. That just sounds like you don't have an imagination.
Are you religious?
Well, it depends on what you mean by religious.
What do you believe in? What's your definition of religious?
Oh, my metaphysic, dude, is that the entire reality prior to existence, which means to come out of, was the thing of which everything came out of, which is itself the grounding of reality, which is an eternal, sentient being.
So the universe is a being. That's what you believe? The universe is...
The universe... No, hold on, brother. The universe would be something that exists, which means it came out of that being. So, no, the being itself isn't the universe, no.
Bro, you really like your philosophical takes, don't you?
Well, dude, in order to do anything, you have to have a philosophical groundwork.
Yeah, but when you're talking about the flat earth, you kind of have to, shoot from the hip, man.
No, I'm not shooting from the hip, dude. It's very simple. Throughout antiquity, it's been well established that the majority of people on the earth...
You gotta break it down, man. You have to break it down in layman's terms. You can't use all this mumbo jumbo that you've been using. Okay,
fair enough. Yeah, so I'll make it very simple for you.
What the fuck you're saying, dude?
So the eternal being created the world to be what it is. It's true. And then there's evil, which is against the truth, and they're against the eternal being. So in other words, for lack of a better term, you have God and you have Satan. You have the good and you have the evil, and it's being played out on a grand stage. And humanity is the pawns for which it's being played upon. And so humanity's beliefs about the Creator and about their place in the universe are drastically altered with their metaphysic and their cosmogony, which means where everything came from, and their cosmology, which means what's everything doing right now. So yeah, there's a lot of reasons why people will be interested. And keep in mind, I don't limit my reasons to just human actors. Okay, I'm fully aware of the fact that there are greater entities than just humans playing around in reality, sandbox, bro. Now, you may laugh at me and say, oh, that's just a stupid religious thing from a stupid religious book. And then I tell you, oh, you mean the book? No, I'm not saying you, dude. I'm just the royal you. because people do this, so it's just a response that people give when you say stuff like that. But listen, I can make my conclusions without citing any religious text. I could cite a book written by an evolutionary biologist. I could cite a book written by an evolutionary biologist where he was working with astrophysicists and other evolutionary physicists, and they all came to the conclusion based on modern experiments that the fundamental unit of reality, when you get down to the smallest state of time, the smallest state of matter, and the smallest state of energy, that what is the core underpinning of those things even existing is an eternal sentient agent. So they believe it, and I could just quote them. They're straight up evolutionists. They're not specific theists at all.
You said an internal sentient agent?
Eternal.
Oh, eternal. Oh, yeah.
Uncaused. Non-temporal.
I appreciate you going a little more in depth, but I think we're getting a little off track here. This is the flat Earth.
Well, dude, you're the one who asked. You're the one who asked why, rather than focus on the facts.
You went on a little tangent. You did go on a little tangent, brother.
No, dude, you asked.
Dude, how else? Listen, how else could you answer the question why? For example, this granite countertop. Just check this out, brother.
Of the universe.
No, it's important. That's relevant to why. So, for example, I have my granite countertop.
I don't really think
right
so,
now.
Man.
It's brown.
Granite countertop.
It's brown. Well, it's just what's in front of me, and it's flat. It's brown. It's got some black and some gray. It's got rounded edges. It's a certain length. I could tell you all of those facts, but I could not tell you why the people who originally chose this design chose it. All I can tell you is what it is. I can measure it. I could take out my tools and measure this countertop and give you all the particulars.
Okay.
None of that information tells me why.
Okay, you live in a dirt ball or a dirt plane. What does it change? What shape is of the dirt changes the fact that you're living on it.
Right. So what?
Understand how to build things.
What? No.
Fuck, dude.
What do these people gain from changing that perception? What do they gain from that?
Here we go again, dude. Here we go again. Is it me that wants to go down this track, or is it me that wants to go down this track, or is it you?
Are you afraid? Are you a scared person? Do you need someone to be afraid of? I don't understand. I just don't understand that.
See, dude, you're going. Listen, you're now moving on. You're now moving on to another stage of grief called Cope 2.0. You went from Cope 1.0, now you're in Cope 2.0.
Well, you are the AI Overlord 2.0, so I don't know why I'm in Cope 2.0. You're the AI Overlord.
Dude, not only am I the AI Overlord, but I'm from the future. And in the future, everybody realizes the Earth is flat. They look back at people like you from the past, and they're like, and including me, because I used to be a Glober, and they're like, wow, people used to be retarded.
And what, the world's just going to get better because we all know it's flat?
No,
doesn't matter, dude.
Retarded.
The shape of the Earth doesn't cure the human condition. There's still going to be evil people in the future, just like there was in the past.
Matter?
That's what I was going to follow up with, because you must have obviously left the future for some reason and had to come back
here where
it was better for some reason.
Right, listen, let me ask you this question. Let me ask you this
here
question.
For a reason, right? What's the difference? What's wrong with the future?
Let me ask you this question. Why is it? Hey, Dora, let's see if Dora can answer. Dora, why is it that these guys it matters to them why it matters rather than the facts of what it is? It's like they're in denial because they know it's true that it's flat, and now they're trying to cope after the fact. Like, why did mom have to die? Why did God take mom away? Your mom's dead, bro, and the Earth's flat. I'm sorry.
I think it's just funny to get this upset over something that is not even known or even possible to be true.
Since we're dealing with people like you that are just nuts.
I already demonstrated to you that the Earth is flat decisively. You had no answer except to ask, why does it matter? Which we all know means that your cognitive dissonance is now trying to protect you from the truth.
What's up, Evening Star? Why are you muted? Speak, or I will mute you again.
What's up, man? I just saw that you muted me.
Yeah, what's up? Why were you muted?
I have no idea, man. I think I had a conversation once here and somebody muted me for like maybe the channel owner or something.
Another channel didn't mute you?
No, I think it was here.
Okay. What brings you to the FE chat?
I'm just interested to hear some like different approaches, you know.
Truth. You said you've been here before, so what did you hear last time you were here?
I mean, it's cool to hear, you know, different opinions.
Well, what did you hear? What do you remember hearing last time when you got muted?
I don't remember quietly, but I was probably trying to prove some point, and somebody maybe did not like it, and I got muted. What do you say? Who's speaking? The cyclone. Yeah, go ahead, man. Yeah, it was the middle of conversation. I don't quite remember. I don't even remember that I was muted. I think I left before I saw it.
Okay, so you don't know any of our arguments or our positions on this?
Not really, no. Usually I join in the middle of conversations and then I like try to participate, you know.
Okay. Well, I mean, if you want to know, we can have a conversation.
It depends. Like, if you can trigger the topic, it would be great, you know?
Okay, well, basically our position is that the Earth's surface that we live on, despite what we're being shown in the media and in textbooks, is not a curved surface. It's not a spherically curved surface. Like, the bodies of water are not curving down and away from us like they're showing us in these images of a ball Earth. And that can be measured by long-distance observation, laser tests, basically surveying big chunks of water, lakes, shorelines, things like that. So, given that there's no curvature, there can't be a ball. So that's basically the position. And for 10 years, we've been asking people, well, show us who's measured this curvature. And there's no measurement. There's just inferences. They'll say, like, Eratosthenes, he measured these angles from the sun, casting a shadow, and then they'll just assume a ball and then do some maths around that. But as it comes to, like, direct measurement of a drop over distance curvature, it doesn't exist.
Right. Like, I want to hear your opinion. Like, you're a flat earther, right? Like, I want to hear, like, what is your thoughts about, like, the edge of this flat earth? Like, do you think
that would be like,
how does it look like, you know?
Well, I don't know what it looks like, but I mean, it's almost like asking what's at the edge of reality, right? Because the whole, like, shift you need to make in your head is that when we're talking about flat earth, we're just talking about reality, what we experience every day, right? The earth.
So if I start to walk, let's say, from a certain point and I get back to the same point, does that mean I just mistakenly lost my direction and went back to the same point?
Yeah, well, you'll have had to have walked in some kind of circle to end up back where you started. You can't Pac-Man from one side of a place to another in this world. So yeah, you'd be walking in a circle. I mean, if you talk about circle navigation, that's what that is, circle navigation.
Right. So you think there is no way to go and explore the limits of this flat?
No. Like, you and me, members of the public with jobs, no. I mean, loads of places in the world are off limits to the public, right? They're under military purview or they're environmentally protected. And these are the instruments they use to restrict travel from the public. So we can't go wherever we want to go. I would say there is likely a finite limit to this place, this system that we're in, but where it is I wouldn't be able to tell you.
Yeah, interesting though. Very interesting.
Yeah, I don't know if anyone knows.
It's very interesting because at the individual level, like, it's difficult to prove either way. Huh?
Yeah, it's impossible to prove that it's a globe in space. It's very possible to prove that it's a topographical motionless plane, but you can't prove how big it is or what quote unquote shape it might be. Like, we're just talking about you know what, you heard the term empirical. You know what empirical means?
Not really, but yeah, I can Google
it. EMPIRICAL, and like empire, empirical.
Oh, empirical, yeah, with E. Okay.
Yeah, with an E.
Yeah, go
You know
ahead.
what that means?
Go ahead. Yeah, I just saw it.
It's the foundation of science, right? It's what's observable, measurable, experienced in reality. Yeah?
Yeah.
So not theoretical, not some theoretical math or some hypothetical. What is actually observed and measured. That's what we are interested in. That's what we talk about. Anything beyond that is just imagination as far as we're concerned. So when you look at the empirical evidence, it only gives us flat, motionless, and contained. Right? The system as a whole, it's contained. We're not open to a vacuum. It's more like a terrarium. You heard of a terrarium? You know what that is?
No.
Yeah, it's another one to Google. TE.
Is it like that kind of how you call it, like greenhouse sort of thing?
Yeah. Yeah, it's like a fish tank, but without the water. It's just a closed tank, and you put like earth and seeds and water in it, and it's a totally closed system. And the plants will grow, and life will flourish, and the water and the gas will create their own cycles within this little system, just like we have on Earth. So it's called a terrarium.
Basically, we've been like in a big terrarium since forever.
Yeah. Basically.
Everything controlled, all the reality.
Yeah. It turns out that we are in a greater being's construction, whatever that is. Yeah.
Yeah, I got you, man. Very interesting.
Yeah, it's very interesting.
Do you have any idea at an individual level? How can I prove like this flat Earth theory
long distance
or
observations.
reality?
Yeah, long distance observations.
Yeah.
You can test how far you can see across the surface, and you can prove that you can see too far for it to be the globe that they say, because the globe puts a physical limit on how far we should see due to the curvature. But that physical limit, when tested, isn't there. You see way beyond it.
Yeah, gotcha.
So just like the nature of water itself, right? The nature of water is that it takes the shape of its container, and when it's at rest, it'll find level. The surface will be flat. Yeah.
So in that case, gravity also is definitely questioned, right?
Yeah. I mean, gravity, in as far as the theory or the theories, right? Because we agree that some things fall down and some things rise. The difference is what's causing that, and even the globe side, they're just theorizing about it, and they'll openly admit it's just a theory, right? The bending and warping of space-time, it's just a theory.
So gravity theory will fall in that case.
Yeah, we don't need you only need gravity if you think you live on the outside of a giant spinning ball. They had to come up with a story as to how we could possibly be stuck to the outside of a giant spinning ball, because you'd think, just using your natural logic, that you couldn't be on the side of a spinning ball, you'd be chucked off of it.
But hold on a second, like, have you ever tried that experiment, like, of holding a cup of water and like trying to spin that cup of water, and the water won't like how it once
Yeah, you're
filled.
talking about like if you have a bucket of water and you swing the bucket.
Yep. Exactly.
Yeah, but
like it won't spill.
The globe is not a bucket. Try turning your bucket into a globe, putting water on the outside. What's going to happen to it?
Yeah, but if there is a gravity, maybe like a force that will.
Yeah, exactly. That's what I'm saying. They have to come up with that story. They have to come up with that story, but you can't demonstrate that. In your demonstration, you turn that bucket into a ball and put water on the outside of it and swing it around. That's going to go flying off. And then they'll say, yes. But if you have a really big ball, bigger than we can possibly ever feasibly test, then it works. And you just have to go, okay, I guess so. I guess I'll trust you on that. So it's undemonstrable.
Yes, it's not demonstrable at the individual level.
It's not demonstrable at any level. It's not. They can't even model it.
But you agree that when I spin the bucket of water, like I can manage to get the water.
It's a different thing. A bucket is a different thing. It's because it's the water is still wanting to leave in the same trajectory, but it's contained by the bucket. But the globe model isn't containing it.
I got you. Yeah, that's fair enough.
Yeah. So all natural law, observation, physics, and everything, it debunks the globe when you actually think about it and look into it. The only thing that supports a globe are images and stories from the government, basically. That's it.
I mean, that's pretty much it. Like you cannot really discuss those unless you have the possibility to prove something at the individual level.
And you hear now NASA are classified as an intelligence agency, like the CIA.
No.
Which means they can legally lie and withhold information. So they're effectively a propaganda agency, and now they've effectively just admitted it. I mean, they always were, but now they've essentially just admitted it.
I personally checked like the NASA website and some data on the moon, like how I call it, moon mission. Apollo. There was a lot of manipulation in the information there. So
that was just propaganda. That was just propaganda to make people think that the United States is technologically superior.
But besides that, I look at the moon, right? And when you look at the moon, you don't need anything, camera or anything, but it's clearly that the moon is kind of spherical. Because with your eye...
Even that you don't know. If the moon is well, think about it. You're saying the moon is a spinning ball, right?
I don't know if it's spinning or not. I cannot tell you this. I did not make my own experiments.
Well, we only observe one circular face, right?
Yeah, but circle face. But if sometimes in the moon
unless you travel to it and around it, you wouldn't know that there's another circular face on the other side or a spherical shape to discover. We actually can't confirm that.
But you know that there is craters on the moon, right? Surface. So
there's things that we call craters. Again, without going to that place and walking around it and seeing that they're actually craters, we've got no idea what we're even looking at.
I mean, the biggest ones there are visible, almost with your eyes, you can see them.
You can see what we call craters. For me,
the moon. Me personally, the moon, I kind of see and perceive it, without having to do any crazy experiment. I can tell that it's spherical as much as I can tell you. Basketball or something is a spherical thing.
No. You can't hold the moon in your hands like you can hold a basketball in your hand.
Definitely not, but at least
you can believe it.
It's visible
for sure. You can believe it's a sphere, and maybe it is. Even if it was, the Earth isn't. That would
it's not my point. My point is not. My point is not to say hey, the moon is spherical, then automatically the moon, like the Earth, is also spherical. But my point is like, hey, look at that, like spherical shape. It exists. It's possible. It's not something that I need to wait for government or NASA to tell me to.
Well, you do though, because you don't. I mean, really, all you know about the moon is what you observe. You don't know anything about it being physical land with craters on it, or a sphere, or a rock that's reflecting the sun. All of that has come from the government telling you.
Well, I don't know at this point, to be honest with you. But the moon, I'm personally convinced that, like.
Yeah, that's fine. You can be convinced about whatever you think, but I mean, throughout the course of human history,
not Earth.
Yeah. No, I get that. I mean, people throughout human history have all had loads of different theories about what the moon is. What are the chances that you're correct? Probably pretty slim. I'm not claiming that I know, but
yeah, I get you, man. I think there's a guy here. I heard like that. This guy, Visitor, maybe he wants to add something. I'll get muted for now and just listen to the convo.
Okay, no worries. Well, yeah, if there's another guy who's got a question, feel free.
I don't even know what you're discussing. Just came here.
We're discussing the Earth and whether or not it's a ball, like they've told us. What do you think?
It's not a ball, of course.
You don't think it's a ball?
It's not a ball. It's not a circle either.
What do you think it is?
Similar to circle, but not circle.
Like an oval?
Could be.
Could be. How'd you figure that?
There's this law of charges, law of matter.
Law of matter.
Yes. How particles have special force.
Go on.
That's it. I don't have much to add onto this conversation. I'm curious to know about your thoughts.
What do the particles do?
What they do is they attract each other.
It sounds a bit like you're talking about gravity forming balls in a vacuum, like the globe.
Gravity is about, same concept. Masses attract other masses is gravity.
Now, is that a theory or is that reality?
It's reality.
Okay, where have you seen these things attract each other and form into balls?
Experiment lab.
Yeah, which experiment has shown particles forming into balls due to gravity?
I don't know which one. I mean,
well, I'll tell you, there isn't one. They can't even simulate it.
Are you sure?
Yeah, that doesn't happen. Not in reality. It's just a story.
Whatever doesn't happen needs to be proved.
It needs to be proven that it does happen. If you say it does, if you say this thing happens, you have to prove that. And if you can't prove it, then we can just dismiss it.
Yeah, that defeats the whole point of proving stuff.
No, because the way it works is, if I say, for example, I have a unicorn, the burden of proof is on me to prove that I have a unicorn. It's not on you to prove that I don't have one.
There is no burden in proof. There is not something called burden when it comes to proof.
Yes, it's a well-known concept in logic and law. You can Google it. Burden of proof. Google it. It basically says he who is making the claim must provide evidence for his claim.
Well, I'm not making any claim.
Okay, so you're not claiming that particles come together and form balls due to gravity.
I just saw it. I don't know how.
You didn't see it, though. You don't see it. Remember, you said some experiment, and I said which one, and you said you don't know.
I don't know what they did.
And they just told you this. They just told you a story. That's all they did.
Could be. Could be. It could be they were lying to me. Yeah, you're right.
Or not even lying. Maybe they were just believing like you were. Maybe they just heard the story like you did, and they just repeated it to you, like they had it repeated to them.
Yeah, that's true. Could be.
Yeah, it's true, because the Earth is not a ball. So it can't have been made into a ball by gravity. That's not what it is.
Yeah, they're not lying. They just don't know.
Well, your teacher, whoever told you that wasn't lying. They're just believing like you are.
Yeah. Why would they lie? I mean, yeah, you're right.
There might be some people lying, but your teacher isn't one of them. They're just another believer. And who do they all appeal to? NASA.
I think NASA is trying to get us into trouble. They're trying to control us. That's why they're manipulating our thoughts.
Could be.
I think NASA is the real enemy.
They're an intelligence agency, aren't they? So they can lie professionally.
Yeah, they send people to the moon, and we don't even know they are on the moon because we don't see. There's just photos.
Yeah, they didn't send anyone to the moon. That's just propaganda.
Yeah, it could be the AI was created way earlier. They just generated those photos, or maybe they just created something moon-like structure. Maybe sand or something. They were standing on sand, created. Take pictures and send us, and like moon.
Well, very easy. It's very easy to fake images and videos.
True. I saw my friend was faking his girlfriend. He's using AI.
Yeah, sounds about right. Yeah. So most people are just basing their entire worldview on images and videos that could easily be fake.
Yeah.
Yeah.
You're right.
Yeah, that's why we like to go and check. We'll see if there is actually a curved surface for there to be a globe. And there's not. So there's no globe.
Maybe I should do it myself. See it with my own eyes.
You should double check. You should double check that whole story about you living on a big spinning ball of water and gas in a vacuum.
Yeah. I don't think it's a circle, to be honest. Because when I walk, it's flat.
Well, circles are flat.
Circles, they have curve, right? They have curve like a ball.
Around the edge, no, not like a ball. Ball has a 360-degree curvilinear surface. A circle is just a flat surface.
Ah, you're imagining a sphere.
Sphere, yes. Sphere is what they claim, not circle.
Yeah, sphere.
Yeah, that's what they're teaching all the kids in school, that it's a sphere.
Maybe the color that we see, when I see red, maybe you see it's blue, but the way they teach us about colors, that's why we assume that it's...
Well, that may be. There are people who are colorblind, but we all see a flat horizon, don't we?
Mm-hmm. No, what happens is when I see a tomato, it's red for me.
As well as a flat horizon, we all experience a motionless surface, unless we're in an earthquake, right?
Yeah, you're right.
So you experience a flat, motionless Earth every single day, as does every other person on Earth.
Yes,
so we all actually know. We all actually do know that it's flat and motionless. We just have the government telling us, "Oh, it's actually a big spinning ball. You can't trust your senses."
Yeah, I think it's all government propaganda.
Well, even if you don't, that is what it is.
Mm-hmm. I believe you.
You don't have to believe me. Just go outside.
See, for yeah, I see myself. It's not a sphere. It's flat surface.
Yep, and motionless.
Yeah, it's obviously it's not moving. If
Correct.
it was moving, then I would be moving also. But I'm sitting
You
here.
would. Yes, you are. Still.
All right, enough with this conversation. I can't do.
Welcome to reality, my friend. I know that was uncomfortable, wasn't it? You acknowledged reality. That's uncomfortable.
Yeah, that's very uncomfortable and funny also.
Yeah, what's funny about it? You're just sitting still, right? You're not moving.
Yeah.
Or do you think you're moving now? Where are you moving to?
Yeah, I'm not moving. That's for sure. If I would be moving, my wire will get tangled.
Oh, you've gone back into it.
Yes.
See, but you think the ground is moving.
If the ground was moving, then my feet were maybe they will. I would feel it.
Oh, is that what they say?
Yeah, because when you travel in bus, you feel it, right? The bus is moving, but the ground is not.
Well, this would be like sitting on the roof of the bus if the bus was spinning around at 1,000 miles an hour.
Mm-hmm. But even when
but they tell you you wouldn't notice that.
Yeah.
Don't worry about it.
Yeah.
No, it has to be true. They've given us images and videos. All the scientists agree. You must be spinning around in your chair. Hundreds of miles an hour. Millions of miles an hour. Yeah, none of that's true. Surprise, surprise. You're not moving. Have we got anyone else? Any other new people in? Questions? Don't be shy. Hey, ladies man, welcome back. I heard you the other night.
Like
you on the mic? Yeah.
You were there?
No, I wasn't there. I just heard some of the replay on YouTube.
Oh. You watched that? Isn't that like a few hours?
No, I didn't watch the whole thing. I just heard bits of it. But I heard you speaking and saying that you were taking some notes.
Oh, no. Not actually. Oh, no.
I want to hear some of the notes that you took.
Why?
Curiosity.
Curiosity?
Yeah. Like, what are you writing? What are you noting down as important from our conversations? Yeah, I'm curious to see what you wrote down.
I don't know. I mean, it's nothing like important. If you think it's like some like I have some hatred towards you with these notes, I don't. I just
No, not at all. I don't expect you to have some hatred towards us. You must have some kind of appreciation of us if you're listening to us and taking notes. I just wanted to hear what those notes were. Just give us an example. Read off like a bit.
One of the notes I wrote was they don't seem to have the same drive to convert people to the globe. Like, not all, but some of them I've noticed they just, with my personal experience, they just seem to just want to beat the person in a debate. While I've talked to other flat earthers that I felt genuinely just wanted to give you a new perspective and, like, in a nicer way.
Okay, so you're saying you were listening and you thought some people were just trying to debate and other people were trying to pass on the information. Is that what you mean?
Yeah, some people didn't seem like they truly wanted to convert them to the flat earth model. They just wanted to debate them and win.
Well, see, none of us are really trying to convert, quote unquote, anyone into any kind of model. We're literally only talking about empirical reality. We're not talking about models and concepts.
All right.
So I don't think anyone's doing that, but I can understand maybe where your critique would come from, saying that some people are just more wanting to debate it. But I think that's just the internet and some people's way of discussing the topic, you know. All right, give us another example. What other note did you put down?
I'll give you like 3 max. Well, there's a lot in here, but I'll give you a 0. I don't know. It's like about a page, but Indio. I put he seems. I don't know. He doesn't seem that nice.
Oh, Indio doesn't seem that nice. Someone tag Indio.
Okay, maybe let's not get him in here right now.
That's all right. He'd enjoy hearing the critique. Okay, you don't think Indio sounded nice? Why don't you think Indio sounded
like
nice?
His other half? Because they seem to both be like similar.
What? No.
They both have like an Asian person as their PFP, and like I see them together a lot in the other server.
No.
Just wondering. If he gets in here though, I'm.
That's all right. That's all right. You don't need to worry. He's a nice guy. He's just, you know, just imparting information. What didn't seem nice about him? He was passing on information, wasn't he?
Alright, before I say that, Indio, I don't hate you. I'm just saying that if he's listening somehow, maybe this is also on YouTube, but
yeah, we're on YouTube 24/7, by the way, just so you know. We're streaming all the time.
Right. I didn't. It's just I don't know. Sometimes I ask a question, and I'll be like a genuine question. And I think, like, I feel like he comes off as like just instantly like, how could you even think that? Like, did you even just hear what you just said? Like, trying to bash the other person instantly. Like, chill out, bro. I barely said anything. And sometimes people go on like tangents on me, and then like my first claim is like they're not even on that anymore.
Yeah, and I think for something like that, you just have to keep in mind that we've heard the same arguments like 10,000 times. So they're probably just cutting to the end of the argument just as you're starting it, and you're thinking, why are you jumping down my throat? But they're 10 steps further through the argument already. They're just getting to the conclusion and saying, no, this is a fallacy or whatever it is. But, okay.
Yeah, I can tell.
So Indio's not nice.
Like me talking about this. I'm sorry, guys. I don't want to talk about this.
No, you're fine talking about it.
I was asked.
It's fine. This is feedback. I'm just curious what your note was. All right, so give me one more of your notes. Was there anything like relating to the Earth, the subject, like that you were like, whoa, this is interesting, I didn't know that? Or is it all kind of just about personalities and things?
It's not all about personalities. Like I wrote down about the ice lake, and how like I was able to see like more than 3 miles and still see the lights.
Okay, what does that mean?
I don't know. I put my thoughts out. It was very interesting. Said maybe light shining through the ice, but
Light
I don't
shining
know. I
through
wasn't
the
there.
ice.
I mean, I don't really know. I just wrote it was an interesting observation they made.
Does it seem like they're shining through the ice?
But I did see that like parts like the it was like half the light. It was like some of the lights were like barely visible. But
yeah, descending towards the horizon.
already.
It's still above the horizon.
How far is it again? Like more than 3 miles?
Yeah, I can't remember which one you're talking about. If it's the Frozen Lake one, what's that?
It's in like the side chat.
10 miles or something? I can't remember off the top of my head. But okay, so, well, I mean, do you understand the other possibility of that observation being that they're just seeing the lights because they have a direct line of sight to the lights?
Sure.
And you understand that that would mean that the globe model is incorrect?
I don't know if that alone disproves everything, but it's an interesting observation.
But if it disproves the curvature, that effectively disproves everything, yeah.
I don't think anyone ever said the globe is like a perfect sphere. It's mounted.
No, but it's perfect. It's perfect enough that mathematically this would still debunk it.
Right.
Interesting.
Okay, so that's a good example of a good note. Something relating to the subject matter, something interesting.
Right.
Did you take any more notes like that?
Yes.
I can't. I wrote how you guys were saying that it seems that someone had just made the globe model, like the spinning person, with the spinning globe, and then had to add to that, like, okay, how is someone gonna stick to the side of this globe? You'll just get flung off, and that's how gravity was made. Someone just came up with that because it didn't make sense.
Sorry, you're saying that you heard someone here saying that they came up with gravity?
I heard you guys talking about the spinning ball, how like it was just like someone said gravity so they can make sense of it.
Okay. What is your understanding of gravity?
I learned about it in school, like mass attracts mass.
Right.
Like the larger it's based on two variables, the mass and the
hold of. Don't worry, I've got a P1000 and I've also got the Vision Adapter 6200.
I mean, what it sounds like to me is just like a bunch of marketing hype. That, they'll build telescopes with it, but it doesn't actually do anything.
Well, that's why it'd be interesting to lay it down horizontal. So instead of shooting it up into clear air, lay it horizontal, like across a lake, anything large, and then specifically on days where there is a lot of air effects, a lot of heat and distortion and whatnot else going on. And it'd be very interesting to see what it does with that.
Yeah, true. I mean, thing about the adaptive optics, because it's all computer corrected, computer generated. This is like post-processing bullshit. It's CGI, is what I'm saying.
Yeah.
In the end, it isn't like, oh, we took a picture, we deformed the mirror, and then here's our picture. All of it's post-processed to create an image. You know what I mean? So it's, this is like that freaking. There used to be a guy that came into the old server, and he had a YouTube channel. He told us he was paid by NASA to make, he made videos about planets and shit.
Oh wow, didn't know that.
And it was a kid though. He's like 18, 19 years old. I can't remember his name, but he came into betas a few times. He could have been lying about that, but I don't think he was. But one time he said that computer enhanced images can be more real than the real thing. And I was like, what? How can something be more real than the real thing?
As per the expectations of the viewer.
Yeah,
so
exactly.
you go and get your average glober, they're expecting to see really, really, really cool pictures of Jupiter or Saturn or whatever the shit they're looking at. Whereas if you go there, yeah, here's a black and white image of some looks like bands around something. People are going to be disappointed with that. But if you colorize it and do all sorts of other cool tricks, yeah, it's all marketing.
Have you ever seen the Pioneer image? The Pioneer satellite image? Dude, it is so...
Is that the one that's taking the image of itself?
No, Pioneer was an old one. So, dude, you're going to laugh when you see this. So, Pioneer was a satellite they launched in the 70s. They sent it to Saturn and Jupiter. This is the photo of Saturn.
That's what it sent back.
Yeah. It looks like it looks like it's in colored pencil. That's how bad that is. Like, it's unbelievable how horrible this is. But because they're printing it in magazines, it was good enough. Okay.
Yeah.
So let me show you this one.
Okay.
What is it? Okay, here we go. Now we got this. The new and improved Saturn.
Ooh. High def.
Oh, I got an even better one. This one's pretty cuckoo.
That's not a photo, that's CGI.
You think? Here's a real good one. Look at that.
Oh.
I think they rendered that on an NVIDIA graphics card, or was it AMD?
ATI.
Yeah, ATI. I was going to say ATI too. How do you know?
Nah, it should be a Quadro for sure.
Well,
yeah.
can't you
Like to thank our sponsors, NVIDIA.
Yeah, it's got to be ATI. It doesn't have soft shadows. That's so crazy. Why is the backside of Saturn lit? Ain't that funny? So you got the Terminator line, right? And then you got the dark side. Why can we see the backside of Saturn?
Yeah,
Why
it should be
illuminated
black
compared to the shadow? You know what I'm saying?
Yeah.
It all should be black, not just the part on the rings. The freaking whole backside should be freaking black.
Do you want me to tell you what the Globetard excuse for it to be? The light reflecting off of the rings back onto the backside.
Yes, because that's how that works. It's being scattered, man, by all the ice crystals in the rings.
Haven't you seen a chandelier at home? Don't you know how that works?
There's some unobtainium in the rings, man. It's glistening. Is that the current thing with the Saturn's rings are? Are they ice or rock?
Oh, I wouldn't have a clue. Going so fast that it looks like a ring.
Billions of chunks of water ice, ranging in size from tiny dust-sized grains to large house-sized boulders. These particles
Now, that's something I want to
smaller
know.
amounts of rocky material and dust, believed to be remnants of comets, asteroids, or shattered moons. That's a freaking great story.
With our high-powered cameras and high-powered telescopes and all that kind of jazz that we've got these days, has anyone actually like tried to film it using like high-speed cameras? Like, you know, those
Like
slow
time-lapse?
motion guys that, not time lapse, but the other way, speed the camera right up so when they slow it down, you can actually, it doesn't show as a ring,
What?
it
That's
breaks it down.
interesting, dude. That's actually interesting. That
Because the rings are supposed to be there due to our perception of the dust and shit going so fast that it looks solid. So if we can slow that shit down, we should nearly be able to see bits and pieces of crap right through it.
That's right. That's a good point. Well, shouldn't they a single frame catch for that?
Well, that's interesting. Why doesn't it
Depends on
catch
the
for that?
exposure time, right? So you need
Correct.
a shorter exposure, right?
Yeah, short exposure time to snag it. And because you're always doing photos in the dark, you need a long exposure and you'll never snag it.
Well, you know what they're going to say to that? They're going to say, well, Saturn isn't bright enough to use a short exposure time. We have to use a longer exposure time because we got to capture more light.
Yep.
They could have did it when they were right there. When they're sitting right next to it, right? They're right next
Yeah,
to
when you're 1,000 miles from it, it should have been a whole shit ton of photos.
Well, I mean, according to them, they're
So-
probably like freaking 100,000 miles away in these photos, or even more. I don't even know.
So let's get this sorted out here. That's from Pioneer 1. No, the shitty one at the top was Pioneer 1. What was that? Those last ones, what were they off of?
Cassini. Cassini.
Cassini was released in the 80s? No, late 80s.
I don't know when they sent it. The pictures came out like in the 90s, maybe, or early 2000s.
Interesting.
And then it just magically stopped working. Only Voyager still works.
And what just still works. Interesting that. We got better shit than ever, and it's only the nasty old one still chugging away. It's having a great old time. All right.
7-year journey from Earth. It launched it from 2004 to 2017. Took 7
shit.
years to get there. It was launched in 1997. Completed its mission by diving into Saturn's atmosphere, burning up to protect the moons like Enceladus from potential Earth microbes. For fuck's
What? What a load of shit.
For fuck's sake, man.
What they don't want to give Saturnians the flu?
Yeah. Because microbes survive the vacuum of space, man. My God. Says it took 400,000 images. 450,000 images. Let's see. Where are the 450,000 images?
What, we just get 3?
You have to have an image archive somewhere. And not NASA's a raw image gallery. the main repository of raw data. Oh. Oh, this is great. And here's an image of Saturn. That's great.
What about when you get closer? Does it look flat too?
Yeah. It seems like there's a lot of. How many images are there? Well, 2,000
Now,
images. I wonder if they all look like this.
Something interesting. What camera did they claim was on Cassini? Because I just punched into DeepSeek what was the best digital camera for 96, 97. Because I'll assume the thing was built in 96. They launched it in 97. So at the time, the best camera on the market was the Kodak AP NC2000E in 1996. It was a 1.28 megapixel camera for 15K.
Yeah, check this out.
Those images are a little bit better than 1 megapixel.
They always have these stupid names.
All right,
Imaging
I'm gonna get a squash.
subsystem, a full camera instrument. I actually looked this up before. Now this is the narrow angle camera in the wide angle camera, but they made them acronyms because the NAC in the WAC. Both cameras were charged couple CCD imagers using a capture detailed multispectral images of Saturn's its moon rings. The narrow angle had a 2,000 millimeter focal length designed to capture high resolution detailed images. The wide angle had a 200 millimeter focal length camera used for broader context and wide field of views of the Saturn system. Both cameras used 1024 by 1024 CCD detectors. That's not even a megapixel.
So just to give everyone an idea,
isn't a megapixel what's the megapixel? Is it the size of the image it makes, or?
So DPI vertical times DPI horizontal, and if it goes over 1 million, that's a megapixel. What's interesting is
1,000 by 1,000. Yeah, so it's a 1 megapixel camera.
Yeah, well, that was the best shit at the time. But look at that image. That's higher than a megapixel. You click on it, and the reason I say that,
Dude,
at its native size,
bigger than 1 megapixel pictures, bro. I'm serious.
No, just size-wise, so people can get an understanding. Remember the old 19-inch monitors, and some people still use them that we use on our computer? That is 1 megapixel at native resolution. The square 19-inch monitors that everyone used to love so much, they are 1 mega. Oh, actually, they're 0.7 of a megapixel, but yeah. But anyways, I'm going to go down to squash and do some reffing. I'll be back for more reffing.
Yeah. I can't even find a 1 megapixel frickin' image on the internet.
Just like was it long distance observations or whatever earlier posted that was it Discover? The one they say is 1 million miles away, and they took a photo of Earth.
Yeah,
and I was thinking to myself,
Epic Discover, yeah.
Right, what sort of camera they got on that to be able to get that much detail from 1 million miles away?
I don't think they even have a camera on that.
They got the P1 million.
Yeah, the P1 million.
Like the Himawari, it's like it's not an actual like camera. There's no like camera lens. It's just like a fucking mirror. According to their spec, it's a mirror reflecting onto a multispectral sensor. And then Himawari team won't like, you can't even get like their raw data. You have to get like second or third hand if you're a researcher, right? If you want their raw, like what they consider raw data, you can't even get it. I think the Epic Discover, let's see what their bullshit is. I know I looked this up before, and I didn't think they had a camera either.
Yeah.
The Earth see, here we go again. EPIC means Earth Polychromatic Imaging Camera is a 10-channel spectral radiometer aboard NOAA's Deep Space Climate Observatory, which is also an acronym. That's what Discover is. Fucking stupid losers, man. I hate acronyms. Unnecessary acronyms. Takes 10 images using narrowband filters to produce high-quality full disk images. I want to know the camera specifications, Tony.
But from a million miles away?
Of course. It is a 30-centimeter aperture Cassegrain telescope. It captures 2048 by 2 megapixels. 2048 by 2048 images of the sunlit Earth from the L1 Lagrangian point with a spatial resolution of 1 kilometer per pixel. That's nonsense.
Yeah, that's insane.
Even if, let me see, do the math real quick. Okay, maybe that's 10K.
By the way, India, it might just be me, but you sound really low, and T-Dub sounds really loud, and I got you up to like 200.
Oh, sorry, man. Yeah, I thought the same thing. I've got everyone turned up.
How about that? How about now?
Loud and clear. You're good.
Yeah, better.
Right. It's down at my mic was turned down to 48. I don't know why it was down there. Where was I? Oh, okay.
But yeah, megapixels.
So 2000. So
Well, I wasn't trying to interrupt you. My bad.
no, it's fine. I'm looking something up. So I'm trying to figure out what the actual. So if it's 10 kilometers per megapixel means that it would have to be 12,000, 1,200 pixels across. Okay, that works out. So it's 2 megapixels. It's 4 megapixels. CCD. It's a Ritchie Christian Cassegrain telescope. Smart spectral channels, 10 kilometers per pixel. Sampled at 1.07 arc seconds. I don't even know what the fuck that means. Now, hypothetically. It's just a smear because it doesn't have subpixel. We need sub. Yeah, man, 10 kilometers per pixel. That means in 100 kilometers would be 10 pixels. Will be a little 10 pixel strip. Exposure time 20 to 100 milliseconds. Operating temperature negative 40 C. The Epic onboard NASA's Deep Space Climate Observatory satellite underwent significant post-processing updates, resulting in a new collection of enhanced, color-balanced, brightness-adjusted images. Since 2018, the multi-angle implementation has an atmospheric correction algorithm. Who was saying that shit the other day? Oh, we listened to Rob Simmons saying that frickin' they didn't have the color for the Earth. Calibration. Because Epic has no in-flight calibration, data is processed using vicarious calibration, comparing it with MODIS for visible channels and OPS-NM for UV channels. Oh yeah, what I was just saying about Laser Guide Star. Seems that they haven't actually done it yet. They have never successfully done it. Yeah, ESA made it. I guess they have problems. Has 3 main challenges to overcome: Larimar precession, recoil, and transition saturation. I guess the idea is to illuminate sodium atoms located in the atmosphere at 90 kilometers altitude. How come everything happens at 90 kilometers, dude? And 100 kilometers? Why is everything happening right there?
Yeah, right at the Kármán line.
Yeah, exactly. Everything happens at the Kármán line for some reason. You know, when they launched the Falcon Heavy, like the last reading that it showed of its altitude was at the Kármán line. It was like 110 kilometers or something. And it stayed that way, even though it was supposed to be a car in frickin' space. It just stayed at 110 kilometers.
Interesting.
You know, like that's something I watch, and I've been watching for a long time. These launches to show the altitude, they always stop at some point and don't show the altitude no more. It just freezes, right? They just freeze it at some number. Yeah, it looks like it just from rereading. It just looks like a big another government make work program. Keeps some frickin' astronomers employed. What a fucking useless fucking human activity, dude. Like, seriously. Can you seriously think of a more useless to humanity human activity? Like, jerking off in a fucking cup as a profession would be more useful than that. But I'll give it to them. Astronomers, they must be really smart to fucking dupe the rest of the public to pay for them to fucking stare at the stars. That must be, they're fucking geniuses. Hey, son, what do you want to do when you grow up? Daddy, I want to stare at the sky. Son, that would be great. I'm so proud of you. I want you to do something completely fucking useless.
I'm gonna a big gay stargazer.
It's like that Seth guy from SETI. Is it Seth? Oh, I can't remember his name now.
I think you're right. Seth from SETI. Yeah, I think that's right.
Yeah. Yeah. Spends all these days waiting.
I mean, I'm serious though. Can you think of a more useless human activity? Like, I can't think of one. Like, even if everything they thought of was right, so what? What does it change? It doesn't mean anything for us.
Right. But we might learn more about the origins of the universe.
Then we can know when we're gonna die. That's their thing. I mean, I got a Hubble clip about that, right? They're just like, and we'll be able to predict when the freaking sun explodes in 1,000,000 years. Like, who gives a shit? No one's gonna be. Why do I care if the sun explodes in 1,000,000 years, dude? As long as it isn't this week.
Yeah, there was an Outer Limits episode of that. They realized that it was going to go off in like a week or something. Or it had started and that nobody had predicted it. They didn't realize. Yeah.
Hello, guys.
Oh, hello, girl.
So, what's going on here?
We're talking about the most useless human profession, if you can call it a profession.
Okay, so what was the outcome?
Astronomy. Being an astronomer.
Ah.
I can't think of anything more useless to humanity than being an astronomer. I mean, think about it. If your kid came to you and said, Daddy, want to know what I want to do when I want to grow up? And you said, I don't know, son. And he says, I want to stare at the sky all day. You'd be like, I'm going to beat you. You'd
Well,
beat your kid if you said that. So, but that's what they do. They stare at the sky. Well, they don't do it all day. They stay all. What if they said, because they do it at night, right? So, like, I want to sleep all day and then stay up all night staring at the sky.
I guess those who like do sustainability, promote sustainability, like something like. Did you watch a few months ago? There was like summit of every country's representative comes about and talk about like how to save an environment. So these people are, I guess, these people are, I guess, most useless, I guess, from my point of view. I don't know like what they are doing because pollution is keep rising, and these people just having meeting on meeting just like this.
Yeah. Yeah.
So I guess that would be the useless job, I guess.
Yeah, that's pretty useless.
Yeah,
But
at least like
hypothetically, it could be useful. Like if they were right? If they were like everything they were talking about was good, it could be good. You don't know. Maybe it is. But there's nothing good about astronomy. Like what's it like? Yeah, you looked in the sky and now what? You can say whatever. Yeah, that star's pretty. So what? Like who cares? But yeah, I agree with you. Sustainability is a scam.
vegans also, why who think about this, right? Because animals like fuck, why it's just like I have some time, I should brag about something.
Yeah.
Dynamic games.
But I have to go to bed. It's like 2:00.
Okay, bro.
2:15 a.m. here. So have a
12
good
p.m.
morning, night, wherever you are, whatever you're doing.
Okay, bye.
Peace.
No worries, India. Cheers, mate.
Later. Later, Aussie crew and one American guy and Canadian person. Quebecian.
Just trying to close my mic.
Keep on keeping on, y'all. Stay blessed and watch out for zombies.
Cheers, AG.
Yeah.
the distance. So what was it like? F equals gravity times mass 1 times mass 2 divided by the radius squared.
So what does that mean in reality? If you were to apply this to physical reality, what would you be talking about?
The distance and the size of the mass.
What mass?
Of the objects, whatever objects. I don't know.
Well, which object are you talking about in relation to this gravity?
To the equation?
Yeah.
I don't know. It could be my phone. It could be me. It could be my wallet. It could be this tiny like pencil. That's on my desk right now.
And what would they be doing?
Nothing. I'm looking at it as doing nothing right now. I mean, I can move it.
Okay, so what does this tell us? What does this tell us about the Earth that we live on?
Well, it tells me that this pencil doesn't have very much mass. It's kind of small. I mean, kind of makes sense. Like I can pick it up, just chucked it at my bed, didn't take much effort.
You're not actually seeing anything attract to anything though in this situation, are you?
No, I mean, if going off the equation, I mean, I don't know about the whole planet, but just going off the equation of the pencil, that tells me this has no mass, like barely anything.
So why does it go down then?
Why does it go down?
Yeah.
Because the Earth has a ton of mass.
As in the ground you're walking on has a ton of mass.
The Earth. I mean, I'm answering in relation to the equation. What this equation would tell me.
Well, I'm asking what it tells you about the Earth being a ball or not.
Oh, the ball? I don't know. All I know is ground. From that equation, the ground has a lot of mass, and it's very close to the ground. And right now, I'm about to let go of it, and down it goes.
Yeah, but you seeing it going down doesn't tell you that that was because the ground is a big mass and it's attracting other masses. I mean, it doesn't attract everything, does it?
What does? I mean, if something's really far away or has like no mass, like hydrogen or helium, it might.
Well, yeah, well, if we've got a helium balloon, that's not getting attracted to the ground.
But that would tell me within the relation to the equation that the helium has like no mass. Well, it doesn't have no mass. I'm just saying in relation to the equation, it would tell me that it has almost no mass.
Well, I would either way tell you that everything is not being pulled down to a great attractive mass of the Earth.
Yeah.
So
maybe if the Earth was a little bigger, it'd pull it down.
It's just imagination at that point. So they've just hijacked the phenomena of some things going down to the ground and told you that that's a mechanism that keeps you attached to the exterior of a spinning ball. They're not giving you any evidence for that.
Maybe if I were to look at this, I'd say the Earth was rising up super fast and like accelerating, so everything got pulled downwards.
Yeah, some people have theorized.
Roller coaster, when it accelerates and you get pushed back in your seat. Maybe something like that.
It's called inertia.
Wait, so you mean, do you think the Earth is rising up to meet something
you hear me?
That's dropping down?
Me? No, I was just saying like a what if for fun. I don't know. You know, I could say that, but like, what evidence do I have for that?
All right. Well, my advice to you is good job with the notes that related to the subject rather than the people. Focus on doing those and research the things you're finding interesting. I mean, I'm sure someone could have the gravity discussion with you, but if you want to really focus on the curvature, I would recommend. But anyway, I'm going to be dropping off, so I don't know who else we've got on the FE side that can pick this up. DJ, you about? Or is anyone here? Says who?
I think they're gone.
Yeah, I'm here for a couple of minutes.
Yeah, I need to drop off anyway, so I'll catch you guys later.
Catch you later, Cyclone. Have a good one, man.
Peace out, dude.
Peace out.
I just wanted to ask a quick question. So, like, You were saying if something has a lot of mass, it attracts things to it.
Sure, I guess so.
Like, okay,
I'm just saying when I look at this equation, that's what it says.
Right. So why and how?
Why? I don't know. I'm just saying, like, how did it get a lot of mass? I don't know. Maybe it'll start.
No. Like, just say it has a lot of mass, right?
Just say it has a lot of mass.
Yeah. So how would that cause it to attract something to it?
I remember my
mass warps space around it. It's like a blanket. When you put something heavy on it, all the space around it will warp around it. So it's also like a black hole, how time warps around it also.
Oh, so it's not Newtonian gravity.
Yeah, imagine space as a large blanket. If you put a bowling ball in it and drop something, you will see that it's going to spin around it. That's also how gravity works.
Is space a large blanket, or is that just imaginary, made-up nonsense?
I'm telling you to imagine it that way so you can understand it.
Yeah, but
that's
I'm
just
asking
imagination.
Yeah, is space a blanket?
Could be.
What do you mean it could be?
How else can you explain anything? The plants you can see with your own eye, or is that also some government made up shit?
Holy cow, already. You just instant spiral. Okay. We're going to keep talking to the guy that's chilled out. So you just go ahead and go on white mic. We'll keep talking to our homeboy, the Wicked down here.
Do what you want.
Yep.
So we have conflicting gravities now. We have mass attracting mass versus the space blanket gravity.
Well, I was told, because I was gonna say something kind of like that, but so in my classroom they said, well, it wasn't really my classroom. It was okay. It's okay. So what was it? I think it was 8th, 9th grade science, somewhere around that. Big cloth, and then the guy, my teacher, put a I don't know, that, whatever you call that. Was it a pear? I don't know. I don't really know the fruits.
But yeah. They set up like a blanket and or whatever, and they
yeah, and then he put like So he put a small marble. No, he didn't put it first, but I'm just gonna say he put a marble, and then he put another marble. Nothing really happened because it barely warped the fabric. Then he put a big cantaloupe. That's what it's called, a cantaloupe. Then it really warped it, and then they put another small little marble, and then it just laid the marble down, and then it rolled toward the cantaloupe, and then just stopped when it hit it. And then he did it again, but he like pushed it along the side, so he did something kind of like an orbit, and he said that's how it works. But
so where is that in reality? Like, where's this blanket in reality? It's invisible.
Space, I'm guessing.
Oh yeah, what's it made out of?
Made out of linen. I don't know. Maybe
there's linen. There's linen in space.
I mean, I don't know, man.
What do you think?
Okay, well, the linen thing was kind of a joke, but you know what I mean. I don't know.
Yeah. Well, the whole thing's a bit of a joke if you think about it logically, right? So he's showing you something that is completely non-analogous to the actual claim. Right? I mean, it's just kind of like like a little trick to try to impress kids. But if I ask any simple questions about it, so okay, how does that relate to what's actually happening here on the Earth when it comes to if you have a big mass, it attracts things to it. Okay, I'm asking how the mass causes things to attract to it.
Oh, that
right? Because you guys are kind of overlapping two different theories of gravity here, like kind of confused between Newtonian and Einsteinian.
I had asked him that. I was like, okay, I actually asked him that exact same thing. Well, not word to word, but I asked him, okay, but why in space does the mass curve it? Like, what's going on? Like, sure, on Earth that happens, but that's because gravity already exists here. But why in space is happening? Why is it causing the space to warp? And he said, we don't know.
Well, how's it happen here?
Here? I just said.
Yeah.
We don't know. Us as a species
Okay.
does not know according to him.
Well, you know what's interesting? If this was true, then over a certain distance, let's say the surface of water, like a 20-mile body of water, for example, it would have to be curving at a certain rate if gravity were true and if the globe were true. But in reality, it's not. And we've tested it over and over and over again, and it's completely flat. When I say completely flat, I just mean it's not curving over distance.
I've seen some hills before.
Yeah, that's why. Yeah, but I just said like over a 20-mile body of water over the surface. There's no hills on the water.
How about the tides? Does that warp water? Like, what's going on there?
Yeah, it's kind of like the tides, right? That's not Earth curvature.
But what is
like
it?
that's not curving water because of the curvature of the Earth. Okay, so over 20 miles, you should have about 260 foot of curvature. Okay, that's not tides. Tides isn't the explanation for that. Like, that should be there because of gravity and because of the size of the globe.
Wait, over
and it would have to be
20 miles?
20 miles, yeah. 266.7 approximately foot. That's kind of like a 26-story building. Like a skyscraper.
Wow.
Yeah, it's quite a bit. Like, so if we went to like a 20-mile distance and we set up a camera and we're just standing, say, 5 or 6 foot high, we shouldn't be able to zoom in across 20 miles away to the other side and see it, right? See the shoreline or see an object that's low to the ground, because it should be hidden by, a ton of Earth curvature over that distance. But when we go to these to these places to test for this, it's completely flat, and we can zoom in and see the shoreline 20 miles away. Yeah, it's kind of crazy. I mean, I was taught all of the same stuff that you guys were taught as well at school. So, and then
Did you ever fight back against your teacher? Not like physically.
Well, no, because you'll just get mocked and ridiculed and probably get in trouble or kicked out of the class or fail your exams or something like that. You get rewarded for being a good little student, parroting the information, memorize it, regurgitate it on the exams, and then you can get a good mark, not for questioning like the core fundamentals of it. Yeah. So, yeah, I know I had never even heard of flat Earth back then either. I was more interested in how long until the end of the class. But once I started. What's that?
I think I've always known about it because I remember I was like told this book or story of this like girl had to go to the edge of the earth to like find some like thing, and then in the book the earth was described as like flat and like a disc, and like if you got too close to the edge you like fall off. I know that's not like what flat earth is to you guys, but like it was an early version of it I was taught.
Yeah, it's probably, kind of like the ridicule propaganda tactic or something like that, just to make the idea of it seem ridiculous. I'm not sure.
A genuine question. What do you guys actually think happens when you get to the edge?
Oh, we don't claim an edge.
Oh, wait, then what? If it's flat, then it has an edge.
Well, what do you mean, define edge?
I mean, if the earth is flat, then there's like... I'm not gonna define the edge, man. You take a plate, it has an edge. Like if the earth is flat, it has an edge.
Does a lake have an edge as well? Is that the same as the plate edge?
Okay, no.
Kind of edge.
Okay, no.
Completely different, right?
There's nothing to fall. There's nothing to just enter into land. You don't fall off into space. So then what's the edge of the Earth to you? Like what surrounds the Earth? Sorry.
Well, we don't claim the Earth is floating around in space.
Okay.
Yeah, like what people hear about flat Earth, and they try to replace the globe with like a flat planet, and that's not what we claim. Yeah, we can't try to put the flat Earth into the globe model. It's not really compatible.
So expand. What do you think it's in then?
Well, we're not claiming to know the shape of the Earth. Okay, flat's not a shape. So when we say flat Earth, we're talking about the surface of the Earth, which is mostly covered in water, not curving over distance. And we're not claiming to, I don't think anyone knows the extremities of the Earth, the shape of the Earth, the size of the Earth fully, right? We only know the area that has been explored. And we know that when we test over large distances, there's no curvature, where there would have to be curvature if it were a globe because of gravity and because of the size of the globe.
Wait, so is this the entire flat Earth community, or is this like a thought? Like within the community, there's multiple thoughts.
All of the flat Earth community that I know of.
So
all agree with what I just said.
So you believe it's flat, and it could be any shape. It could be a rectangle, triangle, circle, any shape.
Any shape, yeah, or something beyond what we can comprehend. Yeah, we don't know. We don't know the extent of the Earth. That would just be speculating. So we try not to speculate.
Can we DM and invite if you prefer? What is this? Chroma Key Challenger. Oh right, okay. What else is there? Okay, so you don't know the shape, and you don't know what it's floating, like quote unquote floating in.
We don't know if it's floating.
I don't think it's exactly.
Yeah, no, that's what I said, quote unquote. Like you don't know what it's contained in.
Not really.
So you don't know. Okay.
Yep. Sorry about that.
Interesting. So then, how do you explain satellites and like stuff like things that have physically gone up and looked down at Earth and seen nothing around it?
What would that be?
Well, yeah.
So do you just think it's all computer faked?
No, the problem that we have is that there are claims about things apparently above the surface of a globe Earth, taking pictures of it, in outer space, tethered by some magical force called gravity. We just don't have any evidence for any of that. What we do have is a measurable surface that is flat. So anything after that, if it includes a ball, it by consequence has to be false.
Interesting, because
that's something to add to that. Just quickly to add to that, quite often when we hear about the satellite data, what you're going to be looking at is like a composited image. Okay, for example, the blue marble images of the Earth that we get from NASA that shows the whole globe. Okay, if you actually have a look into how they're made, they actually just take a bunch of scans of the Earth essentially, and they convert those into imagery. Okay, so it's just data scanned with radio telescopes, and then they convert those into images like an artist does it, and then they stitch together those images into a big flat map, and then they wrap it around a ball in Photoshop. And then if you have a look at the images they use to stitch together from NASA, right, they don't show any curvature whatsoever. So I just put a screenshot of the data set, the images that they use to craft the 2002 blue marble, the 2005, 2007 blue marble images. You don't see any curvature in any of the images they use to stitch together.
I mean, yeah, because it's on such a small scale. It's like there's nothing to define curvature. Like it's a panel of water, and how would you even get like a defined sense of curvature on that?
Well, This is the thing. These claim to be satellites that are in space, the ones that you're talking about. Okay, and then once they stitch it all together and composite it into a picture, you see the globe. Right, and that's kind of what you were talking about, right? How do we see these pictures of the globe from space? Well, this is how they're made. This is how most people don't realize how they're made, and NASA admits how they're made. They said that I already told you how they do it, right? They stitch these together into a big flat map, and then they wrap them around a ball in Photoshop, and then they color them in, and then they keep tweaking them, like an artist keeps tweaking them until they meet people's expectations of what they think the Earth should look like from space.
Okay, then sure. But those are some images. There are genuine images that are completely just one picture.
Okay.
Like the blue.
Which one's that?
Let me find. Okay, I know the moon landing ones are obviously just like the moon landing photos and video.
There's only one photograph that's supposed to be a photograph of Earth from the moon. One photo. So that is basically a perfectly spherical Earth. So we go, okay, well, no problem. We should be able to measure this curvature on the surface and validate this photograph. Well, when we measure the surface of the Earth, there is no curvature. So now what do? Do we accept the photograph as true? Or should we go ahead and scrutinize what the claim is and say, well, maybe that's not possible because the Earth is not curving?
What methods did you use to measure the curvature?
Laser, long distance photography, anything that we can possibly use to see if there's any drop over distance over large surfaces of the Earth, large surface area portions.
Okay, so you're telling me that if I went outside and did like that experiment with like the two stands of set height with the two holes above the ground on the same height, and you shine a light, and if you see the light through both holes, then there's no curvature. If you don't do this curvature, that experiment.
Well, that sounds kind of like a dumb experiment to me. But go okay.
It is a dumb experiment, but we actually went out and replicated a similar experiment. Instead of doing it over a short distance, we got two people at each end of a lake that is just about 14 miles across, and they did the same thing with a flashlight from just 5 foot height. Okay, and he could see the other guy's flashlight 13.7 miles away. And then as soon as he would put his hand over the flashlight, you couldn't see the flashlight anymore in the zoom footage. Okay, so he was able to see a flashlight from 14 miles away. Whereas in the little Netflix demonstration that you're talking about, it just shows 52 seconds worth of footage at nighttime. It doesn't show the setup. And the distance is only very, very small, a small distance. You know, they don't show it. They don't show anything properly, but I can show you one where you can see the flashlight clearly from 14 miles away, which would be about 120 foot or more of missing curvature.
Okay, I want to do this. I should like get one of my friends and do this.
yeah, man. Yeah, look. Here's one in the side chat as well. So some people have really expensive laser beams, like big giant laser beams. Now this is a team of field engineers, and they got a $30,000 laser beam, and they shot it over 40 kilometers distance, and it hit the target. Here is it hitting the target in the side chat. That's from 40 kilometers away. And that beam should have been 90 meters up in the air if the Earth were a globe, but it hit the target. They did 5 different tests.
There's no target, it's just a grid with target.
Yeah, but you can see that the laser beam is hitting it, the green beam. That's from like 40 kilometers away.
Okay. I mean, because I'm seeing this, it's not center, it is upwards, but like that's the expected position for a flower.
Yeah, it should be 90 meters upward if we're a globe, like 90 meters.
Oh, it shouldn't even hit the sheet. Okay.
No. It should be like 90 meters. That's like I don't know how that is in feet. That's like a skyscraper.
Yeah, that's way high.
Yeah, way high.
Interesting. Okay.
Yeah, man.
Really? Wait, there should be 90 feet of curvature?
90 meters. 90 meters.
Yeah.
So there's 40 kilometers.
For 90 meters.
Yeah, hold on. I'll check exactly right now. So I'm on an Earth curvature calculator. Okay, so hold on. I just got to change it to kilometers.
Is that an NASA calculator?
No, it's just Omni calculator. If you go to Google, you type in Earth curvature calculator, just a whole bunch of them will come up. You can pick any one. It's just a basic calculation. Okay, so the distance was 40 kilometers. The eye height or the laser height was 1.5 meters. Okay, so 326 foot of curvature over that distance, which is Yeah, it's like 99 meters or something.
Is that what obscured object part is? That's such a weird name.
Yeah, obscured object part. Yep, that's right.
The height of the ground to
It
the
would
lowest.
be obscured. It would be obscured behind the curvature, like behind the horizon.
Is saying 100 meters for me. 98.62.
Yeah, I got 99 on my one.
Okay, sweet.
And this is a team of engineers. They were using some seriously expensive equipment, and they did a whole bunch of tests. They got a 180-page PDF document and an hour-long video that goes over everything start to finish. I can post it for you if you want to. Oh, yeah. Old Dude just posted it. Thanks, Old Dude. But there are more simple tests that you can do, like with the torch as well, if you want to do it, on a budget. Don't have to buy a $30,000 laser.
I don't know how much range the torch would have.
Well, here it is. Look, here's a torch over, obviously it's a pretty high-powered torch, I guess. But this one, I'll just put some screenshots. Like, this is all out of a video, but I took some screenshots the other day. Okay, so this is the distance, 13.7 miles. Here's the math, the screenshot from the Earth curvature calculator. Okay, this is the camera setup. It's like 5.5 foot high. And here is the torch strapped to the camera tripod. And the image on the left is the zoom footage from the other side, right? So he's got a high-powered zoom camera and he's zooming over to the flashlight. So you can see the flashlight. And then the guy tells him, because they're talking on the phone, the guy tells him, put your hand over the flashlight. And then he puts his hand over it and, all of a sudden you can't see it anymore. They do it a bunch of times.
Oh, okay.
And then after that, they do it with a laser as well. And then this is the laser. And with the laser, they start at about 5.5 feet high, and then they lower the laser, and then they try it again, and then they lower it down to like 9 inches off the surface of the water, and you can still see the laser right across the lake.
Why is there also one thing about the distance?
Mm-hmm.
Why does that say 13.7 and your count was 40 kilometers? There's an extra 20 kilometers, like 21 kilometers.
This is because okay, so the one that Old Dude posted above. Okay, that's the laser test with the engineers. Okay, that's a different one. That's 40 kilometers. And then I started talking about the torch test. This is a completely different test. So this one was just done over 13.7 miles.
Correct. My bad.
No, you're good.
Interesting.
Yeah, all sorts of different ways to test it. You can even do it even cheaper than with a torch. You can use mirrors. Okay, so if you just say you find a 10-mile lake, you could go on one side of the lake and your friend could be on the other side of the lake. And if it's a sunny day, then you can use a mirror. And if you angle the mirror correctly, you can shine it into the person's eyes or whatever, on the other side of the lake. And you have to have it angled perfectly to get you need a line of sight basically for the person on the other side to see the mirror flash. Would be called like a mirror flash test. That way you can do it for for free that way. Just need a mirror.
Imagine I actually do this and I'm like questioning my reality if I get these results.
Oh yeah, man. I mean, I did the same thing. I saw all of this stuff. People showed me some of these tests, and I lived on a giant lake. We had a huge section across the lake, Lake Macquarie in New South Wales in Australia, giant saltwater lake. And yeah, I did my own observations, and I could see the shoreline on the other side of the lake by zooming across the lake. But yeah, we encourage people to test it themselves if you want to.
When did you become a flat earther?
Back in 2017. Yeah, quite a fair while ago.
Right, fair. I'm still like hung up on the whole like you don't know what encompasses the Earth, basically. And
we can't test that. Nobody can test that if you think about it. So we can only get up so high. Like we can get up to 40,000 feet on a plane, which isn't very high. And then we can send up a weather balloon to about 120,000 feet. Okay, and when we do that, we can send up a camera. We just see a flat horizon from that height. And we can't really get much higher than that.
Okay. Also, how do you explain gravity then?
Well, gravity just say the Earth is flat and contained, like a contained system that the Earth doesn't move. It's just a flat Earth within a contained system. We don't need to have gravity the way that you would need to have gravity on a globe. Because you guys need to explain how you can have oceans sticking to the outside of a spinning space ball, essentially. We don't have to explain that. We just say water needs a container and things will rise or sink due to their density in relationship to the density of the medium that's surrounding them. Like, obviously, air is a very light medium. So
that's just basically fluid dynamics. I'm pretty sure you call that. That's just basically fluid dynamics. That's not
really
gravity.
No, it's not fluid dynamics. It's called Archimedes' principle. It's actually called specific. It's called specific gravity. Okay, and it explains perfectly why things rise or why things sink. Okay, so if something's more dense than the medium surrounding it, and you lift it up and drop it, it's going to sink if it's more dense than the surrounding medium. Like if you pick up a tennis ball and drop it through air, it's going to sink. But if you pick up a tennis ball and you drop it through water, it's going to go up because it's less dense than the water, but it's more dense than the air. Now, if you drop a helium balloon, it's going to go up because it's less dense than the air. But if it were more dense than the air, it would sink. It just so happens that air is very light, and most things are less dense than the air. More dense than the air, so they're going to sink if you displace them, right? So you need to put some force into it first, right? So something sitting on the ground is never going to move unless some type of energy exchange happens. So if you come along and you force it out of its state of rest and pick it up, then you've input energy into that, okay? And when you release it, it's going to sink back down to find its place of rest again. Very easy to explain. Very easy for anyone to test anywhere. And we can even do an experiment to test it as well. Like we could get like a glass of water, like fresh water, and put an egg in the water, and the egg's going to sink down to the bottom of the cup. But then we can vary and manipulate the medium by changing the density of the water. So we could put some salt into the water, and then all of a sudden that egg that's sitting at the bottom of the cup, all of a sudden it's going to go upward. It's going to start elevating upward, and it's going to go up to the top of the glass. We didn't touch it. All we did was vary and manipulate the medium.
But I swear, with that, I forgot. I don't know what it's called, but the whole with the example of water, let's say helium ballooned water, it will go up with more force the more buoyant it is, right? They go shoot up with more force.
Yeah, so you can explain that using gravity on a globe as well. So they're going to say, they would say that the buoyant force is more powerful than the weak force of gravity. So yeah, the globe has explanations for everything, basically, for most things. Well, not really for the water that doesn't curve. But it should curve, right? Because of gravity. If the water's not curving, then that debunks gravity. Straight up.
Yeah, probably. Yes, it would.
Yeah. Well, it has to be. It has to be curving.
Okay. What do you say about the moon and Mars, other planets?
We can't confirm exactly what they are, and we've been fed a big story about what they are. But they're celestial bodies that move like clockwork, right? Everything in the sky moves in cycles, like a big giant clock above us.
Interesting. You can tell I say interesting a lot. Well, else.
It's interesting, yeah. No, it's interesting stuff for sure.
Okay, so you don't buy any of the like how planets formed and how the solar system formed. You don't buy any of that.
No. What do you mean? How nothing exploded and turned into everything, which was made
that's the Big
up by
Bang.
Yeah.
I'm talking about like because there's a theory called the solar nebula theory or something. The planets formed from a big disk of rotating like gas, and it coalesced into the sun and the planets. Do you not buy that?
Well, no, I can't confirm it, man. And if they say space is a big vacuum, I don't think you can have that happen in a vacuum. Nor can you have water in a vacuum. Nor can you have like a big ball of plasma gas inside a vacuum. Nor can you have a planet that's covered in water and gas inside a giant space vacuum. It's not something that anyone is going to be able to prove that is possible. It goes against gas laws. It goes against a bunch of natural laws. The second law of thermodynamics. It's not possible. It's just something that you're going to have to choose whether you want to believe or not.
I mean, you could. You're talking about there's no plasma in a vacuum like the plasma of the sun, right?
It's a burning ball of like plasma gas.
Yeah, like the way they explain that, like there's like atmosphere. Does the sun have an atmosphere? I think it does.
I don't know what the story is about the atmosphere of the sun, but you're not going to be able to show me a sun in a vacuum chamber. Something that's similar to the sun in a vacuum chamber.
I mean, you're not on Earth, man. You could barely get one. We're to work in like a flippin' reactor.
Yeah, but it's not analogous. It's not to do with gravity. It's not. Are you talking about?
Oh no, I'm completely moved on to gravity. I'm just trying to like learn as much as I can, Loki.
Yeah.
So real quick, if the air is like an ocean or where everything sinks in it, if it's less dense, and if it's more dense, it becomes buoyant. When you drop a rock at normal gravity, at normal pressure, when air is there, it will fall at 9.8 meters per second. And if you drop it in a vacuum chamber, it will fall at the same rate, even though there is no air. So how does it fall in this way if there's no gravity? It's not floating in anything.
The density of the rock, because the density of the rock and the resistance of the air is not going to make much of a difference. So it's going to approximately fall at 9.8 meters per second squared, whether it be in a vacuum, which is just a less dense medium than the air. So get something like a feather or something like that. Obviously, there's going to be more resistance and it's going to slowly float down. But then if you drop the feather in a vacuum chamber, because you've removed what's acting as resistance, then it's going to fall at a similar rate to the bowling ball or whatever you want to put in there. But in a vacuum chamber, we can't test it properly because it doesn't have enough distance to get to its terminal velocity. So they're just going to fall at roughly the same rate. But that does so that's just an observed effect. We agree on that. We can all agree on that. That's
y'all are
anyone can test.
I'm not the guy with the cat with the eyebrows for a profile picture, bro. Come on. Sue a guy for trying to learn.
No. That's that's a troll. That's a globe Earth troll trolling us, not you. You probably. Yeah, that's not a flat earther. Got to watch the cat profile picture, people, bro. They're trolls.
So wait,
pretty much every time.
Wasn't your whole explanation for gravity based on your substituted gravity laws for buoyancy laws?
No. Nope.
No.
Basically, explain the gravity substitution to me again.
Okay, so first of all, I think it's important that there is really no substitute for gravity, since gravity, number one, has never been proven or exists. At this point, it is only a mathematical concept. So if there's no replacement, all we have is what we observe. Apparently, we have a pressurized system where there are 3 to 4 different states of matter. We wouldn't be having any oceans unless we had some kind of containment where this pressurized system could keep the water in a liquid state. So we have these three mediums, if you want to think of it that way: solids, liquids, gases. Solids pretty much always descend or fall downwards in the gas. Sometimes they fall downward in water. Sometimes they rise in water. This is just what's observed. It's like a giant density tower. So there is no replacement for space-time. It's just what we observe. Heavier or more dense objects within a less dense medium will go downwards, and vice versa. That's what we have.
Okay, so now you take the rock. Wait, the rock is always more dense than the vacuum or the air, which is what he was saying. So
And
it's like
typically
in
the
both
water.
situations.
Mm-hmm.
I had a thought, I lost it.
So now let's take something different. Let's take let's say a block of wood. So a block of wood still descends through the air, right? The air is not dense enough to support it, so it goes downward. You take that same block of wood, you put it in the water. Now it wants to rise upward and find its equilibrium at the surface of the water. But you'll notice that not the entire block is resting on top of it. So the little bit of density that there is displaces the small amount of water that is there. So everything is just a really big density tower. Have you ever seen a density tower?
Just again, so in a vacuum, when you drop the thing, there vacuum chamber, so there is no, it's also going to fall down.
Correct.
So yeah,
That's what we
dropping
observe.
it down now? Vacuum is the presence of nothing, or nothingness. You have taken out all the air.
It's look, Ben, it's the same thing that I was describing without the vacuum chamber. Okay, so the things that you put in the
You
vacuum
were
chamber.
talking about air resistance, so
Yeah. Hold on. This is it, though, right? So the things that you put in the vacuum chamber are just going to sit at the bottom of the vacuum chamber forever. They're never going to move unless someone comes along and forces them out of their resting place and lifts them up. Okay, then they're going to reseek where they were due to their density. Okay, and in relationship to the density of the surrounding medium, which is essentially no resistance, right? Because there's hardly any gas left in the chamber. Okay, so they're just going to sink back to where they were, but only because you lifted them up. They never would have moved if you didn't lift them up.
So how come the air pressure decreases as you increase altitude if it's air is the same medium, right? Like if we're talking about like a homogeneous system at this point, not two different densities, why did the densities change?
Okay, so completely different question, unrelated to the one we were just talking about. But thank you, Josh. Okay,
happy to hop in line. That's fine. I'm just next time we find a pivot.
Yeah. So I mean, obviously it's a lot warmer down here, a lot cooler up there, and then also the gas is all being created down here. Okay, almost all of the gases are created down here. Okay, and gas obviously slows down like crazy as it gets cooler. Okay, so is it such a crazy claim to think that you would have more gas pressure where the gas is being created, and that you would have less pressure where it's way cooler, and also there's way more space up there? But yeah, who are we talking to just then? CYE? Psy? And
yeah. And Bean Toasty.
No, I'm here just thinking about what you said.
Yeah.
When you're talking about the pressure where gas is more dense, there's more of it down there than it's up there, but there's something called osmosis pressure, where matter from the more dense parts will go to the parts with less density. So if there was no gravity, it should be equal at everywhere, since there aren't many obstacles in the air, like walls or pillars, as you said, that would obstruct it. So shouldn't it be? It should be just equal everywhere, because matter flows from the objects of high concentration to parts of lower concentration.
Sorry, I was typing something towards the end of your sentence. Can you just say that one more time for me? Sorry about that.
Yeah, if you think about like the osmotic pressure in sewer water, in the higher concentrated places will flow to the lower parts. That because matter always wants equilibrium.
Mm-hmm.
Objects always want equilibrium. So gases at the bottom would rise to the top, almost reaching an equal state. If there is no gravity, that should be the case.
Well, not necessarily. Like gas particles behave very differently than solids and liquids.
This also applies to gas. How do you think about air pressure or the weather, to be exact? Why does rain or something happen at any place? Because winds from
it's to do with temperature, though. It's to do with pressure systems that are caused by temperature differences.
Yes, temperature causes concentration differences. When you increase the temperature, the matter gets excited, so it disperses more. That creates a concentration difference. The part where the temperature increased would have less wind or less gas. That's why it would increase. Unlike the
but if what you're saying, like, look, let me use your own argument against you for a second. Okay, so if things are always trying to reach equilibrium, then obviously high pressure would go to low pressure, right?
Yeah.
Okay, so we're claimed to be inside a giant space vacuum that's 10 to the negative 17 torr, about more than 100,000 times more powerful than any vacuum chamber that we can create here on the Earth. Yet we have high pressure adjacent to the low pressure, extreme low pressure system of space. Okay, yet it doesn't happen, does it? The equilibrium doesn't happen. Entropy doesn't happen according to you guys. And you're going to say gravity is the solution for that. And then, is that what you're going to say? Yeah,
exactly.
And then we're going to start looking into gas laws. Okay, and we're going to see that gas particles don't have a downward bias. Gas particles move randomly in all directions. You could look up any definition of gas particle movement, and you're going to see the same answer: that gas molecules, they move in straight lines indefinitely, unless they bounce off another gas particle or against the walls of the container. Exactly. They can slow down. They can slow down or speed up because of temperature changes. But if a gas particle is going upward, it's not going to be pulled back down to the Earth by gravity. That doesn't happen with gas.
No, exactly. Gravity acts like the barrier that holds it in place. It holds the gases in place. Think of it like not the vacuum in space, like the vacuum cleaner. When the vacuum exerts pressure, air enters in it. You can test that by, of course, putting your hand over it. You'll see that your hand's getting sucked. The Earth acts exactly the same with gravity.
The gravity would have to be pulling. The gravity would have to be pulling.
Yes, gravity
things towards the center of mass. Everything would be pulled towards the center of mass. So that means that a gas particle would be pulled downward. So that means that a gas particle would have to be getting pulled downwards towards the Earth. But gas particles don't do that. A gas particle that's going upward doesn't get pulled back down. Gas particles move in straight lines, and they move in random directions. They don't have a directional bias. They don't have a downward bias.
So they're just going to go indefinitely, even if they're leaving the Earth, if gravity isn't holding them down. That means if I go to the center of the Earth or go mine really deep where I'm far away from the surface, I shouldn't find any gas there. No oxygen, no carbon, no anything.
I didn't say that. Gas particles move at random in all directions. The gas is being created at the ground level, where 80% of the oxygen is created in the ocean by ocean plankton. Okay, then we have nitrogen cycles. We have all of these different gas processes where the gas is being produced, under the surface of the ground. I got to go on mute for a second.
Yeah. Anyways, I had fun talking with you guys. Should be back in another time.
Yeah, there's a video of a amateur rocket being shot up into space, and you can clearly see a curve, but these guys just always change the subject or ignore it.
That means it will be also on the ground, if you can see from the
whole,
rocket.
Bigfoot, unicorn shtick.
Yeah, that would be the curvature that we're asking for the measurement of that no one has. That
Okay,
curvature.
but you can see it.
Okay, so why can't you measure it?
So, are we trying to disprove flat Earth, or are we trying to prove globe Earth here?
Well, they'd be the same thing.
There's two
they?
sides.
In order to disprove the flat Earth, you would need to prove a globe because.
Okay, so where are the globe tards? Are there any globe tards in the call?
Yeah, we're just speaking to a few of them. Okay. No, the first guy was cool. What is it, Mansky? He's a big time globe head. He's been coming here for months and just like sideshow Bob walking on rakes 24/7. But the first guy, who was that? Because he could actually hold a conversation. So we've not got someone from the flat Earth side who can pick this up. Who's on? TWN? Setu? DJ?
I am, but I may not be for very long.
Drace?
What I would say is that if that imagery that Mansky's talking about is indicative of a sphere Earth with a radius of 3,959 miles, and when we go to a 20-mile lake, or we look across a 21-mile body of water, we wouldn't see clear to the other side. There would be a horizon at about 2.7 miles and a curvature drop of about 260 feet at the other end. But that's not what we find. So sorry, the imagery.
Can we set aside the curvature drop for a bit? Because I'm presenting here a photo of the Earth, and you're saying that it's been manipulated. Is that correct?
I'm saying that if it is indicative of a sphere Earth with a radius of 3,959 miles or a circumference value of around 25,000 miles, then when we go to a large body of water like a lake and look across 21 miles of surface of water, we wouldn't see clear to the other side. There would be a horizon at 2.7 miles and a curvature drop of 260 feet at the other end. But there isn't.
That's just a statement that you made now.
Yes, correct. So any imagery that's presented to you as some kind of evidence or a claim that it is representative of the Earth as viewed from a very far away, and it comes with those values of this Earth's size, its radius, its diameter, its circumference, then when we go to a large body of water like a lake, and we look across 21 miles of surface of the water, we shouldn't see clear to the other side, but we do. So therefore, do what you will with that imagery. Think about it as you will. If you want to just rest your faith on that unverifiable image, that's on you. Right? But meanwhile,
Well, you've got to actually explain the steps.
Yeah, sure.
You can't just tell me that because I'm looking at a circle with some kind of radius that this needs to happen.
Right, so if that is the Earth and its surface is curving, then there's geometric consequences, right, to what we will see and what we can measure on the surface here on Earth, right? Meaning there's a curvature rate to it. So roughly 8 inches per mile squared, which means over a distance of about 20 miles, there would be a curvature drop of around 250 feet. Do you understand?
Right.
How much drop is there? How much drop is there?
I'll go to the Earth curve calculator. I've got. Oh no. I don't know how to use this in conjunction with the image. Whatever.
Because if the Earth doesn't curve as much, that means it would be an even bigger globe.
True. Look, if you're just looking at the image, if it was, for the sake of argument, not touched at all, right? No Photoshop has been altered. They just took it off, like they printed it as soon as it was taken, right? And nothing happened to it. Would that mean we live on a sphere? If the image was true, mind you.
The correct term, I think, is oblate spheroid, but yeah.
Hypothetically,
So the image,
if it was true,
the image
it'd be true.
has been, changed.
If the image was true, the Earth would measure accordingly, curved. However, besides doctoring, there's a very simple explanation, and that they used a wide-angle lens which curves horizontal lines. So if you look at the video, early on when they're close to the ground, does the horizon appear curved? If yes, then this is a wide-angle lens.
I don't know, I don't see a video, and I'm not talking about a specific image. There's lots of images of Earth.
Yeah, and we've gone through you're welcome to try to find one. We've gone through thousands of them, and we have hundreds of ones that don't have a wide-angle lens, and they show flat horizons.
Can you show us that?
According to the math, the ISS is too low to the ground to have the Earth curve, and so they need to use wide-angle lenses to make it appear curved.
Can we all agree that you believe that the image is doctored?
No, I didn't say it was doctored. A lens effect does not mean the image is doctored.
What about an image like without a wide-angle lens?
You have to show me a specific image for me to claim it's doctored or not, okay? It doesn't really matter because the surface determines if the Earth is curved or not. And so if you have an image showing a unicorn in your backyard, and then we go to your backyard and there's no unicorn, I am not obligated to believe in your image. Do you understand?
I can't actually send anything in the chat. I can't send an image.
So you don't understand?
No, I do understand. I'm trying to send an image and I can't.
That may be an issue of just being too new to the server, so you might have to, participate more in chats until you level up, and then they'll grant you that access.
Right. So, do half of you believe that the images are doctored and half of you believe that it's using a wide-angle lens? What is the actual consensus on this? Is there a consensus?
How would there be a consensus on multiple images? Each image is specific to that image. We don't have an imaginary consensus. We're not a cult like the cult you come from. We're not a cult like the cult we left. We're just the people who left your cult, okay? Get it through your brain.
Okay. You can also decide that none of the images are indicative of a globe, that they're either wide-angle lenses or doctored. They're not mutually exclusive. I'll just send DJ the image, whatever.
There's many potential causes for the images. You like us, can simply...
This is the most standard image. I didn't
I understand. I'm just saying any image that contains the globe in it, you can just go test it yourself. Does the reality curve like the image is presenting to you? If it does not, the image is not true, regardless of how it was made.
Right. So, okay. Some images are made with a wide-angle lens, and some are doctored. Can we agree on that at least?
Yeah, sure. NASA admits we have a link here for you from NASA to graphics designer working for NASA who created the blue marble image. They freely admit that they doctor some images and create some images. Many people believe those images are real images. There are other images they claim are real images, and we simply test the surface. So we don't care what other people claim when they don't have any evidence backing those claims. The evidence comes from reality conforming to your images or not. If reality doesn't conform to the image, then the image clearly isn't true regardless of how you derived it. You could have created it through an AI. Whoa! That doesn't mean it was doctored by a human or using a wide-angle lens. There could be other methods made to create images, like what was he called again? Math Powerland, one of the earlier flat earthers. He claimed to have worked for NASA making paintings, very realistic paintings of globes, and he ended up making a comedy routine after he stopped working for NASA, and was like, "Is this a painting or a photograph?" And he had globes, and he made fun of this because he was and ended up becoming one of the earlier flat earthers, because his paintings were so realistic that people believed they were real pictures of actual globes in outer space. But we're not making claims about the entirety of supposed space pictures. We're testing those claims. The pictures themselves are the claims, and we're testing the claims. Do the claims hold up in reality? And they don't. That's the simple.
I'm not doubting any of that, okay? I'm simply saying, all right, let me put this as cleanly as possible. The images could have been painted, doctored, photoshopped, created pixel by pixel, manually written in a text editor, all right? It doesn't matter. An image as of 2026 has no value whatsoever. It is not proof, all right, alone. But let's say, for the sake of argument, that an image was not doctored, it was not painted, it's not fake, all right? For the sake of argument, all right? If the image was actually real, taken on a spacecraft outside of Earth, right? If all of those things were true, never mind that you don't believe in them, just say that they were.
Yeah,
the one I just posted.
If all of those things,
I haven't finished.
Were true. Okay, sorry.
All right, if all of those things were true, and you just take any random image like the one I sent you, right? That would indicate that we're on a sphere, right? But I know you don't believe all of this.
No problem. If we assume all of this is true, and we went out into outer space and we saw the Earth as a ball, the Earth would measure as a ball on the surface. It doesn't, so your hypothetical doesn't make any sense.
Right.
And your image doesn't make any sense.
What's wrong with it?
Well, on one half of the ball, you have Africa.
And that's a problem. Why?
Well, on the other side of the ball, you have North and South America, Asia, Europe, Australia, Antarctica, all the oceans and seas surrounding?
So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth and I can get this exact perspective and everything will be fine. In fact, I'll look right now.
Well, then you have the same problem with Google Earth.
WebGL is not supported on my browser. That's great.
Senator, this stuff seems to be going in one of your ears and out the other. Good luck to you, dude.
Hello, guys. How are you guys?
You just told me that my image makes no sense. Out of the blue.
How are you, bro?
I'm great.
Yeah, it makes
Where are you
no
from,
sense
guys?
because this is not something.
Where are you from,
that
guys?
Sense. Sorry. I'm
Where are you
responding to
from?
him real quick, and then I'll get.
No. Respond to me.
Yes.
Quick.
Yes.
Where are you from?
No. First, I'm responding to him, and then I will respond to you. Don't make me mute you. So it doesn't make any sense because what you experience is a flat, non-rotating world. You see the stars and the sun move in the sky, and you experience the world as a locally flat plane. That's how it's described, that's how it's mathematically used, that's how we function and use the world we live in. However, there's this belief that the world curves beyond what we can experience, and that special people can go outside the globe and experience it as a globe. Meanwhile, you, the plebs, cannot. And so you just have to believe in the superior people, and then you are enlightened because you are part of the religion of the globe. Sorry, we don't buy into that. We actually go out and test their claims, and their claims fall flat.
Unintended. I'm kidding. Yeah, I just realized that I was gonna make a different point, but then I fucked it. I'm sorry, but I don't follow with this whole religion thing, right? With the globe people.
Yeah, it's a globe religion. If you didn't know, the globe religion started as a cult within Pythagoras as a secret doctrine of the Pythagorean cults, and then spread into the mystery schools of Greek, ancient Greek, and our whole current worldview is built on this ancient mystery cult and their secret doctrine. And that's what everybody's been programmed to believe, even though they don't have actually any evidence. All the supposed evidence for it is just logical fallacies, and that's why they removed logic from your curriculum, so you didn't understand how you're being manipulated. And then
they removed logic from the curriculum.
Yes,
that's
they essentially
not true.
Essentially removed logic from the curriculum. You only get a primer and slight education on it if you go into philosophy, but even then, it's drowned out by all of the different aspects of philosophy. Back when we had the trivium and the quadrivium, logic and rhetoric were some of the primary things that they taught children, and so they were better equipped to identify logical fallacies. Meanwhile, we get taught Aristophanes, for instance, if Earth is a sphere, shadows would act like this. We see shadows act like this, therefore the Earth is a sphere. This is circular reasoning, but because it's dressed in math, it's dressed in authority, people don't realize.
That's what I've been trying to get at with my whole sphere photo. The point of the sphere photo is not about proving the existence of a sphere from just a photo. It's about getting you to acknowledge that you believe in someone that is oppressing us, controlling us, and feeding us false ideas.
I don't need any belief in that because I can just go out and measure the world and see that someone's not telling me the truth. For I don't know his reasoning for not telling me the truth. Maybe he's just confused. Maybe he's a dumbass. Maybe he inherited this lie from some other guy who might have been malicious. I don't know. I am not them, but I can test the fruits of their labor. I can test if the earth is actually curved or not, because we have access to the earth.
You can't be making this whole thing about us not being taught logic in school, about a cult created in ancient Greece, about them wanting to control you, and then just go on and be like,
no. Them wanting to control you, that's you putting words in my mouth.
Well, not you specifically, but it was said in this voice channel earlier.
Yeah, that's because we're not a cult like you. You come from a cult where there's a unified belief that you have to believe. We are an independent group of researchers who all have different opinions and beliefs. However, the only thing we share is the empirical, scientific, and logical necessity of reality. And so we teach each other logic. We go through science and physics. That's what we care about. We care about the empiricism, the measurements. If the Earth were measured curved, we would all be globers.
You just can't do that. You can't call me. You can't say that I'm in a cult started in ancient Greece, and then say you're just an independent group of researchers. You can't have it both ways.
That's just how it is, because we are not a cult. We don't have a unified belief system like you do. You have one, and you are here policing for your belief system, because you have a cognitive dissonance when being faced with the idea that your belief system could be wrong, because you were raised in cognitive ease. You were raised with the globe being in all of your programming, all over entertainment, in your education, and you were never presented any alternatives. You were presented this as it was a concrete reality, and so it shaped your ego and your worldview as you think you live on a ball. You think there's outer space and other balls you could go to, and maybe aliens out there, and it creates this whole worldview for you, where you are like random accident of the universe.
If it's so easy to understand, or maybe not to understand, but if it's so observable and measurable and provable that we are on a flat earth, then why is the consensus different? Why is flat earth a minority and globe earth the majority?
Because there's billions of gullible people just like you.
It's actually very easy. In the 1800s, there was a resurgence of flat earthers. In the 1700s, there was a resurgence of flat earthers, and there's always an opposition to this, and that's because the cult, the secret knowledge, the holders of the secret knowledge, we know how the world is, and if it's not how we thought it was, then we were wrong. We were telling everybody things that were wrong, and it's hard to accept that. That's sunken cost fallacy. So there's just human psychological reasons when people get caught up in beliefs. You can see this around any belief, like Scientology or any other thing, where people believe something so hard that they just don't look at reality for what it is. They try to insert their belief into everything, and when it doesn't matches, they just find some excuse to try to make it match. And that's what we keep finding. We wanted to believe the Earth was a ball. None of us wanted to be a flat earther, okay? Most of us who came to this wanted to debunk them, and so we were like, okay, yeah, let's go out and test it. We'll figure out one way or the other, and just confirm the globe again and again and again until the flat earthers concede. However, what we did was confirm that the Earth isn't a globe over and over again, and eventually we just had to scratch our heads and be like, okay, like, who do I talk to? It's far easier to convince people of a lie than to convince people that they've been lied to. And I don't really expect you to believe me or us. I just want you to think about your own beliefs, and then be critical of your own beliefs. And then, as you're out and about, and you can look out over the sea or whatever, and you can see, wait, I can see way too far for the globe, and that might cause some interest in science and logic and reasoning, and you might dig into this and figure out that the Earth isn't a ball, but it requires you to find it within yourself the desire to actually search and learn and test these things, because nobody's going to give you all the knowledge. You think the people who want to maintain power would give you all of the knowledge when knowledge itself is power?
See, there you go again, making claims about people holding the power for themselves. Like, you just said that. You can't unsay it.
No, this is just basic human psychology. I'm not claiming a grand conspiracy. I'm just saying there are people in this world who have narcissistic tendencies. There are people in this world who have sociopathic tendencies. There are people in this world who are greedy. There are people in this world who are selfish and don't care about humanity. Like, there's many people who do, but the naivety of humanity and most people is to think there's no bad people in the world. There's no bad people who want to keep an advantage over you. And I don't presume to know who those people are. All I know is that I can test the surface, and the surface doesn't match what they told me.
And everybody knows there's corruption in government.
Yeah, my sister says everybody knows there's corruption in government, and we can quote her on that. I mean, it's not hard to imagine that some people are malicious, and I'm not saying that the whole globe idea is a malicious plot. It could be, but it could also just be a massive misunderstanding, and people building on that misunderstanding because they believe in the authority and the accolades of the ones before them. They think they're standing on the shoulders of giants.
Or it just could be true.
No, we measured the Earth and it isn't a globe, and so it cannot be true.
Look,
if
the
it's
two
so
main
true,
reasons.
If it's so true, why do you and this printer guy resort to illogical circular reasoning and just wishful thinking?
We don't see it as illogical, wishful thinking. We see it as logical and reasonable.
Okay, give some logic. That's not your. No, dude. Let printer flounder. But he's demonstrating his own illogic. Have you not been listening, Matthew? What has printer? What argument has printer given that's logical?
I'm not. I don't want to butt in on their.
Okay, well then be quiet.
Let them continue. Okay.
No, don't be quiet just because this guy told you to.
It's not logical, Matthew, to say that circular reasoning is logical because you believe in it. That's so far from logic. You are a teacher, bro.
The two main reasons you've given me as to why people... Actually, no, that's a lie. There's a lot of reasons you've given me as to why people don't believe in flat Earth is because... Well, I'm just going to list them all. They've been... That's the way they grow up with. That's what's been taught at school. It's cognitive dissonance to change your ideas. It feels bad. You don't want to feel like you're wrong. And that's also what the cult feels That's why they don't want to change their ideas, because they're also going to feel bad.
What? The first part was all good, but what the cult feels, I don't remember saying. I don't remember personifying a cult. Yeah.
Oh no, you did say I was in a cult, and you did specify that it started in ancient Greece.
Yeah, I call the globe religion a cult. Yes, that's correct.
And then I asked why the cult hasn't changed its views. You said that they didn't want to feel like they were wrong.
Yeah, that's called the sunken cost fallacy. Like, once you start doing something, you prefer that to have been the right choice rather than the wrong choice. And so humanity generally has this bias where you try to keep up with a broken relationship, even though at the start you should have seen the signs that this was never going to work out. It's just basic psychology.
You know, that's difficult to argue with. To argue that these points are invalid would be really hard, because it is hard to change your opinion.
Listen to him rationalize. Crazy.
I don't even blame them. Like, it's tradition. We were raised in this. Like, you see this all around the world with other kinds of traditions. People are raised in this. It's really hard to just let go of your tradition, the thing that you feel like is a part of who you are. It's very familiar, the globe. Like, we were all raised on sci-fi, on the TV. Many of us had rockets and globes in our cribs.
My Cope rationalization is noted.
Yes.
You know, there's a lot of aggression towards globe people.
Dude, don't be a snowflake. I don't listen. I pity the fool.
No, come on. You've got to agree.
No, dude, I was once just as brainwashed as you are.
See, you're calling me brainwashed.
Okay, I'm calling myself previously brainwashed. That's what you're not hearing.
No, you said you're just as brainwashed.
You'd be offended by everything. Don't be.
I'm not offended. I'm not actually offended. It's just
okay. Good. Then move on with it.
Yeah. Maybe. Never mind. Forget about that.
So, Printer, shame on us for being.
He's showing you his perspective, like just like I was showing you my perspective. Like, from my perspective, having left the globe belief, I felt like it was like a cult. And now interacting with the people from the globe belief, it feels even more like a cult because of how they react and how triggered they get just by the idea that some of their foundational ideas about how the world is are wrong, because they put so much faith into this whole system.
Yeah, we don't want to stereotype you, right? So we'll try to avoid that. This is what we've gathered from countless conversations and even being introspective ourselves about how we've behaved when we first encountered the information. So we don't want to project that onto you. This is just what we've observed, that the globe belief is devoid of any empirical or logical foundation. And everything that tries to defend it usually is from a place of either anchor bias or yeah, I don't know, wishful thinking, just a desire to stay on that side for whatever reason. I can't divine anybody's reason for wanting to hold a position that is devoid of empirical evidence or logical consistency.
But they have that illusion of logical consistency or internal consistency within their model. And because they don't understand what a reification fallacy is, they think the model represents reality. And so, because they never were taught deeply logic and how fallacies are so they could identify them, they end up just accepting these things, and especially because it was taught when they were so young, it creates the foundation when they were too young to actually question it. So when you get further in schooling, you're already building on that foundation you assume is true, and if you question it or you don't write the right answers, they fail you on the test. And so it becomes a very programmed machine that pumps out people who believe certain things, and then you find out over time, working in your field, that a lot of the things they taught you in school were outdated, and we're actually moving in this direction now. And so the school creates a certain idea in the general public, even though, like, we get a lot of people in here who think Newton, for instance, still works and is a thing that is believed within physics, when it's a convention that's already been falsified within actual physics. But most people don't know that because they don't go far into physics. They just hear the popularized things on TV or on TV shows and form their opinions based on that.
I mean, look, I'm kind of back here into a dead end because there's really two sides to the flat Earth theory that I'm aware of, and one of them is the experiments, and the other is that that we've been raised wrong, that we've been taught wrong, and all this other stuff. And we can't really seem to agree on any of those. We can't agree on gravity. We can't agree on the drop-off thing, the drop-off distance. I don't even really...
Well, we have no problem agreeing on gravity with many globers. The problem is most globers don't know anything about gravity and don't know that Newton's been debunked, Einstein's been technically debunked. And so they have 79 new theories within the highest levels of academia concerning gravity. There's like 20 different ones that are competing, and are some of them at the highest levels, and some of them are like modified Newtonian dynamics or modified versions of Einsteinian or quantum gravity or holographic gravity. So there's a bunch of different theories right now about what gravity is. But it doesn't change the fact that flat or globe, we all have a downwards vector and things fall. That's just what happens. The effect is the same regardless of your imagined geometry. Gravity has never been a problem. We can even use Newtonian or Einsteinian gravity with flat Earth. All you got to do is change the mass distribution underneath the ground, and it will work the exact same. So the effect is the same regardless of the geometry. The assumed cause has really nothing to do with the geometry.
So there is gravity. Like,
well,
we're not...
yes, there is there's
an effect.
G. Yeah, there's little g, the effect. We all observe that. Everybody does. There's a problem here with languaging in that people call little g, the effect, gravity, but they also call the cause, big G, gravity. And so when you have the same name for the two different effects or two different things, like, because big G isn't really an effect, it's just an assumption about what causes the effect, because they can't test the assumption. And that's why we end up with so many different theories, because they can't test it.
If I can add to that, Andreas, quickly, there's also an issue in the language when it comes to the claim about, oh, it's proven because we've done an experiment to prove it, right? Wherein in this sort of experiment, in this context, what they're calling an experiment, it would basically be a measurement or like a test of sorts, whereby, they drop a thing, it's in a vacuum, okay, they measure the density of this thing or calculate it, whatever, compare that with the surrounding medium, and then they drop it, and then they time, the time it takes to fall. They call that an experiment. You know what I mean?
What's wrong with that?
There's nothing wrong with that setup. It's you're measuring the time it takes from point A to point B. Perfect. You have all your things sorted out. You have your control variables and shit like that. The height, the density gradient, not gradients, differential, et cetera. Right.
The confusing measurement with experiment. Measurements are perfectly valid forms of gathering true knowledge, or because they translated science is now knowledge and not the correct application of the scientific method. So you can call it science within that perspective. However, it's not doing an experiment as much as it's just trying to measure something and control the other variables that could affect the measurements.
Yeah.
Right on. Yeah.
There's also contention.
If I may, right. He asked, what's the problem? The problem is, again, like I said before, and like Dre started off by saying, there's a problem in the language. If you go around saying, I did an experiment to prove gravity, look, I dropped my phone, there's gravity. Okay. Versus, I did an experiment to, test what causes water to boil. Those are two very distinct, areas of inquiry, number one, but also the setup to actually get a result, right? The results are very different, right? Not to mention the process of achieving that result. So to call them or to label them as being, worthwhile being put under the same umbrella is faulty. But we do it kind of colloquially anyway. Go ahead, Tita.
They're two different experiments, aren't they? Why?
One's not an experiment.
One is an experiment, one is an observation. So, you can observe a measurement and you can measure something and get good information out of that. However, an experiment is something to establish a cause and an effect, or cause to an effect. And so you start with finding an effect in nature, like things fall. And so you presume, what's the cause of falling? And you might think, well, if I scratch my head and jump, that makes things fall. Retarded. But that would be your positive hypothesis. And when you try that, and it doesn't make things fall that didn't fall before, then you realize, well, I proved the null hypothesis. I proved that my presumed cause wasn't true. I was just imagining some garbage, and it had nothing to do with what was happening. And that's why the scientific method is so valuable, because you presume the cause, and then you manipulate that presumed cause to see if it has an effect. If it has an effect, like in the case with the water boiling, you heat the water and it starts to boil, you have proven that heat causes water to boil. But when you just measured something falling, you did not prove the cause of that thing falling at all, you just measured something fell. And then if you then take that measurement of the thing falling and then make a bunch of assumptions and mathematics and create a whole model, you can create 79 different models of gravity through different mathematics based on the same effect, but because you never had a cause to test, you can't validate if that cause was the cause of the effect. Does that make sense?
Sorry, I lost you. That was too long. Could you simplify it a little bit? What was your main point?
let me try. Okay. In one context, you're literally manipulating a thing that you are supposing is causing the other thing to happen. Right?
All right.
Right? You literally manipulate the temperature, keep the pressure constant, whatever, and you see that eventually the water boils. Okay?
Okay.
In the other.
Right? And in the other, you're not manipulating shit. You're just dropping something.
Just observing the effect.
Yeah, and you're measuring how long it takes. You're not manipulating the thing that is supposedly pulling the thing down to see if it actually pulls it down. Or changes.
How would I
also,
do it correctly?
just quickly, that leads to an assumption that this, whatever the reason for your object falling, has an influence over all matter, right? But observably, we don't see it influencing gas.
Yeah. So from this, you can extrapolate out and assume a bunch of stuff, and that's where the storytelling starts to come into play, right? So whereas if you could, for example, say, okay, the mass of the Earth is pulling the thing down towards it. That's your hypothesis, right? That would be the variable responsible for the effect. If you could, hypothetically, manipulate the cause, i.e. manipulate the mass of the Earth, and witness a variance or a change in the rate at which things fall, right? Let's say, I shrink the Earth, in half, and I witness the acceleration of the thing downwards cuts in half, say, just for example. Or I reduce it by 90%, and the rate goes from 9.8 to 0.98, right? Cuts that in 10. Shit like that, right?
But even if you could do that, right, you still haven't. You've just demonstrated that there would be a relationship between an object's size or its density or its mass or whatever, right, versus the density or the mass of some other object, right?
Yeah.
You still haven't really established what that interaction is exactly, because Einstein came along and said, right, without the experiment, well, Newton was wrong. There is no force or field emanating from the matter just because it's matter and grabbing onto other things and influencing each other that way. No, he says there is no interaction between those objects at all if there was no space-time.
Right on.
So he's got a third variable involved now.
Yeah. There's a lot more to it, right? But what I outlined would serve as a good stepping stone in that direction, right? Whereby
shrinking the Earth down.
I'm just giving you a silly example, dude. And the whole point is you can't actually do that.
Exactly. Right? Is there an experiment I can do?
In this context, no. Because supposedly the Earth is responsible for this thing, or the Earth's gravity is responsible for this thing. Well, the mass, I should say, which causes the gravity. So there's an assumption that those things are intrinsically linked. Right now, implicit in that assumption in the first is that there is a giant mass, for example, in the heliocentric model, floating in space in the first place. Okay, that's the kind of sneaky motherfucker that you kind of just have to ignore or just absorb and forget about. Okay,
there's an experiment you can do for specific gravity.
Right. Yeah, there's stuff that you can test, dude, in this fashion that we're talking about. This is one such that you can't in this sense. So it's as if, over time, it was recognized that you can't really do that in that sense. So the rules of the game, say, or the rules of the field kind of adjusted or they laxed a bit, So as to allow this, context to be enveloped in this field, and we can't really fully experiment in the way that we know we should, but fuck it, we're just going to do it anyway this way with the rules relaxed and still qualify it as being science. It's almost as if that's what happened. I don't know. Seems like
they
that.
they freely admit this at the highest levels of academia. They'll say, like you'll ask Neil deGrasse Tyson, "What is gravity?" and he'll say, "I don't know," because at the highest levels, they're like, "We don't actually know what gravity is, but we have a pretty good guess, and we have calculated the effect, so we can like model it and do all sorts of things with it, and it's useful, but as to proving it, the effect, it's super difficult. First of all, like he was trying to describe to you earlier, but at the same time, our current theories of gravity don't actually hook gravity into the small things, like the kinetic molecular theory doesn't use gravity. A lot of our basic science on the super small scale just doesn't use gravity. If we were assuming gravity, like all matter would start to collapse in on itself. If we were coming from the matter itself, so it's kind of hard to understand, and that's why Einstein came up with his bending and warping of space-time, and because now you have a bending and warping of a conceptual medium, and you can't measure it and you can't test it. All you got is the effects, and so the medium is just meant to conform to the effects, and that's why it works so well. But when it came to like distant galaxies and star clusters, Einstein didn't work anymore because the galaxies were turning too fast, and the galaxies appeared too old for the Big Bang, and all sorts of things that made the current cosmology kind of fray at the edges. And so we have a lot of people exploring the fringes of cosmology today. We are just the people who are checking the foundations to the cosmology, and once the foundations shift, the whole thing shifts.
All right, so what I've gathered is that dropping something and measuring it is not a valid experiment. It's not real science.
No, it's not a scientific experiment. That's right.
Yeah, it's not a scientific experiment. It's a valid means of you could measure something dropping, and it could be a valid means of gathering information, which could be considered science.
So what is the actual like consensus on gravity? Does it exist or not?
Sorry. Printer, can I ask you something? Are you at all familiar with the scientific method, like formally?
Starts off with making a hypothesis, I think, and do an experiment. There's like 7 steps. I can't really remember them now.
Okay. So you, I guess you learned it a little bit in high school. Did a couple things, and then had to because you changed fields or something.
I'll Google it now. I'll just refresh my memory.
Go for it. And then let's walk through it. Right. If you guys, if I may, you guys, I don't want to interrupt. I want to ensure that Printer understands why we're saying what we're saying here.
Make an observation, ask a question, form a hypothesis, run an experiment, analyze the data and draw conclusions, share your results, repeat the scientific method.
Right on. Okay, cool. So in the context of you take your phone, you drop it, what do you observe? Or excuse me, you take your phone, you suspend it in the air, and you let go. What do you observe?
I see that it falls.
Okay. Second step.
Why does it fall?
Yeah. So what do you propose is the reason why it fell?
Form a hypothesis. Fell because of gravity.
Okay, cool. Does it go into more detail what the hypothesis consists of?
All right. Fell because all objects. I forgot the name for it. All objects act upon each other with a force at any distance.
I was asking, in that outline that you have there, does it show You're the constituent parts of a hypothesis. Maybe research that quickly.
This form a hypothesis. Wait, I need to
Just Google definition of a scientific hypothesis, let's say.
All right. A proposed explanation for a phenomenon. It must be based on observations, and a scientific hypothesis must be based on observations and make a testable and reproducible prediction about reality in the process beginning with an educated guess or thought.
Perfect. Okay. Does it say anything about the variables? Sorry, guys. I don't
know. I don't see anything.
Okay. Well, basically, your hypothesis, the setup requires your proposed cause for the thing. Okay. And then you have your observation, which is the effect, which depends on which depends on the supposed cause. So you have your dependent variable, the effect, influenced by the supposed independent variable, the cause, right? That you get to control or manipulate throughout the experiment to see if it affects the result. Okay.
Right.
Independent variable, dependent variable, and then you have a single one or a set of other variables that you want to maintain constant. They call them control variables. That might be influencing this entire thing that you try and, to the best of your abilities, control for. Okay.
Right.
You'll find that online everywhere. You might be botching it a little bit with some terminology here, but you get the gist. Okay.
Okay.
Perfect. So in this setup, with your phone, you observe your phone falling. What would be the independent, dependent, and control variables in the setup?
The independent would be the fall speed, I guess, or fall time, and the control variables would be,
or even just the sheer. Sorry. But even just the sheer fact that it falls.
All right. The fact that it falls, its a weight, size, atmospheric pressure around it, elevation. I guess those should be all remain constant.
So the weight you can maintain constant. You can probably do it in a vacuum, so you can maintain the air pressure. Humidity also, because it's in a vacuum. Humidity is 0, right? Et cetera, et cetera, et cetera. Okay.
All right. I don't see a problem until now.
Okay. Now, what about the supposed cause, the independent variable?
Well, that's my hypothesis, isn't it? I'm testing it now.
Everything that we've outlined is defining the hypothesis. Okay. There's one critical thing, right? You already said it. I just want you to see the key into the hole. Okay. Right. What is the cause of the effect? Supposedly.
Supposedly, it's gravity.
Wonderful. So there's your independent variable.
Right.
Experiment. What's your setup? What's your method? What are you going to do?
I am not going to do this right now because I'm going to break my phone.
No, I'm not saying drop your phone, dude. Okay.
Yeah, I'm kidding.
Like outline it, right? You got a plan for this shit, right? Okay, I want to figure this thing out.
All right, I'll drop it from 1 meter. All right, and I'll place a stopwatch next to me, and I'll press start as I drop it. How's that?
No, I'm not saying do it, dude. Okay, now check this out. Now it seems like you've changed the supposed cause.
Why have I changed it?
Okay, so in the hypothesis, if the supposed cause is gravity, right, the Earth's mass pulling it in for whatever reason, there's bendy warpy space-time, or there's some invisible three-toed gnomes pulling down your phone with lassos or something. Who knows? Whatever. Okay, whatever. If that's the supposed cause, But here you are not necessarily manipulating that supposed cause or that supposed variable, but instead changing the height at which you drop your phone, right? You're basically implying that the height is responsible for the gravity. Because that's all you're changing.
What do you mean I changed it? I didn't change it. It'll be 1 meter the first time. It'll be 1 meter the last time.
Hold on. Wait, let me just, can I bounce in here real quick? Brother, you said that your supposed cause is gravity. So we've got all of our controls. The height is the same. The temperature is the same. The air pressure is the same. Everything is consistent. So now we need to perform an experiment to get the dependent variable to occur. So you have an object. And I don't know what this object is. I don't even know what the observed natural phenomena was in nature, but let's just say we have an object. We're trying to make it fall because the falling is the dependent variable. That is the thing that is observed. So now you have
that was the independent variable.
No, the dependent variable is the observed effect. It is the effect. The falling of the object is the thing that you saw, correct?
So you disagree with the other dude because he told me that was the independent variable.
No,
he did not.
You misheard.
The dependent variable is the thing that we're trying to cause in the experiment so we can verify our independent variable.
Yeah,
All right, fair enough.
The dependent variable depends on the independent variable. Right? The effect depends on the cause. Go ahead.
You say gravity is the cause of the thing falling. So now we have all of our controls, we have our object. The next thing you need to do is vary and manipulate the independent variable. In this case, you would have to find an environment that you can add some gravity and take some gravity away to see if adding the gravity makes the thing fall or take away the gravity and it does nothing. Right? So, what is gravity and how are you going to manipulate it?
Why would I have to change gravity?
Because that is the thing that you said is going to cause the effect. So you need to add the gravity to get the effect that you're looking for.
I'll go to the ISS and I'll drop it from there.
Holy cow, dude. What are you talking about? Gravity, what is it?
I've answered this question like 50 times already.
Yeah, well, what is it?
I'll give you my standard response. It's the force that is applied from every object to every other object at any point in the universe.
That's a vague description, and it's just describing something that we don't actually observe.
Did you ask me what gravity is just to disagree on me on it? You already knew what I was going to say.
No, I actually didn't because we get different. Why are you freaking out, bro? I'm being very calm with you. I don't know why you're getting so excited. Do you think you could just take a deep breath? For crying out loud. So, you are ascribing this is a description of something that, read it off to me again. What is it?
I actually didn't read it from anything.
Oh, so you made it up on the spot. What did you just describe? What is it?
All right, I'll read it off of Google. Gravity is the law that every object with mass attracts every other object in the universe in proportion to each mass and inversely proportional to the square of the distance between them.
Okay, great. So what you need to do is get us whatever that gravity is and put it in this experiment to see if it causes things to fall.
You asked me to change the variable. You didn't ask me to personify gravity and put it in the experiment.
Dude, you're the one that has personified it. You're the one that has given it this vague description, even by Google. So we have to add whatever it is that you think is causing the effect. In this case, what is it? Mass? Or is it an attraction of mass? Okay.
Yeah.
Put that in your experiment. Vary that, put it into the experiment, and see if you get the effect that you're looking for.
Yeah, Printer, nobody was asking you to change the variable. What I was highlighting to you is that you implicitly did change the variable simply by changing the height. Because apparently the height is now...
Hold on. Wasn't I just told to change gravity in order to verify the experiment?
No, you're not following along very well. What I said is the...
Yeah.
In the independent variable is the thing that you would ascribe the causal mechanism to, the thing that makes the other thing fall. You have all your controls. Nothing is changing. We're trying to make the effect, the falling, occur. You said it was gravity. I asked you, what is that? And now you're saying it's some kind of force having to do with mass or something. Okay, well, that force, how can we put that into the scenario to make the effect that we hope will happen? How can you add that to make the effect happen? The dependent variable. How can you make the falling occur? So you're going to put in what? Mass? Or maybe you're going to put in a force? Well, which one is it?
Define put in.
I'm saying apply this to the object that you want to fall.
You want me to apply gravity to my phone?
Yes, that would be your independent variable. That's what you declared.
And what would I apply mean in this context?
That's what I'm asking you, because you actually...
you told me to do it. You have to define it.
Yeah, I'm not the one here that's supposed to define gravity. You are. I don't know what it is. You have described it to me in both your words, and then you gave me Google. So how do we get this into the experiment to make the thing fall?
That's what I'm asking you.
No, I'm asking you. It's your claim.
Well, my claim is that I don't have to apply anything. Gravity is just there.
Oh, so now it's just there. So you just decided to declare on your own volition that this is why it's happening, even though you can't make it happen in an experiment. That, my friend, is pathetic.
I made a hypothesis, and then I confirmed it using an experiment.
You performed no experiment. You did not apply an independent variable. You said it's always there, and that's why it happens. That's a baseless assertion fallacy, and it's ridiculous.
Yeah, Printer.
If it's not all,
check this out. Okay, this ruffling of the feathers that's going on. Okay, this is you internally starting to recognize the difficulty of this whole thing and why you can't actually do this. As we stated before, okay, you're coming to the recognition that you can't manipulate the supposed cause of the effect. So then you, as you just said, like not 10 seconds ago, you basically just declare it's there anyway. Follow?
How would I, all right, let's say I didn't declare that it was just there. Would I have to change it or not?
If you want to actually explore why the things are falling, you have to come up with a reason, right? A supposed reason, and then demonstrate that supposed reason actually affecting it. Period. It's very, very simple. In this context, obviously you can't, because you can't manipulate gravity hands-on. You can't manipulate the mass of the Earth to demonstrate whether it's going to have an effect on the rate of things falling, or the speed, acceleration, whatever. You can't actually do that. Therefore, it does not qualify as being scientifically experimented on. Period.
So I do have to manipulate it in order for it to qualify.
That's the whole point, dude.
Well, I asked just a few seconds ago if I have to change it.
If you want to change the entire... Hold on. Change as in alter the value, like manipulate the variable itself, or do you mean basically change the entire experiment, swap in a different supposed cause from this one? What do you mean?
Change the value.
Change the value. Yes, you have to do that.
I have to either come up with a different cause or change the value of gravity.
Yeah, you can suppose anything as being the proper reason, so long as you can manipulate it and demonstrate that it does or does not have the effect. So you can outlaw if you suppose something, you demonstrate that it doesn't have the effect, then it rules out that this is the cause, and then nobody else has to bother checking it again if they don't want to. Right? So there's value in null hypotheses, too. Right? But you actually have to have the test, or the experiment, I should say. It has to be a valid experiment, where you actually do manipulate the variable. In this case, you just can't in the first place, as you are coming to grips with reality about it. You can't in this case. So it doesn't
Well, if not gravity, then what is the effect? What is the cause? Sorry.
Fantastic question. And guess what? Everybody's wondering the same fucking thing.
I have been wondering since the start of this voice chat.
Mm-hmm. But you also came in storming that, oh, you know it's the Earth pulling shit down because of the maths. Right? So you either don't know and are wondering, or are certain and not wondering because you're already certain, or you're in the middle somewhere, or you think it might be this because, I don't know, you're biased in that direction. You were told that ever since you were a kid. I mean, we all were, right? It's not an attack on you personally, right? But these are the facts, man. It's an open question. Even as Drace mentioned before, I think. Neil deGrasse Tyson said the same thing. We don't know. Next question.
Wait, so you don't know either?
Of course not. How the hell would I know?
No one in this voice channel knows why the phone is falling.
Homie, did you not listen to Drace 10 minutes ago? Outlining that there are currently up, 70? In the 70s, okay? Number of different competing extensions or whatever to Einstein's theory.
So that, all right, well, that clears up your position. That's really all I wanted to know.
That we don't know? I'm surprised that hasn't been...
No, I wanted...
Yeah, I'm surprised that hasn't...
to clear up your position.
Yeah, and we're not making claims about that. We're just trying to show you that the people who come in here storming that they do know don't actually know. But they say it anyway. And then we inquire about these details, and they're like, they don't know. So their arrogance, slowly subsides, and they're like, okay. Sometimes they just leave and come back and argue the same points again and again and again, But at least, it seems like you're coming to this realization, which is good. Now, if we're wrong, okay, I'll caveat all this with this. Right? If I'm wrong on this, and we're all wrong on this, okay, I want to know. Okay? So come back if you find something.
That is not what I already stated. That's not gravity.
What?
Sorry. What?
Well, you said come back when you find something, and it's clear that the something that I've tried to tell you that it is, you haven't accepted, so I need to find something else.
Yeah. I get that. Yeah, if you come across something, right, something novel or whatever, feel free to bring it to the panel.
Now, the biggest problem that you're going to be bucking up against is that there is no exclusive downward vector for all matter. So these are more circumstantial observations than they are anything else. If you take an object and you put it in a medium, it may go downward. If you put it in another medium, it may go upward. This is what we observe, but we cannot actually give you concretely a cause as to why these things happen. They just do. It's almost like a law. We just observe it. We can't really explain why. This is just what happens.
You're talking about water now, right?
I'm talking about any medium. So you can take an anvil. It will fall downward in both air and water. But then if you put it in mercury, which is a liquid state of metal, then it will float in mercury. It will go upward.
What's your position on buoyancy?
Buoyancy is something that we observe, but the term buoyancy actually begs the question of gravity. What we do observe is specific gravity, which is Objects in mediums where they are less dense go upward, and when they are more dense, they go downward. That's what we observe.
I mean, that's true. So why not? All right, never mind. Well, I still have more questions. For example, why do you believe in this dome?
There's no belief in the dome. The evidence for any kind of container, we don't say dome, but a container for the gas pressure is required to have the gas pressure in the first place. Now, you say somebody here told you about a dome. Who was that?
That was you.
I didn't say anything about a dome.
I mean, the container. I called it a dome.
Okay. So there's a container for the gas pressure that we have on Earth. This is not disputable. We have gas pressure. The requirement for gas pressure in physics is containment.
Does it go under the flat Earth as well?
What do you mean under?
I mean, if, let's say, the container was like oblong thing or whatever, is there no up and down of the flat Earth? What? I'm not getting.
Well, as far as we can tell, the Earth itself is horizontally oriented. That's how we experience it. Up and down is the same for everybody. So it is a horizontal plane. What its complete construction is, I have no idea. I have no idea what the entire, realm looks like overall. But if we have gas pressure, then it must be contained.
Have gas pressure. Why is he asking about buoyancy now when it was addressed a long time ago? I don't remember why. Properties that are relevant. Okay. The dome exists because of gas. I'm going to Google gas pressure. It's caused by the force.
First of all,
by gas molecules colliding with the surfaces of objects. Although the force of each collision is very small, these refer. Okay. You were going to say something?
No, I mean, if you're going to call it a dome, that's fine. I don't know if it's a dome. There's a containment.
You don't know what shape it is?
I have no idea. What would that matter? We have the gas pressure. It could be a cake top for all I know. I don't know.
But it can't be a cube if the...
Bro, the thing is, we don't have a replacement cosmology for you. We are not a different belief system to believe in. So we just have measurements and evidence and logic that proves the old belief system false. So we don't have a replacement for you. So you asking us about the edge of the world or how things work that are unknown have no relevance to our actual arguments or points.
I still think it's worth talking about.
Well, fair enough. We would begin to, yeah. If you're going to speculate, we're going to go ahead.
Yeah, exactly. I wanted to say, if you want to speculate, we have speculation Sundays where people can speculate about why they think this works or that works, and we'll be like, well, how do we prove that? And if there's no way to prove that, nobody's going to believe that. don't believe things willy-nilly here. We try to be empiricists about things. If we can't measure and prove it, there's no reason for us to even entertain it normally.
The curiosity.
You can't really
in
prove
trying-
this dome, can you? You can't
No, we
see it,
can't.
you can't measure it, you can't test it.
Sorry, friend. The dome that you think exists, because you keep using the word dome, the evidence for the dome is the gas pressure. The container itself, the gas pressure is the necessary antecedent, or the container is the necessary antecedent for the gas pressure. You cannot have one without the other.
Yeah. So,
but there is a downward force.
Yeah. No,
there
that doesn't affect gas, though. That's the problem. If you take gas and you release it, if you take two bulbs and connect them with a valve, you have gas in one bulb and vacuum in the other, and then you open the valve, the gas will expand into the available volume, and it will not be impeded at all by any imagined gravity. And so this is the second law of thermodynamics. This is the most simplest demonstration. I have a recording of Richard Feynman saying that this is the most basic demonstration of the second law of thermodynamics. They claim we live in a vacuum, an ever-expanding vacuum. That means the gas would just continue to expand into the available volume and be gone. And then the next layer and the next layer and the next layer until you have no air on the earth. And then the entire ocean would evaporate. And then you would have no air, no liquids, and everything would die. That's the globe in a nutshell. It's violating natural law, which we can demonstrate here on Earth, where gravity is supposed to be the strongest, and it does not impede gas at all.
The reality is that the story behind the Earth being a ball within this vacuum is that however many billions of years ago, this ball Earth was cooling and off-gassing. So all of that energy, heat, gas that was leaving the surface of this ball would be leaving and filling the available volume of the ever-expanding vacuum, meaning no pressure of any kind would have ever been developed in the first place.
Let's say that I accept the container, all right? No strings. What's around it? Is there matter around it, or is there nothing?
How would we know that?
Yeah, just
choose any one. Is it not one of those two things?
No, this is not multiple choice speculation. You're asking us a question that we cannot confirm. Why would we even speculate on something so silly?
Two things.
No, bro, this is not pick your own cosmology day. We're not just willy-nilly deciding what...
Can you just humor me and do it?
No.
Can we just humor you and make up a new cosmology? We can do whatever we want if we wanted to do that. We have done...
I'm not asking you to make a new cosmology.
That's exactly what you're asking us to do.
There's plenty of...
No, I'm simply asking you to... Sorry.
Yes, you are asking us to make a new cosmology. And there's plenty of flat earthers who have done that. We are not those people. We are empiricists. So making up beliefs and imagining things are true is not what we do. We like to test. If those people can bring to us their imaginations, and we test if those imaginations are true, and if they're not testable, we don't have any reason to believe them.
Yeah, we're not going to create a fantasy.
Wait.
To create
a fantasy.
So you're presenting a false dichotomy. You're giving us two options, neither of which you could even possibly verify.
Yeah.
No, we're not going to engage in false dichotomies with you. Sorry.
I don't see why this is such a big deal. I'm simply asking you for
this anyways. What is the point? Why would we do this for you? Why are you asking us to speculate about stupid shit?
It's stupid shit.
This is because you didn't learn logic well enough in school, you didn't realize that you were making a false dichotomy and you're asking us to be illogical. And we don't want to be illogical, so we refuse.
You don't want to imagine what's around the container.
No, this is not a place for us to imagine things. If you want to imagine things, go to one of these, places where people think that they're dogs or cats. Imagine whatever you want. We're not going to engage in that. It's pointless, fruitless, time wasting.
Yeah, anybody can imagine anything outside of the reality. You can imagine there are ponies, there are leprechauns, you can imagine whatever you want. We don't want to imagine anything, because if you start imagining things and believing in a certain imagination of yours, because, oh, I like this one, well, that creates a bias. That creates tinted glasses that you now look at reality through, where you try to match reality to your belief. We don't want to become biased like that. We don't want to taint our clear eyes. We want to see the world for what it is and let the world tell us what it is based on what it gives us, not based on our imaginations and trying to match the world to those imaginations.
So there could be anything there. There could be ponies, there could be whatever, we don't know.
We don't know, yes.
Wow. That I was not expecting so much backlash from that question.
We get this all the time.
Right, how about this
annoying.
one?
It's annoying because we get this all the time. Let me just finish this. We get this all the time where people tell us, what's beyond the end of the earth? And the same idiots are telling us, well, the earth is a globe because air moves around a tree. We're not making claims what's beyond the known earth. We're just making claims about the surface of the earth that anybody can go out and test. And we're not even asking you to believe our claims. We're just saying, maybe you should question your claims and go check them.
So anything outside the earth is off limits. Is that what you're telling me?
Anything outside the earth we don't know. Like, it could be many things. There's if you actually started to research this and look at all the different ideas of the different flat earthers, we're the conservative flat earthers who stick only to the measurements and the empirical and the logic. And so you can't come to us with some retarded idea of how you think the world works without evidence. However, there's millions of flat earthers in the world, and
I didn't even present an idea. I simply asked you what's out there.
Yeah, that's why I'm telling you. There's many of flat earthers in the world who have imagined how the world is beyond the known land masses. And if you look into that, there's many interesting tidbits you find within it. However, you'll notice that they all have a belief they're trying to push, because aspects of what they believe are not verifiable. We like to stay within the verifiable. So you can explore this topic and find what you're looking for, but we're not going to do that for you because we don't do that here.
Right. So, like, you just don't care about anything outside of the earth, like the moon, the sun, the stars, nothing?
Oh, we care about all of that stuff. We just are not delusional enough to think that we know what that is without enough data to determine what it is. And so that means that we can look at all of the different speculations about what it is without having a bias that makes us go like, oh, I'll dismiss this out of hand because it doesn't match my ideas. And so we can look at all of the ideas and be like, well, there's problem here, there's problem there, there's problem over there. But they had some interesting ideas over here, they had some interesting data over there, and so the more data you have, the better idea you can have about the world. But there's always going to be a problem with you don't have enough data, and that's the position we're in right now. We can't make you a map. We can't map the whole world for you. What we can do is measure the ground, and anybody can do that.
So a consensus can only be reached if anyone can perform an experiment on it.
Yeah, essentially, if you can make it so that it's completely logical, you have evidence to support it, and then you can get people to have a consensus on it. Problem with the current consensus is we have a bunch of fallacies, and people have a consensus on the fallacies, and then they appeal to the majority because many people believe the fallacies. That's just stacking fallacies, and we don't do that here. We like to stay empirical. Give us the data, or we'll just ignore the claims, because the claims without evidence can be dismissed without evidence.
But it is true that everyone has to be able to perform the experiment, right? Within reason.
Essentially, yeah, that's basic empiricism. That's repeatability. If you can't repeat the experiment, if it's something that you have this special fairy dust that allows you to talk to the fairies, and that's how you know all this stuff, and we just have to accept it because you have the special fairy dust, and we're not allowed to get any special fairy dust, then that's not acceptable.
So, if I was a millionaire and had access to a special hot air balloon that allowed me to go above 70 kilometers, let's say, and I just kept going up, and I reached the container, and I made some measurements about it, and I came back down and told everyone, that wouldn't be enough because no one else can do this. I'm the special fairy that can tell people whatever I want.
Yeah, you claim you have this special technology. Of course, that's a pretty absurd example. With
hot air
balloon, because we have sent up all sorts of balloons of all sorts of types, and we know how high they can go and where they stop. So it's not reaching any imagined dome yet, because we can't get high enough. We just have not been able to go high enough. They claim the ISS, for instance, is circling the Earth, and we get these pictures, and we see this Earth curve in the pictures. But if you look at the math, the ISS is so close to the surface, it only sees about 3% of the surface. And so it has a horizon line, just like you and me, that's circular around the craft if it were at that height. And I don't know that it is at that height. That's just the height they tell us it's at.
So where is it then?
I don't know. I didn't put it up there. I can't verify its position.
But it is somewhere high up.
No, not sure how high it is, if it even is there, because there's many different ways of spoofing its position. So you could see something in the air and you think it's the ISS, but it could be many different things, and we have no way of determining which of those things it actually is, if it is. So usually
I find this problematic because not everyone can perform experiments. Not everyone can perform every experiment, especially the expensive ones.
Oh, I agree. It's not reasonable for you to expect someone to perform every experiment for every single thing. You can watch many experiments if you want to understand something. You don't have to perform all of them yourself. You can watch other people perform them, and then. But if you're gonna try to build on that or make claims on that, then your experiments, you would need to do experiments to validate that. Like I am writing a optical framework, for instance, a scientific paper essentially, and before I publish it, even though I have a bunch of data collected over the years from other sources, I'm gonna make my own data to go with all the other data before I publish it.
Even though you have your own data, you're going to make your own data to go with the other data before you publish it. How is that helping anything? You can't, like, that's not allowing me to do the experiment for myself.
For instance, the optical framework, when you create something like that, what you want to do is, and that's what I did, is you make it falsifiable. And so people can go out, if they want, try to replicate your findings, and if the findings don't come out that way, then you have falsified the framework. And most scientists and most people don't allow for this and don't give this opportunity because they are scared of their funding. They are dependent on this. I am not. And so I don't care if I'm wrong. If I'm wrong and somebody proves me wrong, I'm happy because I learned something new. Just like I went into this flat earth thing, I wanted to prove them wrong, but because they showed me that I was wrong in my assumptions, I was like, okay, I'll test this other thing because I'm not going to believe you. I don't believe anybody. The world informs me of what I believe, and so I'm not subject to the manipulations of other people.
You said that they can falsify you if they want. How are they going to do that?
It's very easy. For instance, when it comes to the globe, they tell you that the horizon should be X far away based on the geometry. And then once optics got more advanced and we started seeing far smaller things with larger optics and zoom capabilities, we suddenly started realizing we were seeing 10 times beyond the proposed Earth curvature, which we assumed was the geometric limit or the horizon. And so after that, they started saying, oh, well, the horizon's apparent. Well, there must be refraction causing the light to bend around the globe and making it appear flat in all observations up to the horizon. And then beyond the horizon, that's where it starts to curve, boys. It's somewhere we can't detect. That's where we start to see the curve. But it always looks flat up to the horizon. And we can see way too far, so it must be refraction. Problem is, they never actually tested that, and they just kept on assuming that the light was, whenever the observation didn't match their presumption of the globe, they would just bend the light to make it match. And so it became an ad hoc excuse to save them. And so I proposed a simple test, because visible light refracts at a certain rate. Infrared light refracts at a lesser rate. And so the two wavelengths don't refract at the same rate. And so you can take two cameras, one calibrated for infrared, one calibrated for visible light, and then you can observe the horizon with those two cameras. And in the visible light camera, the globe predicts that you would see further in visible light because the light is bending around the globe, making it appear flat so you can see so far. However, infrared doesn't refract as much as visible light, so it wouldn't bend as much, wouldn't allow you to see as far. So you have a prediction for the globe. You see further in visible light, less far in infrared. And then for us, we don't need Earth curvature for anything. In my optical framework, I describe every single refractive effect over a flat surface. It's very simple and very easy. so for us, infrared refracts less, so it causes less ray loss. So when the bottom rays of objects in the distance get refracted down, if those rays hit the ground, you're not going to recover those rays, and so the bottom of the object will be occluded or will be obscured. That's just the light hitting your eye.
Right. So you need 2 cameras for this setup. Or
Yeah, that's to falsify my framework, and because what I've seen through a bunch of other people using infrared cameras and people taking pictures is once we use infrared, we actually see further because infrared cuts through the haze and allows us to see further, and it doesn't refract as much, so we have less ray loss. And so that's the inverse prediction if the Earth is flat, is that we would see further with infrared, less far with visible, which is completely the opposite of the globe. And all of the data I've seen so far seems to support the flat Earth position, or that we see further with infrared, and that's why all of the world record long distance photographs are all taken in infrared.
Right. Well, here's my problem with this take on experimentation. It's that you don't trust isolated experiments that can't be replicated. And that sounds like common sense, like why would I trust that? But let's say that you are the one performing the experiment. And the experiment was you go build some device and you go really high up and you find the container, right? And you see it. Or you don't see it with your very own eyes. Maybe it's not. Maybe it's made of something like, I don't know, that you can't see. Then you come back down and you try to publish your findings. But no one else can do this. No one else can build this experiment, and no one else can falsify it unless they have giant wads of cash just lying around.
Yeah, but I don't have giant wads of cash. This doesn't require giant wads of cash.
Your experiment doesn't.
No,
but
you're inverting it, because the Globers claim that you require giant wads of cash to get things into low Earth orbit, and even Werner von Braun and Elon Musk claim that to get to the moon would require multiple rockets to refuel in orbit, which didn't happen with the moon landings, for example. So it's clear that that was a lie, because they didn't have the fuel to get to the moon, according to the space experts.
Moon landing costed billions of dollars, though.
Did it?
A free experiment.
Yeah, and who got all that money?
It was used to build the rocket. And it was financed by the American government. Am I wrong there? Anyway, that's besides the point. My point is that if someone actually did go up and touch the container, no one would believe them because they can't replicate the experiment.
Well, they should be able to replicate the experiment if someone can go and do that.
Why? They don't have the capacity to. They don't have the money.
How did they do that? How did they do that? What technology did they use to do that?
They used a hot air balloon. Or alternatively, a rocket.
So, like, why isn't other people testing it? And, like, if
anyone can make a hot air balloon
result, we need to figure out why he's getting a different result from everybody else doing it.
I didn't even imply that they.
This is kind of like with the flat Earth. Everybody else is doing it, and they're finding the Earth is flat. Meanwhile, there's this one guy who claims that he has done it with the same equipment that like everybody else is using, but somehow he found it.
I'm trying to. You're not really getting my point. I'm trying to put you in. I'm trying to make you put yourself in the perspective of someone that actually goes and does this. That actually builds a rocket and touches the container. And then comes back down and no one believes him because they can't also build a rocket. And I'm trying to get you to see that there's a problem with that. You can't expect all experiments to be replicated by anyone.
No, I agree with you. There's a giant problem with that. Someone claiming to have done that, and then claiming that when he did that, he debunked observable reality. That's a problem. Why would you believe that?
Debunked? What do you mean debunked observable reality?
Because the guy who, in your example, the dome in your example is the globe Earth. In the globe Earth, they claim they have so much money.
No, it's not the globe Earth. It's the container.
No, bro, it's the same analogy. The analogy is the same. In your example, the container is the globe Earth. They claim they have the power and the money to go and verify the container, the globe Earth, but nobody else can go do that. And then when we go actually and test the ground, which should be curved like they claim, because they have the secret knowledge, it isn't curved. So we know that they are not telling us the whole truth.
I'm sorry, am I wrong that you claim that there is a container that causes gas pressure around the Earth?
There is containment of the gas. We don't know how that containment works.
Okay, so let's say someone wanted to try and find out. So they build a rocket and they go up.
Yeah.
Right.
They go up and
they either see it or see something
else. They can't
else.
go any further, and then what?
And then they come back down.
Yeah,
and try to tell people
up,
about
they
it.
couldn't get any further. They didn't find the end. So how did that help?
What do you mean they couldn't get any further? You yourself said you don't know what's up there. Why are you assuming now that they couldn't get any further? What does that even mean?
Because that's how rockets work. Rockets push off things.
Okay. I don't think you're getting my point here.
I get your point. You're imagining that what if
what is my
went
point?
Up into the, you're imagining what if somebody went up to the sky and touched the imagined end point, and then went down and told everybody, well, I have the secret knowledge of the end point of the sky, and nobody believed him.
Yeah.
Yeah?
Okay.
Where are you going with that?
I'm saying they should believe him.
Why? Because one retarded guy who was hallucinating on shrooms and believed he did all those things, claimed he did those things. Why should we fucking believe him? That's called being naive and gullible, buddy.
Well, relax.
You need to actually test his claims. If he claims that you can go up there and you can do this in a hot air balloon and people go up there and they can't, then you know he is bullshitting you. Just like we go out and they claim the earth is curved and we go out and test it, we know they're bullshitting us.
Nothing that has been said up to this point has pointed me to think that you can't go and touch the container. What's stopping you from going higher?
Rockets push off things. So, like, if you take a rocket and make it push all of its exhaust into a completely vacuous chamber, the vacuous chamber will fill, and it's not until the gas hits the wall of the container that the rocket moves forward.
No, that's not true.
Oh, we have evidence of that.
No, you don't. That's wrong.
Oh, we have.
I'm sorry, but when you throw something, you're gonna get immediately pushed back before that thing hits any wall. You can try this with yourself now by throwing the bottle.
Are you in a medium?
Yes, I'm in air.
Yeah.
That doesn't disprove anything.
Oh, you're pushing against the air.
All right, and so is the rocket.
Yeah, you're claiming the rocket's in nowhere.
No, I never made that claim. I simply said that rockets can go up.
Yeah, and eventually the air gets so thin that they don't work very well. And so there's different types of nozzles and different things they do to try to make them work better and go higher. And that's why you have ballistic intercontinental missiles. However, there's a limit. You can't go pushing off nothing.
You can. It's Newton's third or first, I don't remember, law of motion. I can't prove it because I'm on Earth. To prove it, I would have to go to space.
Yeah, unfalsifiable nonsense.
No, it's not unfalsifiable by you. You're saying that it only happens because I'm in a medium.
You could not prove it. That means it's unfalsifiable. You cannot.
I can't prove it by your standards.
You have to go into Narnia through the magic closet to talk to the lion and tell me he's real.
Wait, what?
All right. Rockets have the same effectiveness no matter where they are, because it doesn't matter that they're pushing against the air. As soon as you throw something, you get an equal and opposite reaction. That's one of Newton's laws of motion.
Yeah.
And that's true. It's measurable. It's detectable.
We've all heard this claim. However, we have not seen any evidence that this is true, that you can push off nothing. And so far, many people have tried to do this. Mythbuster tried to do this. Cody's Labs tried to do this.
Oh, Mythbusters.
Yeah, and the problem is...
you can actually do this. I forgot about vacuums. Put yourself in a vacuum and do it.
Yeah, every time they do this, we watched all these examples. Every time they do this, every time, the exhaust from the rocket repressurizes the chamber, and you don't get movement until you have pressure.
What do you want me to do? Build this now?
No, I don't want you to do anything. Like, I am not asking you to do anything. I'm just answering your questions. Like, if anything, I just want you to be critical of your own beliefs. Like, I don't care if you never turn into a flat earther. Like, you might realize that, well, they're not telling me the truth about the globe. Like, there's contradictions here. I don't want to accept that. Like, you might get to that point, and I'm perfectly fine with you even being a completely zealous glober. Like, I don't care what you become. Like, I don't care what you believe. I'm just here to help you if you want it.
Neither does science.
Yeah, and I love science.
Me too.
So how high has the highest rocket gone, just out of curiosity?
Well, the claim is it's gone to the moon.
All right.
That's
and
the highest.
What's your opinion?
Well, I don't have an opinion on that because I don't know. I don't have opinions on things I don't know.
So we don't know how high the highest rocket has gone. That's very convenient that we don't know how high they've gone.
Yeah, right.
Well, like I told you, I know how high they claimed it has gone. However, I don't actually know. There's a difference between belief and knowing. So I could believe that what they're telling me about how high they've gone with a rocket, or I could just be like, well, I don't know how high they've gone with a rocket. They've told me this high.
Why don't you believe them? Don't you have a reason to not believe them?
I don't have any reason to believe that.
What? How would you believe that? In what world? Like, what would you have to be there on the rocket?
Like I told you earlier, there's no reason to believe they've ever shot a rocket all the way to the moon, because according to Werner von Braun and Elon Musk, Werner von Braun said they would need 3 of the rockets that they used to get to the moon, 1 to get into low Earth orbit, and 2 to ferry the fuel to refuel that first rocket so it could get to the moon. Elon Musk said he would need 15 starships just to refuel the spacecraft to get to the moon. So logistically, they never could have gone to the moon. But then we take all of the supposed images and evidence that they've gone to the moon, and we look at the different perspective of the images, let me find the link. I'll find the link for you. This is a...
You said that it takes 1 rocket to get into low Earth orbit?
Yeah, essentially. It uses about 98%, 95% of the fuel to get to low Earth orbit.
And how high is that?
It's claimed to be about... how high is the ISS? Fuck, I need to look that up.
120 miles?
Yeah, roughly.
See, that's interesting because of like maybe 2 hours ago, that's how long I've been here. I don't know if it was you, but people told me that you can't go that high. No one's ever been above 60 miles.
Nobody's saying they went that high. This is what is alleged.
Yeah, the NASA crew and the ISS crew claim to have gone higher than that, but no commercial flight has gone higher than 60 miles, and that's Bezos and crew.
Flight? You mean like in an airplane or any?
No, like Bezos had his penis rocket. He shot Lady Gaga up there and William Shatner, and then William Shatner was like, well, it looks flat from that height. And then the old lady who was like, I'm super disappointed that I couldn't see the Earth curve.
Okay, so how high did they go? Or you don't believe them? You don't?
I'll give you Neil deGrasse Tyson talking about that just a second.
Very serious scholarly discussion going on here.
Yeah.
Yeah, until you entered into it for itself.
Right. So we just don't believe anyone who says they've gone high. Not hot air balloon, not Bezos, not NASA.
But it's not about, like, what you don't believe them. Like, William Shatner and the lady who went on the flight said the Earth looked flat from that height. However, like, Lady Gaga says something different, but, like, she's crazy. And here's hostile witness, Neil deGrasse Tyson, on Bezos going up.
Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Well, yeah, say right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody has seen the curvature of the Earth from that height. I just want to make that clear.
always curves, but it's imperceptible at human scale. We already
You
talked
just
about this.
told. Okay, fine.
That may be true, but it's not immeasurable at human scale. Okay. We have
Imperceptible with
equipment
just
sufficient to the task.
Okay.
Okay, yeah, with your naked eye, yeah, we all agree with that. You don't need to repeat it. We all understand what you mean. It's not kindergarten here. Okay, but it is measurable by the tools we possess. If it wasn't measurable by the tools we possess, then it wouldn't be the case that many globers are claiming they're measuring it with the tools we possess, such as theodolites and other type such things. So if it's the case that it can be directly measured, which it should be able to be by the tools we possess, such as lasers, etc., then all you have to do is arbitrate the one principle, and that is water level. If water level is indeed flat and not curving, then the Earth is flat, ipso facto, period. If water level is indeed curving, then the Earth could be a globe. So all you got to do, Josh, is just demonstrate to the flat earthers that the water's curving, and then you've proven that it's not flat.
Okay.
Well,
There's no argument. Real quick, there's no argument that water seeks level, and that in its equilibrium, water is at rest, and it's the definition of level throughout human antiquity. Like anybody who argues that just needs to be slapped upside the head with a mental stick, right? We all agree water's level. The globe claim is that water level is actually a curve around a giant ball, and not a level, flat, horizontal surface, just like we all experience from our direct observations.
Yeah, I mean in spherical geometry, level is just holding R constant, right?
Yeah, I know, and that's sure. I mean, you could write that on a piece of paper. Well, that's great and all. You could draw that on a piece of paper. Nobody doubts that. Nobody doubts that if you made a sphere with a 3D lathe machine, that you could then make a concentric circle around the sphere, right, and say that these two arcs are parallel to each other. No one's doubting that either. Okay, the problem is that's all theory. Practice is when you apply it to the actual Earth and prove that there's parallel arcs, one of which is the surface of water.
And the other, which would be a laser you shoot over it.
Why would a laser have a parallel arc to the surface of the water if it was curved? We think lasers just follow the curve of the Earth? Are you kidding me, dude?
It's traveling through a medium of specific pressure and temperature lines. Like I mean, you can say the R word if you like, but it's how these things work.
Yeah, that's great. That's great, and all of which your side claims that they know all about it. So give us the accurate model so we can use a laser and apply it and measure the sucker already, instead of hemming and hawing and having to listen to people like you saying, "Well, I don't know how I would prove it."
Yeah, I have no idea. I haven't done that. I appreciate.
I know. We agree. Yeah, no worries, brother. No worries. We understand. Nobody's done it. Okay, that's the real problem. Is that nobody's ever given any actual quote unquote the refraction model that we can use to understand what we're looking at. It's always a post hoc excuse of I see something that's geometrically impossible on this geometry if the Earth was this size. Therefore, I'm going to assume, based on the prior premise, I already know the Earth is a globe, that the light must have curved to reach my eye or my optic, therefore it curved. That's how it actually goes in reality.
Yeah, because in reality, folks have other sources of data that are beyond, local long distance experiments or long distance observations. Like they have that premise. They lean on.
Yeah, they have this premise. I already know the Earth is a globe. And then when you actually test them on how they know that the Earth already is a globe, that's also stacked on a bunch of premises that also have to be proven separately, right?
Correct.
So we've never gotten down to the brass tacks of where's the foundation of this mighty, long, tall tower that's been built on the premise the Earth is a globe, when the premise the Earth is a globe hasn't been proven in the first instance.
From your perspective, yes. That makes sense.
Josh, so they're not leaning on it, they're kneeling on it and praying.
The leaning tower of hopes and dreams.
Just people, man.
He acts like
it is what it is.
We know the books are cooked
for them because they've been wanting this to get God out of it, and that's all there is to it.
Okay.
Right, so reverse the Uno card. You came here to sociologically study flat earthers. We told you straight up. You believe the earth is a globe based on a whole set of presuppositions and premises that aren't proven in the first instance, that are circular reasoning, and a whole bunch of loop-de-loos. And when you're just asked to demonstrate that the surface itself is just actually curving through a direct measurement, you have no answer. And so if that's the case, my friend, then you understand already the sociological phenomenon of why flat earthers are flat earthers. Because everyone experiences the earth as flat and stationary, period. And someone like you who should know and should be able to help them out and give them the one truth to rule them all, that supposedly is the truth of all truthiness, which everything is founded on, that the earth is actually a ball floating in space. You can't do it. So why do they care? I'll tell you why they care. They care because you're denying their experience. You're basically saying what you experience is a delusion. You experience the earth as flat and stationary, but you're a delusional person for just coming to the conclusion, well, it's obviously flat and stationary, whereas you claim it's something that you don't experience. So who's the delusional one that should be studied?
Well, no, I think the delusion is not that. It's the extrapolation that because my own observation, my own senses are telling me that A must also be correct at at a scale way larger than myself. Right. It's that faith in that extrapolation.
Yeah, cool. So basically, you just shot uniformitarianism in the foot. So, for example, the same thing applies to you, and I'm having a faith at scale that spectra in a lab and something that looks similar to that spectra coming from something which I can never go validate. I'm going to say is the exact same thing and functions in the exact same way based on that quote unquote extrapolation by faith. So, yeah, I would agree with you that your belief in the cosmos, where it is, what it's doing, and where it came from is just out of faith, borderline a religion, if not a religion de facto.
I can get down with that.
I know you can.
You are
because you're an honest guy, and you recognize that your worldview is a religion, and I applaud you for being honest.
I was going to say where usually my head goes here is just diving into a pragmatic fallacy, which is
pragmatic.
No, shit works. Therefore the way that
I knew he was going to say that. People get their packages. Therefore, Earth is a ball.
Yeah,
that's lunacy.
I understand that. I'm just explaining where my head's at.
Yeah, fair enough. So I could also say the transverse is true, which is the alleged claim of the globe being a shape that actually has any impact in anything we do is so negligible that it's technically irrelevant. And even if you account for it or don't account for it, the end results will be that everything works within a small margin of error that's inconsequential for pragmatic ends. In other words, shit works. So we both have the same answer, dude. So the difference is how are you going to prove one or the other? Yeah, so the burden of proof is on you. I know you're not. That's how it works. That's how it always works.
Because that's not my purpose.
Well, yeah, that's fine. So meanwhile, people go out, they measure with lasers, they use dual bands, they use multiple frequencies, they account for refraction, they apply PhDs in optics do it. All kinds of people go out, they measure the Earth, they find the hump of Earth curve isn't there, and so they know it's flat, and they know that you believe it's a globe, and so they're happy to go to sleep at night and have you sociologically crunch them because you're curious of why people don't believe in your religion. So cool. I think we solved it. So now you know the answers and the reasons for your sociological write-up. So good for you. You win.
Like I said, there's a lot of nuances person to person, but I think that's a good general thesis. I appreciate that.
So when did you learn, person to person? When did you learn that you're participating in a religion? During your time here?
No, I don't say I agree with you. I say that
You said you could get down with that.
Yeah, exactly. That doesn't mean I agree.
Please define you can get down with that. I can't believe it's come to this.
I'm saying that perspective makes sense hypothetically to me. from the person from the
That's what
worldview
you're
of the person that makes.
demonstrating. That's what you're demonstrating. Every time one of your claims a thread is pulled, you say, well, I'm just believing it. So it's not hypothetical. It's what you are. Self-admitted.
Okay.
So you're the one that should be studying delusion.
Sure.
Okay, good.
So, guys, I'm trying to figure out here. So, our friend Josh here, especially early on in today's conversation, told us about 100 times that he didn't want to talk. He just wanted to do his laundry and listen to us, et cetera, et cetera. And it seems like he continues to talk from almost a compulsion that none of us have controlled his microphone. None of us have forced him to transmit. All he had to do was just say, hey, guys,
I never heard him say that.
Now,
So
what is it, Josh, that keeps you coming around? Is this like a study for a course of study that you're doing? Like, what is it that has you continuing to return to us?
Well, I mean, I'm writing an IOC paper for not next year. I'll give it another year. I got already one cooking for 2026, but there's a big space conference every year in October ish, and I like doing independent research for it.
Are you going to be talking about the phenomenological expansion of the social phenomenon, of the social pretense, of the social expanse of the flat Earth movement?
No, I mean, I haven't really put together a full abstract yet of what I want to look at, but I think there's some interesting
You should talk to Scott
correlations.
Mackey, brother. You should talk to Scott Mackey. He's been a quote unquote studying flat earther psychology, and he supposedly has psychological credentials in some regard. And he's putting together this study. I just got to warn you though. Scott Mackey said that if the Earth turns out to be flat through direct measurement, he would check himself into an insane asylum because his belief is that he's concluded that the Earth is a globe based on its faculties, and if that was proven wrong, he must be insane. And he chose insanity rather than mistake. That's pretty weird, don't you think? I think that type of behavior should be psychologically studied.
Yeah, I can get down with that as well.
Yeah, imagine the ego on yourself. There's no way I could be wrong about my premise of what the Earth is, so if it turns out to be wrong, I must be insane, and I'm literally going to check myself in an insane asylum, then just admit I was wrong.
The funny thing is, Mackey, if past performance is indicative of future, he would even call you out on some of your bullshit, Josh. But yeah, include a chapter since you haven't decided what you're going to include in your writing. Include a chapter on yourself.
Oh, sure. That's like
include a chapter.
Chanting religious zealot thought they were speaking science.
Yeah, let's do something more important. Let's include in there that there is tensions between people, individuals, family members, sectors of politics, governmental agencies, social companies, et cetera, that are exacerbated by this not being definitively with a stake through its heart by a direct measurement of the Earth. And get some plea funding for a direct measurement of the Earth that can be actually direct. That's something that doesn't require a whole bunch of loop-de-loos and la-di-las, but it's just straightforward. Like, a structure like Brian Mullins, the engineer, came up with called Force the Line. It's less than $1 million in cost. You just need a piece of land and a crew to execute it. Or like the gyro box thing where you take a multimodal gyro system across 35 miles of the surface of the Earth. 3,500 north, east to west, and then 1,500 north to south. Brian Mullen. Oh yeah, let me tell you real quick where he went. A Globe zealot decided to attack his family and his livelihood by attempting to get his license pulled, harassing his workplace, harassing his customers, basically saying, because he's a flat earther, he can't be a competent engineer, right? That's what we've had to deal with, this sociological study that you're so interested in. I suggest you study Glober zealot crazy people and why they are so psychotic about the idea of flat Earth, why they are
It's
so
cognitive
visceral
dissonance.
and full of vitriol. Because rest assured, friend, people's mothers, grandmothers, aunts, uncles, loved ones, spouses, children are flat earthers. Okay? Your family members are flat earthers. Everybody you know, there's somebody that's a flat earther. Do they deserve derision, hate, disrespect, being called that they can't have a job, et cetera, et cetera? Right. So why is it the case that that kind of nonsense is not only tolerated, but often endorsed in the public sphere?
To be fair, like I tend to go to bat for y'all pretty hard.
Good. So go to bat and say we want a funding for either Force the Line or the gyro box, which is,
What
by
does
the
that
way, just a
even
whole bunch
mean?
of gyros that are going across the surface of the Earth to be the longest continuous measurement of the surface in the history of mankind. So any of those types of things could be funded and just done, and it'll be over. Because let me rest assured, Will Duffy thought he was the savior of mankind, right? I'm going to save everyone from flat Earth, including flat Earthers from themselves, because being a flat Earther is morally bankrupt and you're poor and all that stuff. You know, all his ad hominem nonsense. And he said, the way I'm going to prove it is by going to Antarctica and looking at the sun. That's not a direct measurement of the surface of the Earth. That's why it wasn't final, because what flat Earthers want, and if you want to help them out, you got to give it to them. You got to give them a direct measurement of the surface. So get some of that funding into that, because let me tell you what that's going to do for you, Josh. It's going to increase the esprit de corps to be tolerant of all this space nonsense and to be exuberant about paying money for it and to be like, yeah, let's do more of it. So it'll help you out.
What do you mean? I got to
Plus-
ask, dude. What do you mean? Yeah.
One more second. Plus, you could write a big Amazon sticker on the top of the structure. Be like, Amazon finally proved the Earth was a globe through a direct measurement methodology that you can drive down I-40 and just look at with your own eyes. Look, there it is. Force the line. Clearly, the Earth's curving away from the level line structure. Boom, shabam, it's done. Amazon. Buy now. Subscribe.
Just making it very clear that my presence here and my this endeavor is 100% independent, has absolutely nothing to do with my employer.
Oh, fair. Then have the UN fund it.
What? Yeah, that's what I'm asking. I'm glad.
What was the question?
But see, the problem is, brother, instead of guys like you actually helping us out or helping the Globers out, either way you want to look at it, we got guys like Dr. Shiva, right, who says he wants to oversee the scientific method to prove the shape of the Earth, which is a category error. You can't prove the shape of the Earth with the scientific method. You need to just directly measure the thing. This is what we got to deal with on the globe side. We got to deal with doctors, right, in front of their name that are too stupid to realize that a direct measurement of something has nothing to do with the scientific method. These are the kind of morons we deal with, Josh. You see my problem? You feel my pain?
Oh, yeah, they're awful. No, they're awful. I mean, honestly, like, you know, Indio and Jin can tell you, I tend to call out bullshit Globers in the other rooms as well.
But they think, brother. They think the thing is, they think they're self-appointed to teach us and save us from ourselves with their knowledge of how they're going to figure out whether the Earth is a globe or not, and they're too stupid to realize that the scientific method is not the thing to use. This is the problem, brother. These are the kind of morons we deal with, all the way from the average person up into the most educated person. Even people that allegedly search for quote-unquote exoplanets are too stupid to know any of this stuff.
Well, they spent the first, 18 years of their life catching up on quote unquote human history and human knowledge, and then they go off in their specialized field to go
Exactly. Like we had a guy who was an astrophysicist specializing in the finding and classification of exoplanets, and the dude didn't even know the first rung of the cosmic distance ladder. These are the kind of morons we're dealing with, bro. He has no idea what he's doing. He could be fed any kind of data, and he just sits there and puts it out like a stupid person that's no different than a temp that says, hey, when the A button flashes, press the B button. That's about his intelligence.
I had a friend like you who, and I know I'm no saint, but I had a friend like you. If you ever brought something up to him and it kind of, he wasn't privy to it, he would always bring up something sort of parallel to it with extra information. I don't know, man. I need, you're here to learn. I'm here to learn. I need to have more level conversations. I got to be in my bonnet. I'm not attacking you. I'm attacking the bullshit stories, but you seem to have this in your back pocket, always wanting to substantiate these stories as if they're real. When it comes down to it, you admit that you're just believing that they're real. I think you want to have your cake and eat it too.
I mean, I have first-person observations of our spacecraft working in the way that they're described to work, and that tends to be the crux of my understanding. But that's
Sorry, Josh.
that's just me.
That's
But I'm not going to
untrue.
make that
That's
assertion
untrue, Josh.
and what?
That's not true. Come on, I brought this up yesterday in terms of what actual evidence there is of any of these craft, any of these probes going to any of these places, and there is none. Beyond
I
the odd
disagree with that.
CGI image or
I mean,
attempted
all their
video, there's
all of their
absolutely
trajectories are
nothing.
public. Like an exercise I did during grad school was I built an antenna to downlink imagery from NOAA satellites because they're not encrypted.
Yeah, there's no evidence for any of these fantastical claims about robots on Mars, robots going to the sun, robots going to a star. None of that is real. We all know that it's not real. And I mean, you sound like you're trying to be a nice guy, which is fine, but everyone in here already understands that none of that is real. So it's almost like you're just trying to convince yourself at this point. Because all of us understand that in order for any of those stories to be remotely true, it necessitates a physical geometry of the surface that we do not have, right? And it's like you know this as well, because whenever this subject is brought up, you avoid it, right? You cannot even discuss, let alone substantiate the base assumption of all of your stories, which is that the surface of the earth that we live on is curving commensurate to a 3959 radius ball. And if that is not happening, Josh, you would have to be honest with yourself and say, well, then, yeah, all the things I'm saying consequently cannot be true. And you're not even making an attempt to substantiate that. You're jumping right to the pinnacle of this house of cards, which has no foundation. Right? So, I mean, you're fine to be here and talk to us and stuff, but really, I mean, I can't I can't imagine that you don't understand what we're actually saying here, which is like, I know you say you're not trying to convince anyone, but it's like you're trying to convince yourself, because we all know that this fantasy globe in space story is just that, a fantasy. Now, I don't know what it is you're doing in your work or your day job, but you can't say, I've seen it. You've seen none of it. You've seen arguably data on a screen with no idea of where it's coming from. I mean, these people are on interview with people saying they don't have any kind of observation or physical knowledge of where these objects are, where they are purported to be. So none of this is real. None of this going to Mars or sending a robot into deep space. None of that is happening. And really, I would ask, before you go on talking about those things, you would have to make an attempt to substantiate that they are leaving a globe like you're claiming. Because so far, all the empirical data is telling us that that's not the case. We don't have any curvature, so we can't have little robots blasting off from a curved ball into space. That can't be the case. Right? So sorry to burst the bubble, And I'm not trying to say that your work has no value and that you're not setting up, I don't know, communications for people. That could still all be happening, not to take anything away from your work. But it's certainly not taking place on a 3959 mile radius ball hurtling through an infinite vacuum. If that were the case, we would have some evidence of that, when we don't. At best, what you tell us is, oh, you could apply to go to a radio telescope in Spain and maybe they'd let you hear the robots on Mars. Like, dude, come on. Are you serious? In 2025, this is what we have to resort to know that we live on a spinning ball? Just hearsay stories from unaccountable, unaudited organizations that say they're doing Star Wars sci-fi stuff when they can't even measure 8 inches per mile squared of surface curvature, but they can travel hundreds of thousands of miles with little robots and take samples and send them back to Earth. It's Star Wars on one hand and Dumb and Dumber on the other. Can't measure Earth curve, can't explore the galaxy. It's just contradictory nonsense because it's just propaganda. Not to say what you're doing necessarily is propaganda. Your work, I'm sure, has real world impact and benefit, but it's certainly not in the technical backdrop of what you're purporting it is, because the geometry that is required for that does not exist. And I would really like to hear you, after the amount of time that you've spent here, address that point. Because surely you would agree logically that if the geometry of the globe does not exist, then the globe does not exist. Therefore, all these stories ancillary to the globe, such as space exploration around the globe, consequently cannot exist. I'm sure logically you would agree with that. Therefore, the curvature being in contention is really the thing you should be addressing if you have an interest in purporting that this whole thing is true. Okay?
The last line there is important. I don't have an interest in purporting that's true.
Okay. Well, then I would recommend that you stop suggesting that it is true by talking about we have satellites going here and going there, because whenever you say that, you are implicitly, explicitly making the claim that it is all true, when we know that it's not, by direct measurement. So that's not to say you shouldn't hang around here and you shouldn't talk and ask questions, do all that stuff, but you can't on the one hand say, hey, we're going to space and we're doing all these things that NASA claim we're doing around a globe, and then at the same time say, I'm not arguing for a globe. Yes, you are. By pushing this propagandistic nonsense that flies in the face of observable, measurable reality as every human being on Earth knows it to be, you are implicitly, explicitly pushing this fantasy, whether you know it or not, whether you mean to or not.
Can I say something just for a second? I don't have a lot of time, but just for food for thought. So, orbital propagation models are built off of WGS84. So just like what AI Overlord was talking about with regards to the cosmic distance ladder that the astrophysicists didn't know about, WGS84 is built on the same or similar a chain of requirements. And if you walk the dog all the way back to its original premise, you're going to find the same thing that we're talking about today. And like SGP84 built off of WGS84. It's an arbitrary coordinate reference system, dude.
Yeah, I mean, I'm sure he's a nice guy or whatever, but I mean, the fact is, you can't push space stories and then say I'm not arguing for a globe. Yes, you are.
So I'd like, if you don't mind, Wolfgang, I'd like to hear Mr. Ingersoll reply to Yoder. So please, Mr. Ingersoll, do you have a Do you have commentary to share with Yoder there?
If he can't reply, he's taking care of kids. I mean, that's totally
Oh, okay. I
understandable.
may have missed that. No. I may have missed him saying that if he said he's taking care of kids. That's 100% understandable. That's not a.
So maybe we have some kind of genuine person here we could talk to. That'd be cool. Is there anybody else? Lewis is here. Methuselah. Anybody but Josh would be amazing. VLTK. Glad you have supporters, Josh. They love you. Entmonk. What'd you say, Neil? Kopsky's back. Love you.
I was kind of interested in the satellites there that Josh was talking about because I had put up my own there for Dish. You have your 110, 119, and 129. Those are those dishes that have the 3 eyeballs. And then I had a special one since I live close to Canada. I had 91 where I could grab the Sunday ticket. So I know about, and those dishes, they just point up a little bit like you're pointing to a tower down my street.
Yeah. The higher the latitude, the more horizontal they go. Typically, I mean, there are going to be some cases where there are going to be some orbital propagation that puts them at an inclination that sends them close to what's called a polar orbit. In which case you could aim them up higher. But most of these things are said to be orbiting above the equator. So it's going to be facing south from you, or north if you're in the south.
Yeah, sorry, Yoder, I was just going to add in, so the more north you are, the more your dish would look like it's pointing, like you say, to an antenna down the road, or the alternative, the further south of the equator you are, then the same phenomenon it would.
Yeah, so like Globies will show us like 2 pictures, one of images of people getting reception from Ecuador with their satellite TV pointed straight up, and then people in Canada pointed more horizontally for the same satellite TV. Ignoring the fact that, like, if you've been to a third world country in South America, people take these massive satellite dishes, like what's shown in these images, and they hang their clothes to dry on them. It has nothing to do with TV reception. At least for the meme.
I don't think I've seen that meme.
Okay.
But it is interesting here that obviously he's admitted to having some research grant that he's attempting to obtain to study us, and he goes to bat for us. So I sincerely appreciate his honesty, but I'm a little more curious as to.
Please, I'm sorry. Like going to bat, I mean, that is just so obviously a ploy. Please. Yeah. It's like, oh, yeah, those big bad Globers, they think you guys are dumb. This is the other side of the coin of Mansky from yesterday, Kopsky, who's like, did you guys know that other people think you're dumb? Do you not see that this is just a snake oil salesman version of that? I'm sorry. I'm sorry, I didn't mean to interrupt. Continue with your thought by all means.
Yeah, so anyway, it'll be interesting to see he's already mentioned a former executive of Google, and it'd be interesting to see a little more of this. Who, what, when, where, how, and why. That, because it is interesting here that I do detect in him what what I detect from people who are doing research that is not here to actually learn and discuss the topic, that he's definitely here with an intention on a purpose. And so, frankly, all of our breath on talking to him about the subject is wasted. He's not here to actually talk about the topic. He's here for whatever that research is. And
that's my feeling as well.
When you're surrounded by all the belief, okay? When you're surrounded in this industry by the power and technology of belief, this topic is absolutely 100% interesting, a curiosity. Like, it is such a bizarre canard that it is absolutely interesting to somebody like this. I totally get the mindset because I was there.
Yeah, but his line of questioning leads me to think that he's making some kind of research, which is, I think, this is what Mr. Barrington was talking to. That's how I feel.
Yeah, he admitted
maybe for marketing.
Yeah, he said that in 2027 he's doing an IRC, whatever exactly that means for a conference. So he's admitted to it. He's told us a timeline. He's told us that some of the grant money might be coming from a former executive of Google. So he's been transparent. So I'm going to give him A+ for transparency. So
I smell cat. Right. So it's an evaluation of our thought processes. But what he seemed to when he was asked what is our position, basically, that was the first question asked of him. He said, "Oh, it's because you don't see the curvature, it's flat." But it's a bit more than that because we actually measure. It's actually being measured whether or not it's flat or not. It's not just we look and we don't see it. He was a bit basic on that. He didn't seem to speak enough to that we actually painstakingly taking the time out to go and check and measure over a given distance. So it's not something that you just look at with your eyes and then you don't see curvature, that's it. Because it can be deceiving. So you make sure. That's all. So
yeah, every time he describes it, he forces himself to be dismissive to frame it in that way. Yeah, he says
putting psychological distance between the thing that's causing psychological harm in you. It's a total ego protection.
Yeah. And he was pulled up on that by saying, "You all," yo, that was a perfect timing to pick him up on that because he's excluding himself from the experience that we all have and we all know. So well done anyway. I thought it was good. He deserved. We treated him amicably, and that was that. I don't think we were harsh on him.
Yeah, I don't think he's nefarious at all.
We just
curious.
Dealt with him. Yeah, we just dealt with him fairly. The logic was pressed to him. If you haven't got the radius of the Earth, and that would be a Wolfgang cyclone, if you don't have that dialed in, you can't claim the Earth to be a globe. Therefore, whatever you're making isn't going to where you think it is. You might be making it, but it's not going there. So you can't claim we have satellites in space. If you do that, then you're doing that disingenuously because you know that you don't know that they're up there. You're guessing or just what's the word I'm looking for? Guessing and believing. That's it.
Yeah. Well, he believes he knows and thinks he knows.
Yeah.
That doesn't mean he
No,
has.
but this is the problem, though, because
not at all. No way.
Well, but to be fair, though, and this is why I would step in, is because it is disingenuous. Because on the one hand, saying he's not trying to prove a globe, but on the other hand, all the stories he's telling are exactly told to persuade of that notion. And he's not actually saying, this is what I think I know. When pushed, he is actually saying, I know this. And we had this conversation yesterday when India was asking him about the nature of the sun. And we said the same thing to him. Well, I said exactly that to him. I said, would it be more fair to characterize what you're saying as you believe you know, or you think you know what these things are, but you wouldn't actually say you definitively know? He was like, doubled down. He's like, nah, I know. So
yeah, that was the end of it for me. Yeah. Oh, I'm sorry, Wolfgang. I was just gonna continue on with your thought. I just wanted to give you amazing Kudos for both yesterday and today, your incredible patience, adherence to the topic, and so on. Indio replayed, or he posted that audio last night and replayed some of the audio from that, because for me that was like the end, like, for me, because the way he treated both you and Indio was so incredibly rude, while also saying, I'm not here to argue. I 100% applaud you for calling him out on that disingenuous, use snake oil salesman nonsense. I get it. A bunch of people here want to be your buddy, Josh. You got so many buddies. You can DM all of them. They love you. You love us and they love you. I'm not one of them, as we know. So thanks, Cyclone. Love it.
No, you're very welcome.
I
No,
can relate
thank you.
with him personally,
And,
so
and yeah, I'm sure, but I'm sure this is discombobulating. I'm sure it's discombobulating for him because a person like him, I'm sure, goes into these spaces and has a raptured audience waiting to hear about the space stories and what robots have been sent to what light in the sky and what they know, as if he's some shamanistic priest come down from on high to the Amazonian tribes to regale them with infinite wisdom. When it's the total opposite here. Not only are people not enthralled or raptured, we're calling it out as bullshit because we know that's what it is. At least in the setting that he is trying to insinuate all this is taking place, without actually arguing that that's what he's arguing. So it's a kind of underhand way of convincing an audience of the globe without actually having to confront the fundamental arguments that we're having here, which is about the geometry of the globe, just bypassing all of that and going straight to the space stories. So I'm sure, I know some people have time for that, but personally I don't. It's like, well, we could sit here till the cows come home talking about the Dungeons and Dragons rule of space exploration and satellite fantasies. But if we've got none of the geometry that requires, then it's not an argument. How are we going to waste our time? So that's what annoys me a bit. It's that he's not just harmlessly like regaling space stories. There's an intention to promote the globe space fantasy without actually
that's his
having
job.
to have it scrutinized. Well,
Yeah, that's his
that
job.
might be his
He's
job.
an
Maybe that's his
evangelist
job,
for
but
his product.
here it's not his job. Here his job is to provide some evidence for his claims, and if he can't, well then don't make the claim.
Good point. So maybe the point of our discussion should focus on the epistemics of this and the philosophy of mathematics behind what he understands from a more technical standpoint.
Well, to me, it's not getting into the mathematics or the philosophy of what he's saying. It's prove the geometry of the Earth that you claim this is taking place on and is
that's
essential for the story. Because if that's not the case, if that geometry isn't there, then none of these stories hold up. I mean, that's not to say that there's not some alternative possibilities in terms of high altitude technologies. That's not to say that. But that's not where he's coming at it from. He's coming at it from globe in space. And that's what I have a problem with low key pushing, but being entirely unable to actually defend or evidence.
Good point. Yep, you're right. Yeah.
Hello.
How's it going?
Yeah, going alright. What were you talking about here?
We are talking about the nature of the Earth.
Nature of the Earth. I'm not really familiar with that.
Well, you know how they tell people that the Earth is a globe?
Yeah.
We're asking if there's any proof for that.
Oh, really?
Yeah. Because
yeah. I thought there were a lot of evidence.
What was that?
I thought there was a lot of evidence.
Yeah, a lot of people thought there was a lot of evidence, but then when you actually look, there's no evidence. There's only claims. and images and videos that you can't verify. You see?
Then
Like
is
if I
there
were
like
to
more
ask
evidence
you,
for flat?
oh yeah, there's way more evidence for a flat Earth. Like, for
Yeah, I'm
instance,
interested.
you understand that you experience the Earth to be flat and motionless directly from your perspective.
Yeah.
You know, you've heard them say it's too big to see the curve.
Mm-hmm.
Yeah, so this is then what they're actually telling you is you experience a flat Earth. You ever thought about that?
Mm.
So they tell you, oh, it's just because it's such a big ball. But what evidence do you have for that other than, well, they've shown you some images which you can't reproduce or duplicate? You know?
Mm-hmm. Yeah. So what evidence do you have then?
Well, observable, measurable, practically used reality. So it observes flat and motionless. It measures flat and motionless. The surface, that is, like the ground, the bodies of water, yeah, like lakes, things like that. Measure flat, not curved.
Mm. Then how do you prove the Earth is flat? Like by measuring?
But you can do things like, well, basically, you're wanting to test your line of sight. You know what line of sight is?
I'm not sure. Yeah, no.
Like how far you can see. Like if you were to draw a straight line from your eyeballs forward, right, horizontally, like how far you can see across the surface. Because if you're on a curved surface like a ball, it's going to limit the amount you can see of that surface, yeah, because it's going to curve down and away from you. So we can test the globe model just by using the numbers that they give us. So do you know how big they say the Earth is? The globe?
I'm not sure.
So they say it's got a 3,959 mile radius.
Uh-huh.
Right? So this tells us the size of the ball that we're supposedly living on. So we can use this to work out how much curvature drop over a distance there should be. So let's take an example. So let's say we've got a 10-mile stretch. Let's say we're at a lake that's 10 miles wide. You ever been to a big lake? You know what a lake is? Yeah.
Yeah.
You ever been to a big one?
No, I don't think so.
Okay. Well, the one that you did go to, did it look flat or curved?
It looked flat.
It looks flat, right? That's right. The lake does look flat. All bodies of water to us appear to be flat when at rest. But they're telling us that it's actually curved, right?
Yeah.
So do you know, over that 10 miles, how much curvature do they claim there should be?
I don't know.
Have a guess. Don't worry, I don't expect you to know.
I'm not sure. I have no idea.
Well, what do you think? Like a centimeter, 10 centimeters, a meter, 5 meters, 10 meters, ballpark it. Just an average, just a guess.
10
miles. So how much drop over a distance? If you were to draw a horizontal line from your feet, where over 10 miles, how far away would it have curved from that horizontal line down and away?
10 miles?
Over 10 miles, yep.
Okay.
What do you think? 10 centimeters, 50 centimeters, a meter, 10 meters, more or less?
I'm not sure. 10 meters.
10 meters. Okay. Yeah, that's not bad. That's not bad. Usually people say like, oh, a nanometer, less than a centimeter. They think there's no curve at all. But the globe prediction would actually say that there's over 66 feet. Right? So that's like 20 meters. of curvature over that distance. But the thing is, when people try and measure this, and they go to a lake that's, say, 10 miles wide, there is no 66 feet of curvature. Right? You can just see all the way to the other side. You can shoot lasers to the other side, and there's no drop over distance to align with the globe. Whereas if we were on a globe, we would need that curvature. That curvature would have to exist, but it doesn't. Understand? So the lakes are flat. So that water is flat, basically. That's the natural physics of water, yeah? Takes the shape of its container, and the surface will find its level when it rests. Like a cup of water, a bathtub, a swimming pool, a pond, a lake, an ocean, finds its level. You see? So
Well, isn't that because of gravity?
Well, no, gravity, according to the globe, would make it curved, but it's not curved, it's flat.
Yeah, but it's kind of the gravity. As far as I know, gravity pulls everything, even the space.
Yeah, no, that's just a story that we've been told. That's not true.
Really?
Yeah.
Yeah.
That's why the lakes measure flat, because if the story was true, the lakes would measure curved. The water would be curving, but it's not.
Yeah.
The water's flat. You understand?
But like measuring distance, doesn't really debunk the theory of the, usually ordinary people say.
Well, it does if over that distance there's supposed to be curvature, but there's none. So a ball has to have a curved surface, yeah? It does not. And
But you just measuring. Are you saying the measuring the distance from the other side?
Yeah, from one side of the lake to the other. Yeah. So there's supposed to be a hill of water between you and the other side of that lake. You shouldn't be able to see. So if I was standing on one side of the lake and you were standing at the other side of the lake, we shouldn't be able to see each other because of the curve, right? You're supposed to be hidden by the curve, by like 60 feet of curved water. But when people take a pair of binoculars or a telescope or whatever down to the lake, they do see the other side. They do see their friend at the other side, and he's not hidden by curvature. Which tells us that there is no curvature. So basically, we're seeing too far for the surface to be a curved ball. We're seeing too far. We're shooting lasers too far. There's no curve. So if there's no curve, it can't possibly be a ball, like they're claiming. You see? But it's also, it's not a disc in space, right? The flat Earth is not in space, floating around.
Oh, where is it?
Well, you can't really define the Earth as being embedded in a larger space. For all intents and purposes, as far as we can tell, the Earth is the place. It's the whole place. You could think of it as the floor of the universe, right? The Earth is the floor, and above is the sky with the sun, moon, and stars. That's above. Not all around, doesn't go below your feet, above.
But then what happens if we dig a really deep hole under the ground?
Yeah, the deepest hole they've dug is less than 8 miles. Right?
Yeah, but they I forgot the name, but they did some scientific method to find out what material inside the ground.
Yeah. So when they did this, when they dug this hole, this 8-mile hole, they made predictions about what they would find at certain depths. Right. So at 1 mile we expect to find this type of rock. At 2 miles we expect to find water like this. They were wrong all the way down. Right. So they couldn't predict what was 8 miles below the Earth's surface, but we're supposed to believe that they know what is 4,000 miles down below the Earth's surface, that being the core of a ball Earth. Right? They've got no idea. So less than 8 miles, if you had that on the globe, that would be like you're barely breaking the skin of the apple. And they're going to tell you what's at the core. No, they've got no idea. This is just propaganda. So
then how do you explain the gravity?
Explain what?
Gravity.
What do you think? Well, what do you mean by gravity?
Gravity, if we can drop things on the ground, that means like something constantly put things at, like.
Yeah, we can have things falling to a flat ground. Like things falling doesn't necessitate the ground being curved or a ball. You know, why would that be the case? So what they've done is they've taken the phenomena of objects falling to the ground, and they've told us that it means we're on a giant spinning ball and we're being pulled to the center of it effectively. But that's not really the case. Things are just rising or falling based on their density relative to the medium. If you look up specific gravity, that basically describes what it is. But there's no globe involved, you see? Just a flat, motionless Earth, like you always experience.
Then what about rotation of Earth?
I was going to ask you, so do you think the ground is rotating?
Oh, yes, I think so.
Do you experience the ground to be rotating?
No, I don't.
No, you don't. So why do you think it is?
I mean, that's how it is. It's like, that's why we have day and night.
You just not how it is. Because how it is, according to our perspective, not rotating. It's not moving. Unless you're in an earthquake, then you'll feel the ground moving. So what makes you think the ground is moving? I think I heard you just say it.
When we see our sky or the stars.
Okay. So we see the sun and moon and stars rotating. But why does that mean that the ground is rotating? Why couldn't it just mean that those things are rotating? You thought about
that? But I knew the reason that they have to be rotating, otherwise it doesn't make sense.
Well, what has to be rotating?
Like the sun and stars, like
yeah. You see the sun moving, the sun rotating around or moving around you, so you don't necessarily see it rotating. You see it move through the sky east to west, yeah? And they've told you that even though that's what you observe, that's only because the ground is rotating. But what proof did they show you that it was actually the ground rotating and not just the sun moving like you observed?
Because by watching the orbit of the stars, like suns and moon.
Well, again, you're just seeing them move, though. What proof is there that it's the ground moving and not just those things you're seeing moving?
Because
if you just see the sun move, you just see the sun move. You can say, okay, I see the sun move, so I'm gonna assume that the sun is moving. But if you're going to say, no, I'm going to assume that it's the ground that's moving, then you need to provide evidence for that, or someone needs to give you evidence for that, no?
Yeah.
So what evidence did they give you that it's actually the ground spinning and not the sun moving like you observed? Did they give you any evidence?
I mean, they did. I just can't really remember on the spot.
What kind of evidence do you think they gave you? Measurements? Or stories? Claims? Assumptions? What do you think? Because as far as I can tell, it's all just claims and assumptions. There's no evidence. There's no measurements. There's no science. It's just assumptions. They assume that the ground is moving, and that's what's causing the sun to appear to move. But no one's actually measured the ground to be spinning. Have they?
Mm.
Who do you think's measured that?
Oh.
Anyone?
Why do you think people lie about the?
Ooh, why have they lied to us?
Yeah.
Well, it's not even necessarily the case. I mean, it's a big question because, I mean, most people that you're thinking about, right, like a teacher who teaches you that the Earth is a globe, they didn't lie to you.
Mm-hmm.
They believe it's a globe. And why do they believe it was a globe? Because that's what they were taught. And who taught them that the Earth was a globe? Their teacher. And how did they know it was a globe? Well, they didn't know it was a globe. They were just taught it as well. So it's almost like a tradition, like Santa Claus or something, right? It's passed down and taught, but they didn't see it themselves. They never proved it. They're all just assuming that these organizations like NASA or the Russian government are telling the truth about what they're doing. It is all based on that assumption. So it's not actually like loads of people are lying. Most people just believe it and teach it and, you know, claim it to be true based on their belief. Really, it's a small group of people who would have to actually be lying about it, meaning they know it's not true and they're saying it is the case anyway. So, but your question about why would they lie, those people who maybe have lied about it, well, I mean, I could come up with a whole host of possible reasons, right? Do some people lie for money? Yeah, because NASA, they make about $70 million a day peddling this story. So would some people lie for even a slice of 70 million a day? Possibly. Yeah. Control of the world view, you know, if they have the power to say there's an asteroid coming and it's going to wipe us all out in a year's time, so you all have to come and work for us, give us your tax dollars, whatever it is, right? They could convince the whole nation to do whatever they tell it to do based on fear, basically, right? They control the environment that you think you're in. Yeah? They're the ones with access to space where Earth is. So if they say, hey, this giant rock is coming to wipe us out in 3 years' time, people will believe them. That's a lot of power. You can get people to do a lot of things through fear, right? It's very powerful for controlling society. You could also argue that they are obscuring the nature of our environment, right? Because they've given us a cosmology that says that the Earth essentially appeared by accident, randomly, right? There was a big bang, a random explosion of nothingness, and then everything just appeared. That's all based on a globe story, right? So when you figure out that that's not the case, then it goes all the way back to the creation story.
Then do you have like completely different story of universe? Like you said,
Yeah, well, it
there's
has
no
to.
such thing.
It shows that it has to have been intelligently designed. The
Intelligently
environment,
designed.
intelligently designed. Yes, a creator.
Okay,
Yeah.
but that intelligent creator might have made the globe and
I'm sure he could have done, but he didn't because we measure it and it measures flat.
okay.
So he
Then
didn't do
why do you
that.
think why do you think the cause was the intelligent creator?
Well, because the only option we had for no intelligent creator was a Big Bang globe cosmology. Right? But that we don't have that. We don't have a globe. We don't have a Big Bang. So there's not really a creation. There's not an accidental natural creation story for a motionless topographical plane. Also, it's a contained system, so something had to have made the container.
But then who made the intelligent creator?
Well, now you're getting into philosophy and religion. It's not what I'm dealing with.
Is it like not your topic?
It's an infinite regression fallacy. Who created the creator? Who created the creator's creator? Who created the creator's creator? Creator's creator? And on and on and on we go.
Yeah, it just doesn't go anywhere. And it would just be speculation.
Yeah, I mean, how do you explain then? If someone asks you like just where the creator is from.
I don't make a claim as to I don't impose my thoughts on the nature of the creator to other people. That's your journey, right? That's up for you.
Yeah. Just I wonder what you are thinking about it.
Well, my view would align generally with what it seems the vast majority of human beings throughout history have held, that there's an intelligent designer that they call God, and he created this environment, this system called the Earth. And the sun, moon, and stars are essentially just like a giant clock above it.
But you also think, so it's like how you think.
Yeah. That's what I think is a logical conclusion to arrive at once you have reviewed the evidence.
Okay. Yeah, I feel like I gotta study a little bit just tease to understand what you say and
yeah, you should check out our home server. We've got a lot of resources that you can study.
Yeah, do you have a link or something?
Let me check if the bot is in with the right link.
You can just click on my profile, and there's a link in my profile. Broken Eraser. That's my name.
Yeah, right. How to? Sorry, I'm new to this application.
Just click my name, Broken Eraser, and then you'll see discord.gg/flatearth, and then just click that, and it will take you there.
Maybe it's different. I'm using I'm using my phone.
Okay.
Yeah, if you just click on my name, hold your finger down, and it should come up with like my profile.
Oh yeah. With my finger, yeah. And
then you should see a link, like a link to the home server. Discord.gg.
Discord. Yeah.
Yeah, so let me direct you to the information just so you know where to look. So you join that server, yeah?
Yeah.
Now you scroll down the channels about 3/4 of the way, and you'll see there's a lot of channels of different topics like astronauts, NASA, curvature, gravity. Do you see all those? It's alphabetical. Do you see those channels? Called additional information.
Yeah.
Okay, so now when you want to research, you might say, what about satellites? So you scroll down to S, and you see a channel on satellites. Yeah? And now we save information here that you won't be able to easily find just using Google and YouTube, because they censor the topic. They hide it. So you can research our side of the argument here. Because you need to research both sides of the argument.
Yeah, I will study those. But yeah, it is like still hard for me just to believe all the ideas of yours.
That's okay. We don't want you to just believe. We want you to figure out.
Yeah.
Right?
So I might be back with additional knowledge, like not just say, "Oh, I heard that."
You can also listen on YouTube. We are live on YouTube 24/7. You can just type in 247 Flat Earth Discord on YouTube, and you'll find our streams. And if you listen to those conversations, you will learn a lot more about the topic.
That's pretty passionate. 24/7.
24/7, 365 days a year. We're even out on Christmas. We don't even take a break for Santa. Okay.
Yeah, 366 years on a leap year.
Yeah.
And then we also make culture and other stuff. We're also making music. We have a Flat Earth radio station on our home server.
Yeah, so take your time, explore all the resources, do some research, think up some questions, and then you can come back and speak to us.
Yeah,
You're
right.
welcome.
Yeah, thank you. It was really interesting.
Yeah, you're welcome to come and talk to us anytime, my friend.
Yeah, okay. Thank you. See you.
Peace.
It does exactly what you see it do, year in, year out. Right? It moves east to west in cycles over your head, resets back into the same cycles, year after year after year, for all verifiable history. What exactly is it? Nobody can test that. How far away is it? Nobody can test that. What medium is it in? Nobody can test that either. What can we test? We can test the surface of water, which makes up most of the known land area of the surface on the Earth. Okay, and we can test that for curvature, which would have to be there if the Earth's a globe. And we can calculate exactly how much. Make sense?
Okay.
Yeah, like if you have 20 miles of water, there has to be approximately 290 foot of curvature. If the Earth's a globe, that would mean that there would be like byproducts of that curvature, such as things being obstructed in the distance and a geometric horizon, which would be the horizon at a certain distance based on the height of the observer. And when we go out and test for those things, there's no curvature. And then when we dig deeper, we can't find any evidence of any curvature being measured throughout all of history. Obviously, there's a lot more to it, but we're not claiming to know the shape of the Earth. All right, flat's the description of the surface. Yeah. Like we're not claiming like a flat planet or anything like that. A lot of people, they try to insert the flat Earth, right? They just try to replace the globe with like a flat planet. We're definitely not claiming that. That would be silly if we were claiming
what are
that.
you claiming?
We're claiming that the surface area of the Earth, when tested, has no curvature, right? Other than obviously then topography like hills and valleys and mountains and things like that. But most of the surface is water, which doesn't have any drop over distance or any curvature over distance.
I mean, from what I can tell, this channel's called 24/7 Flat Earth.
Yeah, flat's not a shape.
I mean,
flat's the description of a surface, right? So you could, like a bumpy, smooth, flat, surface. It's not a shape.
Yeah.
There's no like flat Earth, right? You're still thinking Earth as an object. We're not claiming to know the shape of the Earth.
Yeah, okay. But flat's not a shape, but you guys are claiming that the Earth is flat.
Right. So the surface area tests flat, is observed as flat, and is utilized as flat.
Okay.
Yeah, like we all experience the Earth as flat. I'm not saying just because we experience it as that, that's the proof. I'm saying that's like
I could give you one way you could test for curvature.
Okay, go ahead.
Which people have done. And it's there, funny enough, because the Earth is not flat. You could find a lake that's at least maybe a quarter mile across, and put a laser pointer on one edge and keep it even to the ground. And then you can put something at the same height on the other side. If the Earth is flat, it should hit the dead center at the same height above the ground. But it doesn't. It will be above the center, proving curvature or refraction.
So it actually
bends light down, not up. So
no. Refraction can deviate light up or down depending on the temperature gradient, on the vertical temperature gradient.
And what would the temperature gradient have to be then?
The temperature gradient will cause the optical density of the air to change, right? So cooler air is more dense, more optically dense than warmer air, and light will deviate towards the denser medium. Okay, so it can, if you have like cooler air down lower or warmer air down lower, it will bend up or down, right? Depending on which direction the cooler medium is in, right? That's why we have sinking or looming, right? The opposite effects of each other. And we've done these laser tests that you're talking about, right? We've done them over huge lakes, right? Like 40-kilometer laser tests using the best possible lasers we could get our hands on, right? Like teams of field engineers going out with a $30,000 laser doing a whole series of different tests. Over huge distances and measuring zero curvature in these tests, right? These have been done over and over and over again, all over the world, different people, different types of lasers. We've had PhDs like Dr. John D going out with different spectrums of light, using different spectrums of lasers. And zero curvature is detected in any of the tests. I don't know if you want to see some examples.
Well, from what I've seen a group of flat earthers like yourselves performing an experiment where something similar to what I described to you. You've probably seen it before. It's quite a popular clip of the guy raising the light above his head, and then which you're then able to see it through the little holes in like the wooden boards that they made. Proving that he is on a curved surface. Surface. I mean, you've seen that clip before, not even.
I've seen that clip. I've seen that clip. It's ridiculous, right? It doesn't show the setup, right? It shows some close-ups of absolute moron named Jaren cutting some holes out, right? We're not checking if the holes are aligned properly. He broke the laser, right? It was supposed to be done with a laser, right? But Jaren broke the laser before the test, right? He left it on and melted the collimator to the laser or something like that, which he talks about in the hit piece, right? In the film. Okay, so then they decide, because they've got it all set up, they decide to do it with a flashlight. Okay, now apparently everyone walked away from that saying, well, that was a big fail, right? That didn't really prove anything. And then they ended up editing it in a way that made it look like he debunked the flat earth. And then there was a lawsuit after because the flat earthers were trying to get their hands on the original footage, which they were promised, and then they wouldn't hand it out because they would have been able to show, look, they were lying. But even like anti-flat earthers that hate flat earth, that literally make a living debunking flat earth, right? Even they admit that was like a misrepresentation, right? And it wasn't a laser test. Like I'm talking about teams of field engineers going out with a $30,000 laser, right? Documenting everything from start to finish, right? Showing the whole thing in an hour-long video, and then providing a 280-page PDF doc or 180-page PDF document to go along with it. Right, it's very different than some close-up shots of a dopey-looking guy's face cutting out some holes in some foam or whatever, right? Like, it doesn't really compare. And it wasn't a laser test either.
That's fair enough. I didn't know the ins and outs of the test. I've just seen the viral clip, so I guess that was the context
No, I
behind
got you, man. Yeah,
That's
most
alright.
people like it's made in a way like to mock flat. That's like a mockumentary against flat Earth. And that guy Jaren, he's like, yeah, we don't really.
Yeah,
well, I won't say we, but I don't really like that guy. And
In
most
terms of
people I
like
know,
people in the flat Earth community,
Mhm.
because I've seen a lot of YouTube videos online of. I mean, I'm sure you guys have heard of Professor Dave.
Oh yeah, Strawman. Yep, Strawman Professor Dave. Not a professor, really, by the way.
Not a professor. It's just his YouTube name. I mean,
Yeah.
I like his videos a lot. I think they're really funny. What do you guys think of David Weiss? I mean, he's pretty prominent on that channel. I mean, Professor Dave's debated him quite a few times, and I always thought those debates were very interesting as he kind of got obliterated the entire time. But do you think
Well,
that
this
he's a
is the
valid flat
problem.
earther, or is he a dumbass?
Yeah, so David Weiss, right? He has a few good arguments when it comes to explaining the absolute basics to some people, but then he just butchers it with some really ridiculous arguments, right? Like he claims a flat Earth model. Okay, and his flat Earth model is the AE map projection, which is a globe
Projection, yeah.
Yeah, and then, he'll say that the stars and the sun and the moon, move a certain way above this AE map projection. So that's retarded, right? That's
It's ridiculous.
ridiculous.
Yeah. I mean, whenever he
And
actually talks to someone who's smart and scientifically gifted, he completely falls apart, and it's very obvious in those debates.
well, so does Professor Dave, unfortunately, right? Like when he debated Austin Whitsitt, people do reviews of these debates. There's a guy called Bruce McGuire, also known as Mindshock, right? He's not a flat earther. He just does unbiased reviews on debates, and he's like a professional when it comes to logic, right? To fallacies and things like that. And he'll go through the debate and he'll pause every time there's a fallacy, and he'll explain how it was a fallacy, which fallacy it was, and how it was illogical, blah blah blah. And he'll have a counter to how many fallacies each person made throughout the debate. Professor Dave actually holds the record for the most fallacies out of any debate that this guy has ever reviewed. And what Professor Dave does is he tricks people that don't really know the proper flat Earth arguments, and he'll pull out a bad flat Earth argument, which is fine to do, right? Because we would also disagree with that flat Earth argument, but he'll then say, "Oh, this is what flat Earthers claim," and then he'll debunk the poor argument, and he'll do it in like a very mocking way, right? Which might seem funny to some people that think flat Earth's a big joke, right? But it's very fallacious the way he does it. But there are a lot of bad flat Earth arguments getting around, just like there's a lot of globe Earthers that say the dumbest things you could ever possibly hear as well. But we're not going to take those and then make videos about it and say, well, this is what globe Earthers all say, right? And yeah. So
well,
he's
that's
very
pretty interesting. I
fallacious.
mean,
Yeah.
Could you drop me the link for that YouTube
Yeah,
video
man.
you were talking about of the
Yeah,
debate review? I'd actually
sure.
like to see that. No,
Mhm.
because I do enjoy his videos, and I think whenever you're talking about how he like kind of summarizes, really basic flat Earth points that kind of are outdated to you guys, I think there are a lot of people that still believe in that flat Earth model, with the ice wall and shit like that.
Mhm.
From what I know, like this little community here, this little flat Earth community in Discord, is kind of it seems to me like a bit of a minority in the flat Earth scene. Like from
Unfortunately,
what I've
yes.
encountered online, a lot of people are still believing that real archaic and
Yeah, like if you go on, if when I scroll through my Facebook feed, right, I'm not even a member of any of these flat Earth channels, but for some reason they all show up on my feed, and oh my god, it pisses me off. Like I'll be scrolling down, and the memes that they're posting and things like that, I'm like, oh, these are the worst arguments. That it's almost like it's like controlled opposition or something like that. These are fake flat earthers putting out the worst possible memes and arguments to just make flat earth seem ridiculous, and if it is actually flat earthers, then yeah, it's something that needs to be addressed. We're trying our best to try to put a stop to the bad arguments and things like that, but it takes time to iron all this stuff out.
Some of the memes and stuff could totally just be mockery. I mean, it's a very easy subject to be to make mockery of. And that's not me being sly, but it's obviously a very not even a controversial subject, but if you ever bring it up in a real life conversation, people will look at you funny. If you say that,
that's because of the propaganda behind.
But
the propaganda makes it look like a joke, right? If you type in flat Earth and you hit images on Google, you'll just see a bunch of ridiculous like floating discs in space with all water falling off the edges and things like that. We're not claiming that kind of thing at all. Now, most people mock it because they don't understand the arguments, and once they do, like if they're willing to actually sit down and listen and hear the arguments, like they're not mocking anymore. They're like, damn, it makes a lot of sense. I'm going to have to look into this a bit further, because we're not making any crazy claims at all. And we can back up all our claims with empirical evidence. Blue Jumper just put the video in the side chat, but
I'll watch that later.
Here's the actual channel of the guy who makes them, Bruce McGuire. Probably best to watch it on there. But if you want to watch a good debate, watch Professor Dave versus Austin Whitsitt. It's not the greatest one, but Whitsitt is 100 times better than David Weiss. Whitsitt's a super smart guy.
Is this the guy that was on the 24-hour sun expedition thing?
Yeah, that was him. Yep. Mm-hmm.
Didn't he convert to Globe?
No, absolutely not.
Am I correct on that? No. I know there was a few people on that expedition that converted to the Globe.
It was just 3 flat earthers that went. It was Austin Whitsitt and Jaren, right? Jaren's the same guy from the video that you were talking about, the Netflix video where he did the flashlight thing. That guy's a moron. We haven't liked most flat earthers that I know have been trying to, educate people on how ridiculous that guy is for years. Right? He never really made technical flat earth content. All he ever did was make like videos teasing NASA, like fakery and things like that. Right? Never really going over the technical flat earth arguments or anything
more
like that.
Conspiratorial shit.
Well, yes and no. He also believed in like the David Weiss style model with the ice wall and the AE map. And he believed that was the model of the flat Earth, right? Whereas any true flat earther will tell you that we don't have a model, right? We're not claiming to know the shape of the Earth, and we don't claim to have a full working scientific model of this complex system that we live in. It's not even possible. The globe doesn't even have what a lot of people expect flat earthers to pull out when they say, "Do you have a model?" Right? You can model little bits and pieces here and there. But there's no such thing as like a fully all incorporated globe model or flat Earth model or anything like that. And models need to be tested against reality as well. But yeah, Jaren had like his own like ridiculous little model. Like if you typed in flat Earth right now into GIFs, it'll come up with like, I'll try to type it in right now. Okay, flat Earth. All right, kind of like this thing. Right, that was like kind of like what Jaren. That's a simplified version, obviously, but that was what Jaren thought the flat Earth was. Right, obviously on this, you can't have a 24-hour sun in Antarctica. Okay, so because he was so dedicated to this layout and this silly argument that this was the model and this was the way the sun and the moon worked, then he went back to the globe. Apparently, I don't know. I think he was always whining about not having any money, and he saw the anti-flat earthers getting all of the millions of views and whatnot, right, on their videos, and I think he was maybe wanting to cash in on that. I'm just speculating, by the way. Maybe he was trying to cash in on that. Yeah. You know, look, he was charging, like, before this even happened, right? He was trying to charge people like $200 to have like an online dinner with him where he'll like teach you how to become a better man, and just cryptocurrency bullshit.
Like Sigma grind set.
Yeah.
Right.
So I don't. Yeah. So he went back to the globe, but
do you think?
Yeah.
On your flat Earth, would a 24-hour sun be possible?
But it has to be possible. Like so I would say that when it comes to the mechanics of the sky, it could be something more complex than we can even comprehend, right? Like what is the sun? What medium is it up there? How does it all work? It could be something more than we can comprehend. Like we can't test it. We can't test how it works. But whatever's happening in the sky, right, here's the basic logic. If you measure your floor flat, it doesn't matter what's happening on the ceiling. Right? Anything could be happening on the ceiling of your house, right? But if the floor measures flat, whatever's happening on the ceiling isn't going to change the fact that there's no curvature. You're not standing on a curved surface. That's the logic here. We can empirically test the Earth over and over again, anywhere on the Earth, and not find any curvature. And then once you start looking at how did the globe Earth become a thing in the first place, you're not going to find that people went out and started testing the Earth and doing measurements and things like that. That's not how the globe came to be a thing in the first place. Okay, so there's actually no empirical evidence that there is actually the Earth curvature that would have to exist for the Earth to be a globe. So whatever's happening in the sky is pretty cool, right? But we can't empirically validate exactly what's going on. We agree that there's two apparent points of rotation in the sky, right? This southern celestial point of rotation and the northern celestial point of rotation. But exactly how all of that works, how does the mechanism works? There's flat earthers that make models. Okay, so there's people that have models of it that can show how a 24-hour sun can work over a flat surface. But I'm sure those models have a bunch of issues as well, right? So we don't subscribe to a model that hasn't perfectly been validated and isn't empirical, right? It isn't able to be tested perfectly against reality and probably has a bunch of holes. Okay, so we got the globe model, if you want to call it that, or the globe, the way that they say that the globe works. Let's call it that. Or it's not a scientific model, but whatever. Let's just call it a model for now anyway. So in the globe model, we've got a bunch of flaws, right? It's a flawed model when it comes to the basic essentials that you need to have the globe, right? Like the curvature, the motion, the gas pressure argument, that kind of thing. And you've got some flat earthers that have some shitty models, right? Where they're like, oh, the 24-hour sun works in this model. But then they probably have a whole bunch of issues with them as well. So you've got a bunch of shitty, flawed models where people are trying to model something that you can't really model empirically because a whole bunch of assumptions and guesswork is going to be involved. So we here at 24/7 try to stick with empirical evidence and go from there.
Look, I get that. I do. But the issue I have with this entire thing about having no model is it just seems to me that because nothing actually works, you know, you could have, again, you said it yourself, you could have a flat earth model that someone creates that makes it so that the 24-hour sun is possible, but then this thing happening over on the other side of the earth, you know, to do with the constellations or whatever is not possible. So like basically,
so they can model it so
Earth,
all of the constellations and everything work just fine when it comes to the
totally,
sky.
but like none of the flat Earth models that have been made have worked with absolutely everything that we need it to work with. You know
so
what I mean?
neither does the globe, right? Neither does the globe.
But I don't
That's the
understand
problem.
how the globe doesn't, because we can predict things using our model.
No, you're not. They're not predicting anything, right? So you can predict
Well,
anything that
we can
happens in the
predict the
sky
way
with a
it
flat
is.
Earth model. Hold on a second, right? So you can predict anything that happens in the sky using a flat map with a using the celestial sphere model above that, right? And a personal celestial dome of vision, right? Which is the way that everyone views the sky. This is the problem, though, right? The globe model, or the globe, claims a radius value, right? It claims that water is bending and curving, right? But there's no evidence of that whatsoever. In fact, the thousands and thousands of observations and tests that we've done confirm that there is no curvature, and there isn't a single one from the globe side that validates that such a thing exists. That's the biggest crux of the globe model. Okay, there's also no proof that the Earth is rotating around the sun. There's no proof of that. There's no proof that the Earth even moves at all. So if you want to claim a globe model that predicts it, it's not predicting anything in the sky, right? It's post-diction. Okay, it's everything cyclical. Everything happens over and over again in cycles. Okay, so the eclipses, right? That was from the Saros cycle, which was created by the flat earthers, right? Many thousands of years ago.
NASA doesn't use the Saros cycle anymore. They use
They do use it, right? They do use it. They've built upon it because we have more people on the Earth, and we have more specific information about exactly where the eclipse will be at certain parts of the Earth, right? Where they didn't have that a way to spread that information back then, right? So obviously, over time, over thousands of years, you're going to improve on the Saros cycle. Okay, but they still use the Saros cycle. NASA still uses it. They've just improved on it, right? Which is, of course, you're going to be able to do that when you get, all of this money to do that kind of thing. But when it comes to the sky, right, that's just based off the celestial sphere, right? The ancients are the ones that came up with this idea to begin with, right? And it wasn't until Pythagoras and then people after Pythagoras, in about around 500 to 400 BC, when they started through these were cult leaders, essentially, like Pythagoras, the cult of Pythagoras. Pythagoras was literally like a mystical leader, a crazy dude, right? And he thought that the universe was musical and planets had musical notes and all this crazy stuff, right? Could get into that, but essentially he said that the sphere is like a perfect shape, and because of the imaginary way, right, that they view the sky, they had the celestial sphere. Over time, they inverted the celestial sphere, and they said, "As above, so below," because the circles of the spheres are the most perfect shape. Because the heavens are perfect, therefore, the Earth must also be perfect, right? It has to be. And that's how they inverted the celestial sphere into the terrestrial sphere, which is the latitude-longitude system that we still use to this day, which is the WGS-84. No one went out and actually measured, and they're like, "Oh, guys, we've gone out and checked. We've done some tests and measurements, and here's our results. And it's actually a globe. For thousands of years, we were wrong. It's actually a globe. Here, you can go test it yourself." No, they didn't do that, right? It was through philosophical reasoning and that kind of thing. It wasn't anything to do with because they actually empirically validated the Earth was a globe. Right, and that's how the globe still exists to this day. It's a spherical coordinate system mistaken as a terra firma.
I mean, but why do you think NASA is perpetuating this lie? And I mean, they're spending trillions, possibly. I mean, God knows, an unfathomable, that's a difficult word to say, a lot of money on perpetuating this supposed lie. And they've been doing it for a very
but where's
long
that
time,
money? Okay, well, we can't prove why someone, everyone knows the government would lies. You could ask anyone, does the government lie? Or obviously, everyone's going to say yes, or most people. Okay,
but now we have
they're not using their own money to begin with. They're using taxpayer money. And where exactly is that money going? Is all of the money going into whatever they do? What do they even do, right? They do some little childish science class experiments on the ISS, and things like that. Right? What are they really doing, right? When they got interviewed and asked why they don't go back to the moon, they said they destroyed that technology and it would be a painful process to build it back. So they're not really doing much, not doing a great deal. You know, even the things that people think they invented, like Velcro and air conditioning and things they didn't invent those things at all. That's ridiculous, myth. That's a myth that happened.
Yeah,
you can look up
I'll be back.
Velcro on Velcro.com right now and see who actually invented Velcro, not NASA.
Yeah, on that point, I'll just be back in 10 minutes or so. I gotta go real quick.
Yeah, no worries, man. Catch you soon.
Well, catch you later.
If the Earth is not round, if it's not a globe, can you explain to me how you believe Francis Drake, his circumnavigation of the globe? Can you explain to me how that was possible?
Yeah, he used a coordinate reference system, right? So he used celestial navigation. In fact, most maps today, if not all of them, are derived from the stars. The familiar latitude and longitude system that people think are wireframe meshes being stretched around a globe, that's actually derived from the stars. It's not on the globe, because if you're out at sea, you can find your latitude and longitude. The way you do it is with a sextant, with a clock, and with a good idea of where stars should be and what time of year and time of night it is.
Yeah, let's see anybody try and develop a latitude system without looking at the sky. I love when Indio says that. How do you know?
Absolutely right. You can't do it.
Yeah.
People noticed that the further they moved away from Polaris in one direction, the Polaris started to get lower in the sky. I'm like, pretty much everybody I know can see this in the sky from everywhere on the known Earth. How about we use angle measurements to Polaris? And that'll tell us basically how far we are. If I know that Polaris is 45 degrees north of the horizon, up from the horizon in the sky, and I'm looking at it, and if somebody else says that they're seeing Polaris at 45 degrees up from the horizon too, then guess what? We are at the same latitude. Amazing. And that would be 45 degrees north latitude. See how that works? So people constructed a sphere out of the sky. It's a choice, a perception, a way to try to order the celestials. And then from that choice, they construed this coordinate reference system that was spherical, latitude and longitude. Latitude comes from declination, and longitude comes from right ascension. So sailors are like, well, I'm using the spherical coordinate system, but Earth is flat. Crap, what do I do? And they realized hundreds and hundreds of years ago that there was what's called in mathematics a topology mismatch. If you try to project a spherical surface onto a 2D surface, you're going to have a bad time. You're going to get distortions. So they said, okay, we're going to just start treating Earth as a sphere too. And so you know what they did back in the 1500s? They took the known surveyed extent of the Earth, the land masses, and they wallpapered it into the celestial sphere. And they called it a globe. And instead of using it as a way of trying to get an idea of where things are in relation to how we perceive the stars, people started believing that we actually live on the outside surface of that. It became so popular, people today believe that concept, and it's a useful concept, right? It kind of works. people believe today that they live on a globe as a consequence of that. So what I want to know is if people believe that Earth is a globe based on the stars, then how come we can measure the Earth flat?
Yeah, exactly. So do you understand that now? That was a great question that was asked and a great answer.
Hi, Sporadic.
Hello.
Hi, my boyfriend's with me right now. He had a question for you, if that's all right.
Yeah, that's fine.
Do you think the government spread propaganda about the Earth being curved when it's not?
No, I don't. You know, you'll find a lot of flat earthers, a vast majority on social media, who I disagree with, believe that's the case, but I don't think that's the case at all. I think they buy into it too. And you know what? I think there are good reasons for people to accept it. Good reasons being that it seems to work. I don't know anything different. And you know, I've been basically subjected to this my entire life. Why should I upend my life? Why should I think anything different? I have no reason to, because it doesn't affect my life. And you know what? You might be right to say that. I think people working in government are taking data that they collect from scientific instrumentation and shoehorning it into a model. I mean, you could read about the process on like NASA's website. I was looking at some flow diagrams on NASA's website, where they take all this data that they gather from telescopes, from satellites, overhead platforms in general, they feed it into a processing center, and then they start applying globe coordinates to it. They take raw data that they obtain from using Euclidean geometry, that is to say, elevation angles, azimuth angles, which require flat horizontal and flat vertical reference planes. They take that, they start bending them to what they believe the Earth is based off of a 2,500-year-old concept of the stars, the celestial sphere.
I see. Thank you very much.
Right. I mean, that's really what's going on all the time. They take flat Earth angle measurements and they bend it to a ball because they believe Earth is a ball, so they believe that's what it should be.
So there's like some manipulation going on to kind of fit their hypothesis. Like
backfitting. Absolutely. And it's not, I don't think it's nefarious. I think people believe it so much that this is just the right thing to do. Totally. Right. So if you start to think about it, it's almost a scarier situation to think that it's not that there's like a dark conspiracy to hide the true nature of Earth. It's even worse if the entire world is delusional. And I truly believe that to be the case.
Yeah, I'm glad you just said that because it really bakes my potato or, pops my bicycle tire when people come in here and they say, well, I'm not that smart or, don't do that to yourself. The one thing you can't get in trouble for is stealing knowledge. So you can always learn what you don't know. Don't put yourself down. A lot of people that come in here trying to defend the globe or prove it or disprove the flat Earth knowledge and or topic say that about themselves. And it really bothers me when they do that.
Yeah. So, are there people at NASA and other places that know the Earth is flat? Yeah, I think so. I think it's true. And you know what? Could you imagine like working at NASA and let's say you're in Sporadic's world where everybody believes in the globe and you're like the one guy in your office who freaking figured it out. You're like, oh shit. All these people are like NASA globe heads and they love Star Trek. I see what's going on here. I see where everybody's backfitting data to fit an ideal. I see where everybody's confusing the map for the territory. The classic problem for the ages. I see how it's done. And nobody else seems to realize that's happening. Who else has figured it out? I don't know, maybe Bob over there in accounting? I don't know. So there are people like that at NASA, and there are probably also people super high up in compartmented parts of the government that know and just don't talk about it or make a big deal out of it. I mean, the globe is a great idea to have a public. Have you ever heard of something called the noble lie? The noble lie in history and philosophy is the idea that an emperor can unite people. They can dissolve differences amongst different people because, right, emperors are in charge of amalgamating people of different cultures that they conquer. How do you dissolve their differences and unite them? You create a common cause, like an American dream, or like maybe a heliocentric globe cosmology for the world to believe in.
Or like Anthony Fauci. Sorry to cut you off there. Don't forget Anthony Fauci with his noble lie. He stated that, didn't he?
Well, in this case, I think there could be people at the top, very few, very, very, very few, who know this, okay? But I don't know for sure. You know what's dumb? It's the fact that nobody can ever experience the globe. There's no proof that anyone ever has, and everybody believes it to be true. That's freaking crazy to me. But what's wrong with letting a little noble lie self-perpetuate? I don't have to do anything. I can just let it go, right? Just let it go. What harm is this? It's not going to cause any problem in anybody's lives. In fact, everybody's getting behind all these ideas. People from India, people from Japan, people from Australia, people from South America all believe that they live on the spinning space ball. You know, that's a good thing. It's uniting humanity together behind a common concept. What's wrong with that? Yeah, I think there's a lot of that going on at the upper echelons. So is it nefarious? I don't really think so. I really don't. And I think the number of people who know the truth of flat Earth who are in positions of power are probably very, very few. You know, and there are some people from NASA who became flat earthers and are quite public about it. I mean, David Beverly Jr. used to set up NASA satellite terminals, uplinks and downlinks, little tiny portable ones in Antarctica. Yeah, he was like former Marine Corps and then worked at this special unit at NASA that did this. I mean, you know, it wasn't nefarious at all. He believed in the globe back then.
Is Jay Tolan as well?
Yeah, Jay Tolan. Jay Tolan says, oh my gosh, he's an RF engineer, an expert in optics as well. He's got great videos. Yeah, he's a high-end military contractor. And I mean, he's got some excellent bona fides. He's worked on missile guidance systems, among other things. Long-range missile guidance systems, he says, right? He thinks the Earth is flat. He's got a whole channel devoted to flat Earth.
And you've got Jesus Freak, Computer Geek.
Yeah, that's who I was talking about, David Beverly.
Oh, right. Okay, that's his name. Okay. You got Math Powerland.
Yeah, an artist for NASA, right? I mean, so are you in the company of weirdos? Sure, but not all of us.
I'm not going to disclose who, but there is actually someone in our server too, from the home server.
Oh yeah, I know who you're talking about. Yep, there's a guy who has intimate knowledge of things. Yeah, he hasn't been around that much, but yeah, God bless him.
Yeah, true. I haven't seen him around for a while. Yeah,
JP. You know, and there are people in this very chat who've been around the block too. People who know about coordinate reference systems and why they work the way they do. You know, and none of that really matters at the end of the day because you can't hide a flat Earth.
That's true. Not when it's right out there, right outside, right in front of you.
I mean, it totally is a model. The globe, it's not a scientific model, but the globe is a model in a colloquial sense. And people think it's real. It is a self-contained coordinate reference system, and it does make some physical claims about the universe. You know, they're not, there's nothing rigorous about it. But when you understand a little bit about geometry, you understand that coordinate reference systems, as reference systems, are arbitrary. There are multiple globes out there. People don't realize this. And surveyors who believe in the globe are not thinking about this. When they sit down and they start surveying distances and plugging in coordinates, you know, they can go into settings and they can choose a different globe. They can choose the globe as people conceived of it in 1927, called the North American Data 27. They can choose WGS 84, the World Geodetic System of 1984. They can choose a Clark or Bessel ellipsoid from the 1800s if they wanted. They can also select a flat planar coordinate reference system from any of the states that they work in, because if they're in the United States, their respective state may actually require that they use a planar geometry and not a spherical one. And it's funny, there's academic papers revealing the heightened accuracy of using planar surveying methods, planar coordinates, to get your position fixes and distance calculations as opposed to a spherical one. You know, you get better accuracy.
Right. Yeah, it is like, and all these projections that they claim to use. So they'll like, oh, this projection doesn't work for this purpose. Oh, let's try this one. Oh, this works better. And it's like, why should they? If they're all the same, if the projections are the same thing, why wouldn't they just work? Like, why not just why use the projection? Just use the thing you projected it from.
Yeah. Yeah. I mean, there's an ignorance and a hubris at the same time, right? With technology. People who think the globe is real think that we have it all figured out, right? And so they'll think, okay, yeah, I mean, why can't surveyors use a common universal standard that's been proven to be true? That these coordinates are absolutely true. Well, I mean, different countries have different datums. Like, did you know that in China, this is interesting. I've documented this and I can bring the receipts. It's illegal for you in China to conduct surveying as a private citizen. It's illegal for you to basically measure your back fucking yard. And if you make off with your measurements of the earth and coordinates and leave the country without declaring it, you will go to jail. If they can find you and bring you to justice, you will go to jail. If you keep a logbook of your coordinates and measurements, you will go to jail. If you don't use the Chinese government coordinate system, you will go to jail. That's China, folks. Globe or die. So then people say, well, if Earth is flat, how come everybody's, doing the globe thing? Well, in some countries like China, if you don't do the globe thing, you go to jail. Meanwhile, over in Australia, isn't this true, T-Dub? There was some kind of regulation for surveying railroads that required using a flat horizontal plane for all of Australia.
It was for the Commonwealth in general, I think. So it was passed in British Parliament, and yeah, it was a law that they had to abide by, so that the horizontal reference datum had to remain constant throughout the entire project. Yep.
Yeah, no pear-shaped Earth, as Neil deGrasse Tyson would say. Can't use that. Isn't that interesting, right? So in the Anglo-American Commonwealth, you have to use planar surveys, but man, if you go to China, you got to use curving surveys.
Right. Now that means that if they've changed it since, that means that all the railways in Britain and all the Commonwealth countries that were built by that standard back in the day, they all slope uphill at one end.
Oh, funny. Yeah.
If we're on a globe.
You're right. You're right. They'd be climbing in one direction. That's funny. No, so our coordinate reference system's arbitrary. If I'm here talking about planar geometry and plane surveying being more accurate, well, here is the tiebreaker. The tiebreaker is if you believe Earth is a globe, but you are taking flat Earth angle measurements, and by that I mean Euclidean geometry. With your surveys, you're using angles, straight lines, not curved angles, straight line angles, right? Those have an easy way to map one-to-one in Cartesian space where you don't have a curving reference, a curving coordinate system. When you begin to curve it, you produce inaccuracies. And the literature in the field of surveying supports that planar surveying is more accurate than spherical ones. Now, this doesn't mean that they're all flat earthers. How they deal with this is they say, yeah, we know Earth is a globe, but it's so big and complicated, we haven't figured everything out yet. So they've got all kinds of corrections that people who don't look into this have no idea about. So corrections include local changes of the deflection of the vertical, curving plumb lines. Yeah, that's right. They believe that if you were to go like hang a plumb line from outer space down to Earth, that it curves somewhere in the middle. And they believe that it deflects, which means that the pendulum at the bottom doesn't point straight down to where you think the common center of Earth is. It's actually going to be moved off in that direction a little bit. So it could introduce complex curves, not simple curves. You know, curves with, you know, multiple asymptotes, right? So it's really funny. I mean, and nobody's actually seen this or measured it in real life. So if you start introducing curving plumb lines, you've got a curving radius. And if you've got a curving radius, you can take a flat Earth and curve it.
Sporadic. How do you summarize the difference between Euclidean and non-Euclidean geometry? And there is a point where they meet at the middle to give you some sort of realist level perspective.
Yeah.
From the
so picture this. All right. Let's use an example that Globers love to talk about: the ant on the basketball. This gets into manifold topology. All right, so we're dealing with the shape of surfaces. If you are an ant on a basketball, you might find that the surface is relatively flat in every direction you go. And what would give away the fact that the surface of this manifold is not a Euclidean? And by Euclidean, picture like a piece of paper, XY axis flat. What would give the ant the impression? Well, you know what? The ant might go in one direction and end up right back where he started. Let's say he could actually measure going straight. Straight as a freaking arrow. And he drops breadcrumbs along the way. And guess what? He ends up to his first breadcrumb, his second breadcrumb, third breadcrumb, fourth breadcrumb from going in a straight line. How the hell did that happen? He'll go in a different direction. He'll do the same. The ant will conclude, because he's smart as shit, that this is a flat manifold that has spherical geometry, what's called a two-sphere in geometry. The surface of a sphere is two-dimensional, and what makes it interesting, unlike a piece of paper, is it's got what's called a looping surface with periodicity. The loop, you already understand from the ants, the periodicity is defined by how far the ant has to go before it comes back to where he started again. Now, the ant could be clever and say, okay, well, this appears to be a spherical surface, but how do I know if it's a ball or not? Because the difference between a spherical surface and a ball is the third dimension, the existence of volume, space to fill inside the ball. Without that, it's just a two-dimensional surface. And the closest analogy I can describe for that is, imagine if you take a beach ball, deflate it so it's flat, squeeze all the air out of it, and then basically walk on it like a conveyor belt. Okay? You're going to be scrolling the surface of a flattened beach ball under your feet as you walk, like a conveyor belt or a treadmill. And every direction you go on this ball, you'll end up where you started again if you go in a straight line, but it's flat. So that's the idea of a two-sphere. So the ant will say, okay, maybe I'm on a two-sphere. How do I know if it's a three-dimensional sphere with volume? The ant's going to be like, crap, I'm going to have to go to outer space. Let me launch a rocket and let me see this shit. So funny thing is if the ant could go up into outer space in this magical world, you know what he might see? He might see one of two things. He might either see a ball that he had been walking on, the basketball, or he's going to see a repeating surface. He's going to see multiple instances of this, often on the horizon. Yeah, so which is it? So Euclidean space is going to be straight line XY axis on XYZ axis. You've got like a flat piece of paper is Euclidean. You can draw straight line geometry and you know these lines are straight. You know they're true. You know they're not secretly curving on a big surface that's secretly curving that you can't detect, right? Non-Euclidean space will curve somehow. And whether that's a sphere or whether that's like a saddle shape, like a Pringles potato chip, you know, I mean, it doesn't matter. Those are non-Euclidean spaces where there's an XY grid that you impose on it, but the reference grid itself is not straight and true. It's not orthogonal. It's going to have curves. So this kind of parlays into Einstein math and something called Minkowski space. So Einstein stole from Minkowski the idea that you could be in space and everything could appear to be Euclidean XYZ axis, just like an ant on a basketball. And in your normal everyday lives, you have no idea if you're actually in a curved space-time or not because you're in it, because the effects are too small, too unnoticed, and you will conclude that everything is flat. But in reality, everything is curved, right? The only way to prove that is to do actual measurements, to use Euclidean space itself in a non-Euclidean world and see if there's curvature. That's why we say, let's use laser tests. Let's use long distance observations because we know light propagates fairly straight, especially straight in infrared. You know, let's build things true and level to what we know the surface to be throughout all points of our construction. And let's detect curvature, and nobody can find a single thing. Curvature only appears in the math. It appears in the math of airplanes' inertial navigation systems when they use Euclidean geometry of azimuthal headings, flat Earth angle measurements, like on a piece of paper. And the computer systems curve that geometry into a globe Earth that's presented to the pilot on a digital screen. That's actually, yes, that does actually happen. I've looked into these systems. The Boeing 777 Dreamliner does this. It will take flat Earth angle measurements, feed them into the Air Data Inertial Reference Unit, which applies something called a transport rate, which is a fake rotation of the aircraft, as well as Schuller tuning and a fake Coriolis correction. And it will plot the airplane onto a globe for the user to see on a digital display. Now, which is real, the digital display or what the pilot's actually freaking doing? Okay? The pilot will look at the globe and will say, well, Earth is so big, I don't notice it, even though I'm doing this flat Earth thing. But the pilot is unaware of how the ADIRU, how the inertial navigation system is actually accepting these real world measurements and curving them. Okay? So we know in real life that we're using flat Earth angle measurements. And we know in real life that there are systems that are taking those measurements and adding mathematics to them to curve them into curving space, to non-Euclidean space, non-Cartesian space, and presenting that as a virtual reality, a matrix for people's minds to believe in. That is happening everywhere. It even happens at NASA. It happens at SpaceX, happens to astronauts. It's happening everywhere. And people believe in the globe so much that they are doing this thinking that they're supporting the truth. Like, you got NASA engineers launching high altitude freaking balloons, taking measurements, and then cramming that shit into a globe, even though they measured everything on a flat Earth. It's fucking unreal. Yes, this is actually happening. Yes, we can show that this is happening. We can show the thought process. That's how we know it's happening. We can show you their process that they're following to do this, that they seem to be ignorant of. We are taking their face and we're rubbing their face in the dog shit, and we're telling them, look what you did, and they don't fucking believe it. It's freaking asinine. All right? I got to install a new thermostat, so I'm going to step back for a minute. Thanks for letting me rant.
Thanks for that, Sporadic, bro. Thank you.
Yeah, some info, bro. Appreciate that. Rant anytime you like, please.
Yeah, please rant some more.
Yeah, it's therapeutic, mate. So well done. Excellent stuff.
Set me up with the show to YouTube and I'll rant.
Yeah, I do like the bit where the information coming into the plane is then being bent and then it comes up on your display as curvature when it's all happening on a horizontal, linear, straight line. Yeah, I knew that anyway.
Yeah, it's true. We got all the information on that. It's public. It's public, and people aren't trying to hide it, right? It's out in the public because everybody putting out in the public thinks Earth is a freaking globe. It's batshit crazy.
But I understand that your claim is that Earth is flat, but do you agree that the dome is like a circular, something like that?
Dome. Nobody's claiming a dome. The only thing that we
the way the sky looks.
The way the sky looks is based on visual optics. So there's a limit to how far you can see. So it's what you would call non-linear. So when you look into the sky, the sky wraps around your vision, the limit of your vision. So it's an optical phenomenon. The sky is an optical phenomenon. So regardless of how the sky looks or appears to you, there are still claims being made by whoever is backing the model that cannot be verified, right? We can't determine the shape of the ground by looking at the sky. Do you understand?
Can you repeat?
So the way we see is non-linear, right? So in the same way that things converge, like train tracks converge into a point in the distance, yeah, well, there's the same horizontally as well. So things will converge up and down into a point. So the sky wraps around you, right?
Oh, yeah. Yeah, I understand.
So the sky is no way to determine the geometry of the Earth.
No, I'm not saying the geometry of the Earth. I mean separately. You understand?
Well, I don't understand why you're asking about the sky when we're talking about the claims of the geometry of the Earth.
It's a concern.
It would be like me. It would be like me asking you to measure the floor, and you start measuring the ceiling, right?
I just asked. No, it's not like argument against the flat Earth. It's just a question.
No, I'm not saying it's an argument. I'm saying it's irrelevant.
Yeah. Yes,
I'm saying the way the sky wraps around you is a visual, optical effect.
Yes. I understand.
Right. Yeah. But what we're saying is the claims of the globe isn't about visual or optics, it's geometry. They're claiming there's curvature on the Earth. So if Earth is a ball and it's curving, then that curvature rate needs to be verifiable. Would you agree?
Can you repeat the question? Because I was like not focused.
If the Earth is curving, then there must be curvature. Do you agree?
Curving, you mean like? No, I don't think I agree. When you say curving, you mean like a ball? If the Earth looks like a ball, it must be a ball.
Is the surface of a ball, is it flat or is it curving? The surface of a ball,
right?
Right.
Curving,
so if we lived on a ball, the surface would have to be curving. Would you agree?
Yes.
Right. So if the surface is curving, it should be verifiable. Would you agree?
Yes.
Right. So if it's not verifiable at any scale, then it can't be curving, can it?
Well, if evidence does not exist, doesn't mean necessarily that it is not true. But if in the fullness there is no, like, even in morality or like, I mean, in the universe evidence, that means it's not curved. Do you understand what I try to say? Okay.
What I'm saying is, look, forget about the universe, forget about the claim of the model. We're just talking about the geometry of the Earth. If we lived on a ball, let's say a football, regardless of scale, there'd be a curvature rate, right?
Yes.
So you've already agreed to that. So now we don't have an infinite scale. We can't just hide behind, regardless of scale. Now we know that there is an actual size of the Earth. So the claim is that the Earth is a certain size. And if it's not that size, then the whole model falls apart. You can't have a working solar system the way it does with the orbits and everything, distances, without the Earth being this certain size. So we can put the claim to the test. There's a curvature rate. The Earth is supposed to be curving at 8 inches per mile squared. So we can't hide behind the fact that Earth is too big as an argument. There will be some test or some way to measure that 8 inches per mile squared if the Earth is really a ball.
I agree.
Right. 8 inches per mile squared translates to 66 feet of curvature over 10 miles. That's a lot of curve over 10 miles.
10 miles?
So if over 10 miles, there should be 66 feet of curvature if the rate of curvature is 8 inches per mile squared.
Yes.
66 feet of drop from sea level, if you've got, you're optically looking from sea level, 66 feet from that point, decreasing in elevation over distance. 66 feet. So every observation taken that's beyond 10 miles, where you can see an object in its entirety, is proof that there is no curvature rate of 8 inches per mile squared.
Can you tell me what you said it's proof one more time?
So if there's a curvature rate of 8 inches per mile squared, that means there's 66 feet of drop over 10 miles. So if we show you observations beyond 10 miles that debunks the 8 inch per mile squared, then that we have a problem.
That means it's bigger?
It means that there is no curvature rate of 8 inch per mile squared. And if there's no curvature rate of 8 inch per mile squared, then the globe model is wrong. The globe model won't work.
But can it be like 9 inches and the mistake was of a human and still a curvature?
Well, the whole model is based on the size of the Earth. You need a radius, 3959. You need that radius, which is what was used to calculate, for example, the transit of Venus. The distance to Venus, the distance to the Sun, the distance to the Moon. All of the distances and the orbits are all based on the size of the Earth. So if we have an Earth that's bigger than 8 inch per mile squared, then all the math is wrong. So you have no model. You have no model. You have no way to justify the Earth is 65 million miles away. You have no way to justify any of the distances, any of the sizes of the other planets. Not only that, you don't have any proof that we actually live on a ball. You actually have proof that what we're all witnessing is a flat Earth. And that's what we're witnessing in reality. We don't have an 8 inch per mile squared curvature rate. We don't have any way to detect 66 feet of drop. We can see objects far beyond 10 miles. We can see objects, we have line of sight guns that can shoot up to 100 miles. Line of sight.
That's a good question.
Mm-hmm.
Do you believe that the moon is flat?
Do I believe the moon is flat? I don't try. I'm not trying to believe anything, my friend. The moon.
No.
Better dispel the disc in space misconception.
Yeah, go ahead, T-Dub, if you want to comment on that.
Just be aware that just be aware that we don't think the Earth is a disk in space, like an object amongst other objects in outer space. That's not what we're saying.
Can I ask you now a question? But you ask us, do we see moon do we believe that moon is flat? Is that your question? Hello?
If my question is that the moon is flat?
Okay, let's say you and me sitting outside and watching the moon. I will tell you what I see, then you will tell me what you see, okay? I see this yellow circular thing when it's full. It looks like yellow, sometimes it's red, and it's circular, like a disc. What do you see?
What I see is when the sun hits, I see
the moon.
A ball. What?
The moon.
The moon?
Yeah, when moon is full, what do you see?
A yellow or a grey ball? Yes.
How do you know it's
yellow
a ball?
Like yellow circle? You're saying not the ball.
You believe it's a ball because you were told it's a ball, but you have no way to verify it's a ball. You also have no way to verify that sunlight is hitting the moon.
What I see.
Do you see the ball or the circle?
See a disc. You see a disc in the sky. Be honest. Without any assumptions, you see a disc in the sky.
Let me go look at the wait.
You don't see this moon rotating, do you? You just see the
just quickly. He might be confused that we're claiming the moon is actually a disc, like a flat disc.
No, not that.
Yeah, but that's why if we say we see a disc in the sky, he might think that we're claiming a flat disc in the sky. Just saying.
Yeah.
We're not claiming that.
But I wanted to tell him that we see the same thing, but we are not claiming anything that it's flat. What we see with our eyes, that's it. We don't see the sphere. We see the circular yellow thing. You can call it disc, but it's not disc because you don't know. But it's yellow or red when it's full circle. And you see the same thing.
We don't make any claims to what the moon is. We don't make any claims to what the sun is. Any claims we're making is about empirical evidence you can prove on the Earth.
This is what I'll say. I'll say the moon, right? Whatever the moon is, it doesn't seem to have any resemblance to the Earth, meaning that there's no characteristics of the moon that match the Earth that we're standing on, right? I would consider it more like you're standing on a flat floor and you're seeing a light in the sky, right? That would be a better description of what's going on. We see a light in the sky, it looks circular, we don't know exactly, we can't prove exactly what shape it is. Kind of looks like half a ball to me. Can't tell exactly what it is, right? Don't know how big it is, don't know how far away it is, don't know what medium it resides in, but it doesn't have any characteristics that the Earth has. It's completely different. It's like comparing a chicken to an apple, right? It's just something different. It's the moon and this is the Earth. And if we test the surface of the Earth, over and over again, over huge distances, and there's no curvature, it can't be a ball. It can't be circular, like the moon, like what we're seeing in the sky.
Okay.
Does that make sense?
I understand what you mean.
Yeah. And you understand we're not claiming that Earth is a flat planet, right?
Yes, because the measures doesn't point to flat Earth, right? Right.
Well, we're not. You know what people do, right? Because they've been thinking their whole life that everything is in outer space, right? And the globe is in outer space, and then there's other round planets, and you're standing on a planet. And then when they hear about flat Earth, they try to insert the flat Earth into that concept of outer space. So they usually they think it's like a flat disk instead of a round planet. But that's not what flat earthers claim.
Yeah, outer space is exclusive to the ball Earth theory. If you don't have a ball Earth, none of outer space works. None of the measurements, none of the distances, none of the claims. So you got to throw it all out. No assumptions.
Why they don't agree that the Earth is flat? The government.
Uh,
The government's
tell me?
huge. The government's a whole bunch of different people, right? They have jobs to do. They probably never even thought about that. Most of the people that work at the government probably just went to school like everyone else, and then they got a job at the government, and they believe the Earth's a globe.
No,
and they never tested it.
What? NASA?
What do you mean?
NASA?
What's that? NASA? Did you say NASA?
Yes.
Yeah, same thing. Most people that work at NASA probably believe the Earth is a globe. NASA's not going to space, right? People have different jobs. NASA's just a different division of the government. Okay, so people have specific jobs to do. Whatever the hell NASA does, right? They're not going to the moon. They're not going to space. So whatever the hell people do at NASA, they're just doing their job, and they believe the Earth's a globe. They're not. It's not like you get a job at NASA and they're like, all right, well, the Earth's flat, and we're lying to everyone. Okay, so now you're part of the deception, and we're going to deceive people. No, that's not the way it works.
Works like that. You are working in front of computer, watching some data, and you believing that things what you're seeing on the computer, it's happening in reality in the space or something like that.
Okay.
Yeah, you could fake the moon missions and still believe the Earth's a globe at the same time.
But why they would fake the moon mission?
Why would they fake the moon missions?
Yes.
Oh, well, they were trying to beat Russia. Like, that's the obviously they were trying to make it seem like they're the greatest country in the world that can do what no other country can do, and they're acting like they're competing with Russia in the space race, and and then obviously they faked the moon missions because it's absolutely ridiculous if you actually have a look into it. That doesn't mean you have to believe the Earth's flat. Just, a ton of people know the moon landing was faked and still think the Earth's a globe.
Did Russia say that the Earth is flat?
No, but the head of the Russian space agency said NASA faked the moon landings.
Jesus, at this point, it's kind of irrelevant. I feel like you're skipping a step here. In order to understand the reasoning behind why they, why they believe it's a ball, I feel like that's a step away from what evidence do we have. First of all, we need to decide whether we have evidence. If there is evidence of the ball, direct evidence of the ball, then flat Earth is done. Flat Earth goes away, right? But there is no evidence. So if you want to ask why they lied or why people believe in the ball, well, that's a speculative question, right? That's something that you can come to the conclusion of and start to understand. But first you need to establish whether the Earth is a ball or not.
Okay.
Because it doesn't matter if DJ says it's because of this, or if I say it's because of that, or if Sasha tells you it's because of this. It could be because of all of those reasons put together. It could be because of specifically one of those reasons. Whatever the reason, doesn't matter. Is there evidence that we live on a ball? And if you look into it, there's no evidence. Go ahead, Sasha.
There is good analogy for this. Let's say like this: we have a video that your girl is cheating on you. We have 20 videos, not one, even 1,000 videos that your girl is cheating on you. But you are asking, why would she cheat on me? She is from so good family. Nobody in 100 years, there is giving all good families. She never lied. Something like that.
But I don't do it. I don't do it to complain. I just ask a question.
No, I'm saying what are you asking? You are asking why your girl is cheating on you, and we are showing you the video. Look, there is a video. She's having sex with another man, and you're seeing that, and you're seeing her, and you are saying, yeah, but why would she do that? And then you need to ask her. I think so.
I agree. That's a good analogy. It's like asking for content without context. Before you can understand the content, you need to understand the context first. And the context is the Earth is flat. The context would be, the question would be, is there any evidence that we live on a spinning ball? If the context is set that there is no evidence for that, then the content you can start to decipher and understand. But you're not going to understand the content without first understanding the context. Does that make sense to you?
Yeah, you tell me to understand the context, right?
Before you ask for more content.
Yes.
Because you can misinterpret the content.
Yes.
First of all, nobody knows. Evidence, yeah. Is there any evidence? Yeah, go ahead, Sash.
Nobody knows the answer of your question, because I would like to ask also the same question, but I know the answer. Nobody knows the answer.
Okay.
That's why I'm not asking people, because I know that nobody will give me the answer.
And there's lots of opinions. There's lots of content for you. But it won't make sense without the context that the Earth is measured, treated, and observed as flat. Once you understand that, then the content can be put into perspective. Then you can make your own decisions.
But you can think also...
Lots of logical reasons for why they would do this.
logically, you said also, why would government? Which government was doing good for some people? And you say, okay, this government. We have historical evidence that everybody is complaining about government. I cannot hear. And now, which government is this one? Which you said NASA. NASA is American government. It's not Croatian government. It's not Peru. It's coming from where this space agency is coming from Russia and USA. It's not coming from, Azerbaijan. It's not coming from Nigeria.
But what Russia said about the Earth?
That's very interesting. They have they're saying the same thing. I think they're teaching kids there it's a globe, but they didn't go to the moon. They never tried to go to the moon, and they had better in a time better how to say technology than Americans. But that was strange also.
Yes.
Yes. That's what we know, like a history. But who knows? Is that the truth?
Jesus, we've been sold a story. We've been sold a story, and this model that they've got is not proof of that story. The model that they've got is a backwards engineered piece of math that basically doesn't prove the Earth is curving or spinning. And that's the key point here. There are claims that the Earth is curving and spinning. If there's no evidence that the Earth is curving or spinning, then the model is incorrect. Otherwise, you're just believing a story, a bit like a religion. And human beings, we're suckers for stories. And that's why I think this lie has caught hold so deeply, because it has a good story. It has a model. But that model doesn't reflect reality. It's just a story. You throw in a few wives' tales. You sprinkle on a little bit of math. You hijack perspective. You misinterpret what we're seeing in the sky. And now people think they live on a ball. And you're asking, why does everybody believe it? Because they believe the story. It's got a good story. We're suckers for a good story. But if you apply logic and critical thinking, story doesn't check out. Flat Earth is like a cold, hard lesson in logic and critical thinking. Something most people aren't ready for. The question is, Jesus, if you was to discover the truth, would you want to know it? Some people don't want to handle the truth. Some people don't want to hear the truth.
I want to know the truth. Yes. Hello?
Yeah, that's good. That's good. If you really want to know the truth, eventually you're going to get to the point where you're going to say, right, I want to find evidence. If I'm going to believe this ball, I want the evidence. Direct empirical evidence that we're spinning, that the Earth is curving, that you can have a vacuum in the sky called outer space, that the sun is 95 million miles away. Where is the direct evidence? And if all you can come up with is pre-assumed inferences, you don't have any direct evidence. And that's where you will get to. We all went through the same journey. We all tried to prove this globe at some point. There's not one flat earther who didn't start out without saying, I need to prove this to myself. I need to know this as certainty. In some way, I need some evidence. That's how the journey begins.
Yes.
So go out, get yourself a camera, take some long distance observations. If you can afford it, get a laser. Set up some sort of test, or just do some deep research. Do we have any evidence of the motion of the Earth? Do we have any evidence that the Earth is curving at a rate of 8 inches per mile squared? If so,
SIP laser or what type of laser are you talking about?
A laser, a strong laser. Because a laser will shoot in a horizontal line level to the source, right? So if there's any deviation from level, a very good laser pen would be one way to determine whether you're able to hit a target line of sight further than the 8 inch per mile squared rate of drop, which there should be. If you shoot a laser pen in a horizontal orientation over a lake that's longer than, 6 to 10 miles or about that, there should be deviation from level. Because the Earth is curving at a rate, apparently, of 8 inch per mile squared. So like I said before, over 10 miles, you've got 66 feet of drop. That's a deviation from level. 66 feet of decreasing elevation over distance. Over just 10 miles. Now you can verify there's no curvature that way. You can back that up with other observations. You can learn about refraction. You can look for the consequences of atmospheric conditions, and you can determine what's being claimed doesn't match reality. There's no deviation from level. And water is your key to understanding this, because water doesn't curve. Water is the perfect place to take your observations and tests.
Hello guys, what's up?
Hey, what's up? Welcome to the channel. We're talking about flat Earth. Have you ever looked into it?
So we have flat Earth.
Flat Earth, yeah. Have you ever heard of this topic before?
No.
Okay. Well, the Earth is observed, measured, and treated as a flat, stationary, topographical plane. That's how we treat the Earth. They claim it's a ball.
Sorry, but I don't know what you mean. Can you use more simple words?
The Earth isn't curving. If we live on a ball, the Earth must curve. There's no curving of the Earth. There's no spinning of the Earth. People believe there is.
Oh.
People believe we live on a spinning ball, but there's no evidence for that.
Okay. So.
No evidence. Do you find that hard to believe?
I think so.
Right. As you should. You were taught that the Earth is a spinning ball, and that everybody knows this to be true. But if you try and find the curving, or you try and find the spinning motion on the Earth, it's impossible. There's no curving, no curvature, and there's no spinning, there's no motion to be found anywhere on the Earth. The Earth is treated as if it's flat. In every industry. Is it so hard to believe?
Isn't that funny, Roots, like that question? It really shouldn't be that hard to believe since that's exactly how we experience it. But the indoctrination makes it hard to believe. It actually only exists in the mind. So just like the last guy you were telling him, you need to go out and test this for yourself. Is the Earth actually the way that you experience it? You know, horizontal and such, and not moving. It's a weird time to be alive.
Yeah. It's like people don't want the truth to get in the way of a good story, right?
Exactly.
What we're dealing with is a cult, a religion. A cult. A cult is a group that has special knowledge that can only be verified by them, and everybody else has to believe it. They would have you believe flat Earth is a cult, when in reality, flat Earth is all what you live on. It's all around you. It's reality. When in actual fact, the globe religion is a cult. It's culture. It's a story that cannot be verified by anybody apart from NASA, apparently. Apart from an authority that we have no access to. It's part of the definition of a cult. Or a religion, if you don't know what a cult is.
Laying it down, Roots. Good man.
Yes, sir. Just trying to get some engagement.
Yeah, they can take some cajoling. Their minds are so blown, they don't know what to think. It's like they get an ice bath when they come in here.
I mean, I get how stressful it is, right? I understand that, but I mean, you know, in the pursuit of truth, there should be more questions, right?
Yeah, I found that weird at first as well. Like, why isn't everyone as curious as I was? I was like, I need to know now. But loads of folk are like, nah, who cares? Why does it matter? Or just dumbstruck silence.
It's easier to be told what the answer is, right, than it is to find it for yourself. So in some ways, it's just a nice way of passing off responsibility. Oh, well, I don't want to find out for myself. I'll just let someone else tell me what my paradigm is.
Yeah, that's why when I'm just talking to them, I'll oftentimes just tell them what it is, along with asking them the questions to make them think about it. Just tell them straight up, no, this is what it is. Like, oftentimes I think if you dive straight into like a long distance observation, it just goes way over their head. They can't even contextualize it. I think sometimes you've got to deal with the disk in space question. You've got to give them something to stand on, to then think about. Because like, we rip the ball away from them and they don't know where they are now. You rip space away from them, they doubly don't know where they are. So when you then go and try and explain the world to them, they're so caught up in that floating in nothingness that they can't really take on what you're saying. So I find it's often useful just to actually describe, well, what we seem to have evidence for is a motionless topographical plane that's contained. So it's more like you're in a giant building. You almost give them some context for what they are seeing, a different context, a different way of thinking about their observations. Because oftentimes I feel like we'll dive straight into some hardcore evidence, like long distance observations, and they're just like, they can even acknowledge, yeah, there's no curve there, that's flat water, but they can't apply that to the overall point that we're making. They're like, yeah, it's still a globe. Like, they don't have that foundation to understand where we're even coming from.
Right, because it's almost like because you said a different way to think about it. Well, it's almost like you don't have to think about it, right? Just look at it, see what do you see? See it flat. What's to think about?
Yeah, I mean, oftentimes I'll have a conversation with someone, and I'll get them interested in the subject to look into it, and I've not even presented them any evidence. I've not even spoken about long distance observations or the nature of water. I've just asked them about what they think they know about the Earth, and then to consider what they actually experience. And just to propose, well, it could be like this. And they'll be like, some of them will be like, all right, okay, interesting, good points, I'll look into it. And I've not even really presented any evidence for flat Earth, which I think is quite interesting. It speaks to the way the human mind works. And it can sound a bit like, we're not trying to sell a narrative here, but in a way, we are narrative-driven creatures. And it can help, actually, a lot of people understand this whole topic if we do give them some of that narrative, some of the history, an attempt at describing what this system might be, so they have a place to sit and think about it. I don't know, it's just something I've been thinking about the last little while.
I was talking to my son the other day because he was listening to me talk on here. He couldn't hear the other people, but he could hear me. And like, I had to mute up because he started asking me questions. And he said, well, who was it? Where do we get this idea that we're on a ball from? Like, who was it? Who was it in history, right? And I went, oh, well, the Greeks suggested it, but that didn't take off, right? It was like around the 16th century, right? Like, and then I'm like, hang on a second. Who is attributed with that, like, having said it, we live on a ball? Like, in relatively recent times, like, not thousands of years ago, but like hundreds of years ago. Who was it?
Yeah, that's it. I mean, even just trying to untangle the history aspect of this subject could be a lifelong task. I mean, we've got a lot of untangling to do. I think that's another way I think about it when we're talking to new people. Their ideas and their thoughts, the globe model, it's a huge tangle of ideas, and you've almost got to untangle all these preconceptions and these notions before you can even start to have the conversation about where do we actually live. because you're just trained to think so illogically based on your preconceptions about what's in the sky and what the luminaries are, gravity, all this stuff. It's like cemented in the indoctrination. I mean, even the language anchors the story. So when they're talking about the atmosphere and gravity, they just inherently summon a globe. You've got to almost like untangle all that word magic. Because, you know, that's the basis of how human beings are communicating and thinking, is saying the words which are conjuring an image in the mind. And when we use the words to conjure a specific image of a globe, that really cements itself in the person's psyche.
Right. Because like at first people come in and like some people, right, they come in and they're just laughing instantly. Ha, you idiots! We have pictures from space. When we demonstrate how that's a weak argument, right? Then they start thinking and they go, and then they're like, well, if they don't just spiral out then and there and leave, like they're like thinking, hang on a second. Well, okay, well, how does night and day work then, right? Then they start sort of thinking, right? But,
yeah, that's it.
Why would they lie about pictures in space, right?
Yeah, exactly. I mean, just one point we make, one pushback on a point like that can open up 100 questions, especially if you've never even stopped to really consider this whole topic. You're totally green in it. Yeah, I mean, you can spend hours on just one point like that if they really want to get into it.
T-Dub, I would say it was in modern times. I would say it'd be Copernicus, right? Because didn't he write?
Was it? Was it?
Well, that's the mainstream narrative, right?
I don't think so. He just proposed that the Earth's in the center. Right. He just proposed that the ball Earth is not in the center.
So they say the first globe was made in the 1400s, right?
Right.
Late
So who was it?
1400s.
Is there a name attached?
Was it some Dutch or
Or did
German
it just
guy?
sort of sneak in?
But then he obviously got it from somewhere more recently than the ancient Greeks, who they generally attribute it to.
Right.
I see what
Because
you mean.
he got me questioning. He got me thinking about it. I'm like, hang on a second. Was it Copernicus? Didn't they already sort of like? Wasn't the idea that it was already wasn't it already getting thrown around? We're on a ball. And Copernicus went,
the
we're on a
ball
ball.
was around.
Right. So like Copernicus was like, we're on a ball, but we're not in the center.
And it's an underrated part of the subject to focus on, right? Because it's sort of like a philosophical colonialism that took place with this idea of a Renaissance and an Enlightenment, where the West developed this doctrine of a globe Earth, which is sold as a discovery and makes them scientifically more advanced or more astute than the rest of the world. Therefore, they inherit this position of superiority. And it's like, just a Western philosophy that's been used in a colonial manner. Maybe the spreading of the church philosophies from traveling Jesuit priests, trying to get into places like Japan and that. I mean, the church owned the education, essentially, for a time. So they had a big hand in it. But yeah, as it goes to singular people, it's kind of hard to pin down the exact thread.
Well, there isn't anybody. The only people before Copernicus were all in the BC era, except for probably Ptolemy, right? Ptolemy was just after the BC era. There isn't anybody you can pin down before Copernicus unless you go to the BC era.
Right, but there's images, like there's paintings of like globes before Copernicus. I'm sure there is, like from the 1400s.
Yeah, but that didn't mean that they thought people lived on top of them.
Right.
Because the world was seen as spherical, but you were inside, potentially on a flat plane, inside of that thing.
Well, look into the first globe Earth, the first globe that was made, the physical globe. They say that's like the 1490s or something like that, don't they? Or earlier? 1400.
I'm thinking, yeah, late 15th century. Yeah.
Yeah, but that was when Copernicus lived, right? 14 to the 1500s.
Well, that's what I was going to see. What's the exact time in comparison of that? Is that globe contemporary with Copernicus's life, or is it just before, or is it just after? Because I know they're in the same ballpark, but
Copernicus,
off the top of my head.
From what I can remember, Copernicus was born right at the end of the 1400s and lived till the mid 1500s. So he lived
Right. So then, if that's the case, and it's a late 1400s globe, then that would mean they were depicting the globe when Copernicus was a child, before he'd put his calendar to the church.
Right. So just snuck in, like.
Well, it will have been a group of elite intellectuals and maybe fragments of royals supporting elites and all this kind of thing that we're proposing. I mean, you read the writings of Leonardo da Vinci, and he's talking about a globe.
Right.
Right.
And
Yeah. That's what you guys are
contemporary in
talking about.
China. In China, there were two competing philosophies on whether Earth was flat or a globe for a while too. This is going back like 1,000 years.
But there is a bit of a gray area, we're saying, between the ancient Greeks and like Renaissance Europe, like 2,000 years. Like, who was carrying the torch?
I point to one of these interesting books from the Dark Ages by Cosmas Indicopleustes, the Alexandrian bishop who used to be a trader and traveled all over the world, sailed everywhere. He wrote an encyclopedia called Christian Topography, and it's hundreds and hundreds and hundreds of pages. This was written in the late 400s, and it's not like there's only one copy in existence. There are multiple copies found all over. I think it's in Greek. So, I mean, it makes a pretty strong case that it was written when they said it was written, given that. But he devoted a big part of this book, when he surveyed the known extent of Christianity at the time, he devoted a big part of it to refuting what he called the globe earth heresy that was creeping into modern church ideas back in the late 400s.
Yeah. So
the weird thing is, where's the evidence of that? Like, I want to find what sources he was leaning on or recalling in order to state that this globe heresy was starting to become more popularized within the church back then.
Yeah, and you've got people in the Reformation and Martin Luther and things like that making reference to at least heliocentrism, if not the globe directly, and that being a point of disagreement and conflicting with the scriptures.
Yeah, Martin Luther was a flat earther for sure. That's 1,000 years after Cosmas Indicopleustes. If there is 1,000 years between the two.
So it seems that there's a few individuals who made claims for it to be a sphere, but it just wasn't accepted. It was shut down. It's almost like they were trying to introduce this for a very long time, but they had to work their way into the church, right? And it wasn't until it was adopted by the church that it could actually, become a story people would accept. So I think that's why Copernicus gets the credit, because he's the one who introduced it to the church. Before that, you've got a bunch of people trying to push it, but it was just being rejected. logically inconsistent.
Yeah, and the way I remember hearing it was that Copernicus was very reluctant to come out with his calendar or the heliocentric calendar, and that the church had to convince him and help him get it published. I don't know how true that is.
Well, before Copernicus, wasn't it the people push like Ptolemy and whatnot pushing the geocentric model, and then Copernicus came along in the 1500s, didn't he? And he was the one that suggested that he said that it's spinning and all of that kind of thing.
Well, if I can point to one thing, I tried to find the origin of this too. There were 3 Babylonian astronomers. I forgot their names. You can probably use AI and get their names. But they're kind of responsible for teaching the Greeks astronomy. 2 of them were globe earthers and one of them was a flat earther. Not even joking. And this is like 800 BC.
(800 BC).
Yeah.
So that's before ancient Greece. Babylonia,
Yeah,
you said, yeah, okay.
Yep.
I mean, if the story's true, right? It feels to me like all of the ancient Greeks they quote, we have no evidence for, you know what I mean? Like the whole thing could just be made up. These individuals could just be made up to add credibility to the claim, right?
Perplexity AI is telling me there isn't a single universally agreed upon name that can be attributed to the moment the spherical Earth became widely accepted in the modern Western world. It's just it's just explaining it as a gradual ideology, like that just that slowly gains traction, starting with the ancient Greeks, leading up to now.
Exactly. From what I've gathered looking into it, it was like conceptualized based off the way that we view the sky. Basically, it came from the as above, so below. And they envisioned the heavens as a perfect sphere, and through philosophical grounds, they figured that the Earth must also be perfect, right? And that the Earth is also a sphere. So they kind of inverted the celestial sphere into the terrestrial sphere. It's not like people went out one day and did some measurements and they're like, oh shit, we've been wrong for thousands of years, guys. We've gone out and measured the water and actually it's a globe. Like, here's our results. You can go check for yourself too. This is what we did. No one ever did that. And they didn't even claim to have done that.
Yeah, no, exactly. It makes sense that there's no individual it's attributed to because it's never been a discovery, where discoveries are attributed to singular people at times. But this isn't, because it's just a philosophy. But I think even then, what I was getting at was just, if you could trace a thread from the very beginning all the way to modern day, what groups of people would it pass through and be passed on by? Like, if you had that exact view.
Yep. Well, Perplexity says, in summary, there is no one specific name to attribute the global acceptance of Earth's sphericity to. It was a process led by figures like Magellan, Elcano, and Copernicus, but not a single discoverer, like you just said. And it's put it in quotation marks, discoverer, or, in quotation marks, declarer.
Yeah. This is what I have written down. It kind of, you know how you look at all the ancient depictions of the Earth and it's like a flat plane inside a contained system, and the sky looks like all the stars and everything are on a dome or a container or a celestial sphere, whatever you want to call it. All the stars are in like a dome shape in the sky. So what I have written down is that the Greeks, Egyptians, Babylonians, and early Indian astronomers all described the sky as a dome or sphere revolving around a stationary Earth. And then later on, these philosophers came along, such as Pythagoras, Plato, Aristotle, and they took the symmetry of the celestial sphere and imposed it onto the Earth itself. They reasoned that the heavens appeared spherical and perfect, The Earth beneath must also be spherical, not because of empirical proof, but to maintain philosophical symmetry between the above and the below.
And that's where
Yeah, I
the
think that's pretty
16:1
accurate.
ratio comes in.
And just the Pythagoreans worshipping geometry and seeing the universe as being created in perfect geometry. That totally makes sense. So that's, yeah, a very plausible beginning point. But then tracing
Can you
it
research for me these Babylonian astronomers, if you don't mind? I didn't mean to cut you off. I'm driving. I might be lag. Sorry, Cyclone.
No, you're all right.
Nah.
No, I'm just saying this is a good endeavor. Try and trace it from point to point. I think DJ's on it in terms of the origins of it.
Yeah, I got a whole write-up on here, and all the way up to today, how it kind of like, warped from the ancient culture's way of looking at the sky, and then later philosophers turning that conceptual way of, assuming the sky is like a perfect sphere, and then they sort of turned that into a coordinate system, and eventually inverted that onto the Earth, and then it spiraled from there. Literally after Copernicus came along.
Yeah. Well, no, this is a good thread, guys. So unless there's some new people that want to ask questions or get involved, I'd like to hear some more continuation on this. But anyway, I'm going to have to drop off. But I'll be listening on YouTube, so good to hear you guys. Stay
Yeah, you
flat.
too, man. Good to see
Thank you, Cyclone. The reason why I'm pulling the Babylonian thread is because they wrote every freaking thing down. And this is a thread that I didn't pull completely, and it'd be interesting to see if we can pull it any further from here.
So what do you think 2026 is going to bring? Flat Earth, Indio? Is it going to be anything new? Is it going to be the old stuff? What's going on?
I don't know. It's a good question. I mean, I know what I'm trying to do, like me personally, and I have to work on this, get some of the, trying to get observations together, just get like as many as we can get, like long distance observations, just pile them up. Pile them up, pile them up, pile them up. I actually, interesting enough, because just looking at a lot of the observations that have already been done, and the globe Earth has a whole slew of claims about what refraction does to the horizon and objects and all these things. That just doesn't seem to match what's actually observed in these long distance observations. It just doesn't seem to line up. Like, oh, if there's an inferior mirage, and this is warmer and that's colder, and then if it's a superior mirage, it's the other way around. Like, it just doesn't seem to actually be the case. That it's way more complicated. And yeah, so I think this year should be the year of data collection. Because I also just, by some serendipity, it was called a paper that was published in, I think, 2023, where they went out and they did some surveying, and they assumed like this curving right thing, and then they actually, this K constant, right, this radius of a ray that goes around the ball Earth. Well, when they actually went out and did the measurements, they had to conclude that there was upward refraction if there's a ball Earth, which just basically means that we assumed it's a ball, and and the ray was actually flat, so it must be concave. You know what I mean? Because you're in a coordinate system. Yeah, so like flat lines are concave in their little in their paradigm, right? So that's what they actually went out and measured, and they had thermocouples, and they measured all this stuff. And it's just funny that, you know, this claim of this downward refraction, I just don't think it has any evidence for it. I just don't think it's like the textbook, whatever's in the textbook that says it's wrong. It's just wrong. Like what they say creates inferior mirages is wrong. What they say creates superior mirages, wrong. Fata Morgana is wrong. You know, all this stuff. I just think it's all wrong. And I don't think it's actually been thoroughly researched. If you the literature, the academic literature is relative to like what it is, it's pretty sparse, right? It's like, I mean, I would say in the last 150 years, there may be, maybe 150 papers on the subject of like terrestrial refraction, astronomical refraction, whatever you want to call it. Maybe 150 papers worldwide. But everybody goes out every single day. Surveyors go out every single day. We're always doing these observations at sea, in the sky, right? We're flying around, we're sailing around, we're doing all these things. To be not like have so much literature, so much testing on it, like that, like that your brain would explode from looking at all the data. It just seems a little odd to me that how little there is. And the papers all say the same thing. Yeah, we went in with these assumptions, nothing actually matched up. Shit, try again. This is what people that do future research should consider, and they give like a laundry list of things, of possibilities, and that's it. There's very few. There's not that much out there as far as evidence. There's a lot of claims, there's a lot of theory, there's a lot of textbook nonsense, there's, 7/6R and all that crap. But when you look into the actual experimental data, that's just like, where is it? So, like, as God says, you want something, or, heaven helps those who help themselves, and if you want it done right, do it yourself. In the vein of that, those two things, we'll do those things. That's what I'm hoping. And I'm trying to get, I think I'm going to we talked about this. I talked about this with like Yoder. We should get like a standardized form, right? Make a form that if you go out and do a long distance observation, like a checklist, hey, get the water temperature, get the air temperature, put the camera in the shade, don't have it in the sun, don't go at this time of day, or if you go at that time of day, like, best practices document.
Yeah.
Right.
Where's
that
the sun
anybody
in the
can
sky, that type of thing.
Yeah. Yeah. Best practices document. So one thing I try to do is I try to get the sun behind me so that everything is lit up. Right.
Yeah. Yeah.
So there's like, there's just like, we can come up with some best practices, and part of those best practices will have some data, and that, like, if everybody's collecting the same data, then we can actually go, okay, here's a 10-mile observation. This is the air temperature, water temperature, humidity, all these things. We just plug it into a spreadsheet, and then we collect a whole bunch of it, right? And then like, oh yeah, I filled out the sheet. Here you go. Collect the data off of it. Just keep adding it to like a giant spreadsheet, and go try to find some correlation between observation, between variables, right? The temperature, the water temperature, like the difference in that. Like, what is that? How does that look? Do I see longer? Do I see shorter? Like, what happens there? So, you know what I mean? We could like actually start collecting actual data, because they're not going to do it, apparently.
Sounds like a really good idea. He told me they got a new Matrix has got a new camera. He's talking about going out and doing observations. Apparently, he's getting the camera converted to infrared. In the next few weeks or so. But I know he's doing that. DJ would be a great person as well.
Yoder's got one. DJ's got a camera. Yeah. But there's also all these YouTubers that are already doing these observations every day. There's a guy named Ron Hasberg. There's A Plain Truth. There's Sky Free. There's who is the other one? Pablo's Dog. There's Keith Carmody. So these guys have consistently for couple of years. I know about all their channels, and like nobody watched, like barely anybody. So they have a video, they get like 50 or 60 views maybe. And it's like, this is like the important stuff, the actual observations. This is like the most important thing that people should be paying attention to. Instead, they'll go listen to fucking Jeranism, talk bullshit about fucking who knows what. You know what I mean?
Yeah.
Instead of actually paying attention to what. That's why I made them leaky, right? Because like we're sitting here arguing with these guys about all their ideas and theories. Like, why are we arguing about ideas and theories? Newton said, you know, if it can't be settled by experiment, it's not worthy of debate, right? So let's just settle it by experiment and stop talking about it.
Yeah. No, I agree, man. That's awesome. It's probably the exact.
Yeah, speaking about channels that get too many views. The one guy make that video about the Blackpool picture. In 6 months gets 90,000 views. Whereas any video that debunks the globe, you're lucky if you get 30,000 views.
Are you serious?
Yeah.
Wow. Well, there's always what's his name? Simon Dan. He went from like 1,000 subs, like over like 8 years or something, whatever, however long, and then just like Mr. Cheswick did a video on it. Yeah, some freaking. He got like 12,000 subs in like a week, and it wasn't linked to like any particular video.
So same with Dave McKeegan, because his channel, which was on photography, he was lucky if he got like 5,000 views on a video. He had like one video that went viral that got over 1 million views, but his average views were like 5,000. But now if you look at his anti-flat earth videos, they pretty much, a lot of them have over 1 million views.
You're kidding me. Wow. Dude, his content is horrible too.
I think people watch it for his dog. I don't think they watch it for him.
Yeah, like even his presentation style is just lame. He's not charismatic. He's like anti-charismatic. That's what I don't understand is like how do non-charismatic people get a bunch of views? You know, like McToon, Simon Dan, Professor Dave McKeegan. They're like anti-charismatic. In fact, like looking at them and hearing them speak is like fingernails on a chalkboard. Doesn't even matter what they say. They could be talking about anything. The title says, "Caused people to leave flat Earth," and then he named Ranty.
Yeah.
I mean, caused person to leave flat Earth. It's probably the clickbait title. And people are clicking on it going, oh, it's definitive proof against flat Earth, and it's just trash.
Yeah, doesn't understand that objects in the distance may not be actual size.
Yeah, amazing. Weird. It's weird how the street sign that's 10 feet away is bigger than that mountain 120 miles away. It's higher. It's not in the same line of sight. Why is that? It's so stupid, bro. I mean, just from an objective analytic viewpoint, without even considering what the topic is, Globe Earther videos are trash. They're absolute trash, just as far as like from a rigorous, objective analysis of like the numbers and the assumptions and the measurements and like what they're saying is it's just such trash, dude. They don't even get like even the mainstream stuff right half the time.
Well, ignorance is their superpower.
Yeah, but it's a collective ignorance. That's the problem. That's the thing I don't like is that it's collective. It's like, you know, you got the confirmation bias of like the average, someone just come across the video and then they actually internalize and believe what's being said on the screen. I love it when they're talking, right? And they're saying stuff is being observed in what they're showing on the screen and it doesn't actually show that. It's like saying, hey, this dude just scored a running touchdown when it was clearly a pass. But because they're saying he scored a running touchdown, people think it actually was.
Well, there's a lot of misinformation out there. Like, look, even at the Hindenburg, most people think the Hindenburg burned because it was filled with hydrogen. Nope. Hindenburg burned because the material they used for the envelope there was highly flammable, and it burned up like crazy.
Wasn't it painted with like some highly flammable paint or something?
Well, whatever method they used to make that fabric, which was made in the United States, it was imported from the U.S., made it highly flammable. It's almost as if somebody in the United States didn't want the Zeppelins to be effective because it would ruin their ocean liner business.
Yeah, that could be it.
Because it took 7 days to cross the Atlantic by ocean liner. It took 48 hours by Zeppelin. And there was no seasickness.
How many could the Zeppelin carry? Like 20 people, 30 people?
Let me just see. I think it was a fair amount of people.
Yeah, I don't know what the business model was, whether it was profitable or not. But I mean, there's almost no limit on how big you can make them. Depends on the material.
Yeah.
The material cost, right? I mean, it almost don't matter because though you're increasing the surface area, right? The volume is increasing at a higher rate. Right?
Exactly.
Is that how it works?
Yeah. You increase the diameter a small amount and you get a good amount of volume increase. Maximum 70 people on the Hindenburg. On the fatal flight.
That's a good amount of people, man. That's almost as much as like a, I don't know, like a small plane, not a small plane, but like a regional airlines.
Yeah, like a
seating
DC-3.
capacity. Yeah.
Yeah, the final flight had 36 passengers, 61 crew.
61 crew?
Yeah.
Jesus Christ.
So it says at peak, the Hindenburg could carry up to 72 paying passengers plus crew for a total of over 100 people on board when fully loaded.
That's why tickets are expensive.
Well, first class tickets on the Titanic were expensive. You didn't even reach your location.
Well, if you're intending to go to the bottom of the ocean, you did.
About to read their Yelp review.
Well, probably the only positive thing is the swimming pools are still working. Yeah, the deluxe suites on the Titanic were between 100 to 300 pounds. The biggest Sweets, 870 pounds. That's about $4,350 in 1912, and today that's probably close to almost $200,000.
I mean, we're assuming a lot of stuff that they couldn't improve design over a period of like 100 years. I mean, I'm sure if we stayed with the airship thing, they'd be pretty freaking crazy right now.
Aren't they called planes, bro?
No, I'm talking about we're talking about blimps like the Hindenburg.
Oh.
They were called airships.
Someone made a proposal to use blimps to carry cargo fast over the ocean between the continents. They said they would be far cheaper than aircraft and certainly faster than going the slow boats.
Seems to be kind of hard because I feel like you're going to be affected by the winds a lot, especially with the seas. You're going to have very rough currents.
So, just a side note, has nothing to do with what we're talking about. I mean, Yoder, in the main server in the refraction section, I added PDF. You might want to check it out. You too, Rayleigh. You probably want to check it out. So they did a bunch of surveying, and they, according to their little K constant, they ended up measuring concave refraction or something. So yeah, it's pretty cool. It's interesting.
Oh, I think I could predict why. It's because curvature throws off what their meteorological requirements are. It almost inverts it. Actually, I think it does invert it.
Well, yeah. Well, if you're assuming a curved surface, something that's flat is going to appear concave and note that coordinates.
Precisely. Yep. Yeah, that's it. So that means like a K coefficient of 1, which normally is what a flat would actually be curving. So they'd have to recalibrate their K coefficient and K factor, I guess, depending on the industry.
Yeah, I mean, if you read through it, it seems like they're pretty bullshit about the result, like kind of like waffling, especially in the conclusions. Kind of funny.
Oh, can't wait! I'll be doing that this afternoon.
All right, it's in the refraction section, in the information channel or category. I gotta bounce. I gotta actually do something productive today other than sit on Discord and drink coffee. So I'm gonna do something else and drink
Nobody
coffee.
has to know. All right, see.
Sorry to hear that, India.
Sorry, did I have to do something productive?
Yep.
I'm dicking around for like 3 days, so I mean, I don't have to do it, but I should. This isn't a must, but you know.
I did something productive yesterday. I regret it today.
All right, I'll talk to you later.
Yep.
Bye.
Peace, man.
And I always find it funny how all these Globers talk about the K factor for refraction. Never seen them ever mention the T factor for transmission. And if you're wondering what the T factor is, that's the limit of how far light can travel through the atmosphere, especially weak light like reflected light.
It can be a bit confusing when you read about this subject from different disciplines, because like the K factor that's used in it's used to describe like terrestrial refraction and stuff. A K factor of 1 indicates a regular globe Earth with a regular radius, and anything that's above that, like 7/6 or 4/3, is making a bigger radius. So as that number gets bigger, it gets flatter. But the K coefficient is different, and you'll see this in like a surveying literature. They won't show anything with respect to like a 1. They'll show you like 0.13 or 0.27. And the higher the number, the flatter it is. But it's not the same. Like, it's not just like subtract 1. I forgot how it works. I'm going to have to look at some notes I took on this. Yeah, because a K coefficient of 1.00 is an infinite radius. That's what it is. But a K factor of 1 is a regular globe radius. Now we have, what, T factor to contend with?
Yeah, this T factor is something that I just recently looked into, and tells you how far a light can be seen through the atmosphere. And for the most part, reflected light, the maximum is kind of like 100 kilometers.
And that's for reflected light, not. I guess that kind of makes sense in a way.
Yeah.
But would that apply to a mirror, like a mirror flash of a sun?
Yeah, I would assume not so much for mirrors, since the albedo of mirrors are very high, so they reflect a lot of the light. But the silly thing is that these globers who think I'll be able to see trees at 40, 50 kilometers. No, trees are good at absorbing light. That's how plants grow. The only light they reject is the green light, so they don't dry out and turn into prunes. But their irregular shapes of the leaves also diminishes how much light reflects off the trees. So no, you're not going to see them over great distances.
That's how.
You're watching 24/7 Flat Earth Discord live.